Sketching is a fundamental part of modeling in SolidWorks, so it is important to understand how to create a sketch. In this lesson, I'll show how to create a sketch on a plane and also how to create a sketch on the face of a part. Sketching in SolidWorks is when you create a 2D profile, which can be created using sketch entities such as lines, rectangles, arcs, circles, and ellipses. With SolidWorks open, the first thing we need to do is create a new part file. You can do this in a few ways. The first is to go to the File and then New. When you do this, you'll see a template window pop up and you'll select the part and go OK. There's also two other ways you could do this. If I close this new document, we could also just go to the new icon up the top here, or we could use the hotkey, which is Control-N, making sure the part template is selected and then going OK. Once the document has loaded, we're ready to create our sketch. In a new part file, you'll notice there are actually three default planes that we could begin a sketch from. These are the front, top, and right plane. Currently, they're invisible, but you can make them visible if it's easier to get your orientation in the 3D environment. You can do this by clicking on the front plane in the Feature Manager area, which is this left area here. So you can click on it and going to the little show icon in the contextual menu that pops out. So we could do this for all three planes to show them and make them more visible. In this case, I don't need the right plane and the top plane, so I'm just going to go back and hide these. Just quickly as well, this may be your first time looking at SolidWorks, so I'm just going to show you quickly how to move around the 3D environment. The first thing is if you hold the middle mouse button and move your mouse around, it will rotate the 3D environment. If you hold down Control and the middle mouse button and move the mouse, it will pan the 3D environment. If you scroll on the mouse wheel, it will zoom in and out. And finally, if you hold down Shift and middle mouse button and then move your mouse, it will zoom in and out, but at a more precise kind of increment. Finally, up the top here, you can also change to say front, top, or isometric views by clicking on the drop down. And we actually want a isometric view, so we can click on it here. Another way of doing that is using hotkeys. So it's much quicker to learn to use hotkeys. So I recommend you sort of get familiar with them. So if we wanted to go, we maybe have rotated our part, we can actually click on Control-7 to go back to a isometric view. So to begin a sketch, we can either do this in two ways. You could either click on the plane and then click on the sketch tool, or you could click on the sketch tool and then select the plane. In this case, we're just going to click on the front plane and go to sketch. You'll notice that when you start a sketch, it will actually rotate your view and face your orientation to be directly towards the sketch, just to make it a little easier to understand what's going on. You can also tell that you're in the sketching environment because you'll see these two buttons in the top right-hand corner. The red cross is to exit the sketch without saving anything, and the kind of backwards arrow is to exit the sketch but save the changes. So just always be aware of which one you're actually clicking. What we're going to do is just draw a simple rectangle to begin with. So by making sure the sketch tab is highlighted or activated, we will go to the center rectangle. And if you don't see rectangle or center rectangle, just use this drop down and then pick center rectangle. Bring it over to the middle point of the sketch and you'll notice a little snap icon highlight. So we'll click on that center and we're just going to drag it out to a random size. It doesn't matter. We're going to say OK to that, and then we want to exit our sketch, making sure we click the backwards icon, exit. So now you can see we have created a simple rectangle on the front plane. What if you want to edit the sketch? Well, that's easy to do. You simply go over to your Feature Manager, click on the sketch, and in the contextual menu, you can go to Edit Sketch. So if you need to add a dimension or change some sort of constraints or something, that's how you do that. And let's just say we want it to be a little bit more of a rectangle shape. So we can just drag the point down in this case, clicking OK, and then exiting the sketch. So you can see the change is being made that way. You can also delete a sketch if you really need to by right-clicking on it and then going to delete, but we don't want to do that. You can also create a sketch on the surface of an object. What we can do is actually use the rectangle we've created already, extrude it to give it a bit of volume, and then sketch on one of the surfaces of it. So what we want to do here is click on our Features menu and click on Extrude Boss Base. It will ask us to pick a sketch to extrude, and we can just pick one of the lines. And we're just going to accept the default here. So make sure it's set to blind and 10 millimeters. Click on OK, and you can see we now have an extruded rectangle. We also don't need this front plane anymore, so we're going to actually hide that. Clicking on the front plane, clicking on the hide, and now we just have our rectangle. We want to create a circle and then cut the circle through the middle of this rectangle. With our rectangle now extruded and it has some volume, we can now show you how to create a sketch on one of the surfaces. You can do this a couple of ways. You can click on the face you want to create the sketch on, and then going back to our sketch tools and clicking on the sketch. But you'll also notice that when I clicked on that face, another little contextual menu pops out. Now this can be edited and it may not be the same as what you see, and I'll show you how to edit this UI in another video. With our rectangle now extruded, we have a bit of volume to work with. And what we can do is actually pick one of the faces of this object and create a sketch on it. So to do that, we can click on the face we want to create the sketch on, and then going back to our sketch tools, click on sketch. Again, you'll notice that the view rotates to face it front on. And what we're going to do is draw a circle in the center. So using our center sketching entity, circle sketching entity, pick the middle point, drag it out, and we're just going to make it that big. Clicking OK, and then exiting the sketch. Control 7 to go back to an isometric view, and you can see this circle is now sketched on the face of that rectangle. The sketch is also highlighted at the moment, so if we just click off into empty space, it will deactivate that selection. We can now punch this hole through the rectangle by cutting. So if we go to the features and clicking on extruded cut, it will ask us to select a sketch, which we can pick that circle we just drew, and we'll just use the default settings here. So blind 10 millimeters, click OK, and you can now see the hole has been punched through the rectangle. So that's how you create sketches in SolidWorks. It's important you understand this step before proceeding, because everything you do in SolidWorks will usually involve creating a sketch, drawing a 2D profile, and then manipulating it in some way, such as extruding or cutting or revolving that profile. So if you can at least get the basics of creating the sketch and using the sketch entities to draw the shapes that you require, you'll be on a good start. In the next video, we will discuss sketch relations and sketch dimensions. In this lesson, we'll take a look at sketch relations, which are used to force behavior on sketched elements, and also look at how to add dimensions to your sketches. A quick note to make here is that sketch relations can only be done in the actual sketch environment. So I have a sketch created here with a couple of lines, but we actually need to go in and edit the sketch before we can start setting relations. So the first relation we're going to look at is the coincident relation. And this is just when you have 2 points coincide with each other. So we may want this endpoint of the line to coincide with this line. So it's always kind of following this line at some point. And another tip we can have a look at here is actually when you're selecting multiple things in SolidWorks is you can do that by holding down the control button. So the first thing we want is to actually select this first line, and then we're going to hold down control and click this endpoint. I didn't get a chance, but I'll show you in a sec the little menu that pops out. But basically, if you don't see the menu, you'll always have your relations available on the left-hand side here. So you can actually see a few options: midpoint, coincident, and fix. We actually want the coincident relation. So you can just click on that and you can see that it's now moved over to be coincidental to that line. We can click the OK dialog button here, but you can just push escape as well. So if I now move this point around, you'll see that it coincides on that line. Or if I was to drag this mouse or this line around, you'll see that line, that point coincides. In the current view, we can't see what relations are available on the screen without actually clicking on the lines. And then these little icons that you'll see dotted around will actually represent what sort of relation is in place. But you can also, if you don't see any, you can go to this show hide items up the top here, drop that down, and you'll be looking for the relations, which is view sketch relations. So it's this kind of perpendicular looking icon. So this way you can always see relations available. We'll just leave it on for this lesson. If we want to delete a sketch relation, you could either undo, but maybe you don't have the option available to undo, so you can simply delete them. You can do this by either clicking on the icon for the sketch relation and just hitting the delete key. Or if I undo that, you can actually just right click on that sketch relation icon and then delete. And now with that deleted, you can see I can now move this item around again. Another sketch relation we can use is actually the merge sketch relation. If we again hold down Control so we can select multiple objects, and we'll pick this endpoint and this endpoint. I let go of Control. This time we actually see the little menu pop up, and here you'll see all your sketch relations that are available. We are looking for the merge points, which is this kind of merge point looking, or you could actually just pick over here as well if the menu happens to disappear because you move your mouse or something. So if I show you again quickly, hold down Control, pick those 2 points, release Control, the menu pops up, and we can just go to merge point. So that's the quickest way of, instead of having to go over to the side all the time, or in case the menu disappears. So with merge points coincident, you can now see that this will always merge together and follow that point around. The next relation we can look at is parallel relations. So that is when you have 2 lines that are always following the same angle together. Holding down Control key, we will select these 2 lines. Another way to do it, if you don't have a lot of objects on the screen, is to just drag across those 2 items. If you drag from the from the left to the right, then anything inside the box will be selected. So in this case, you'll see the top line is selected, but not the bottom line. So if you drag left to right, you actually have to cover all the objects you want to select. If you drag right to left, it will actually select whatever the bounding box covers. So we can just quickly select these without having to hold Control. Is just right to left, those 2 are selected. And I want that menu to pop up again. So I'm just going to not move my mouse, and you'll see the menu pops up that way. And we want the make parallel sketch relation. You can see the little sketch relation icons have appeared, so we know there is a relation between these 2. And no matter if I drag this one around, or to make a better point, if I move this endpoint, no matter where it goes, those lines are always parallel to each other. The next sketch relation we're going to look at is the perpendicular relation, and that is when you have a line that's 90 degrees to another line. So we could pick this line and then hold down Control and pick this line, or like I was saying before, to make it even quicker, just drag over those 2 lines together. And we want that menu to pop up, so we won't move our mouse after we've selected. And we want the make perpendicular. Based on the size of these lines, you may think, where is the other line gone now? You can see the perpendicular relationship is there, but where's it gone? A quick hotkey to zoom extents of what's available is to go Control-1 on the keyboard. And this will just zoom out to a point where everything fits on the screen. So that's really good instead of scrolling in and out or trying to pan over to get it to fit on screen. You can just simply go Control-1 and it'll fit everything on screen easily. So we can see they are actually perpendicular now. It's just that when it was trying to make that relationship, it had to kind of move them out of place. So that's all that's happened there. The next one is the collinear relation. And this is just when you have, say, 2 lines that are always following the same axis. Never say that properly. Axes. Anyway, so here we have 2 lines, and we're going to select these 2, leaving our mouse alone, and then so the menu pops up, and we're going to look for the make collinear and click on that. So at the moment the lines are overlapped, but if we drag, say, this point out, and we're going to drag the other end point out, and you can see these lines are always collinear to each other now. And this dashed line in between the 2 lines kind of represents that as well, that they're collinear, that they're always following each other. But no matter where I drag that, or if I overlap, they're always following the same axes. The next 2 sketch relations are very similar, the horizontal and the vertical relations. These are really handy ones that you'll use a lot. They're good for kind of making hard edges against each other and that sort of thing. And also just sort of flattening out lines or whatever. So if we use this line here having the menu pop up, we're going to make this one horizontal. So we're actually going to set the line to be horizontal. And we want this one to be vertical. So that's one way you can use the horizontal and vertical. Another way, if we just undo that, we could actually make these 2 points. So we're going to hold down Control, pick these two, and we're going to make these 2 horizontal. So these 2 points are always going to be horizontally related to each other. Same thing applies if you wanted to make them always vertical. So you could pick 2 endpoints and then make vertical. That way, these points are always going to be vertically related. Another sketch relation is the equal relation. So this is used if you want to make, say, 2 lines the same size all the time. What we'll do here is we're going to select these 2 lines. And again, sometimes you see the menu, sometimes you don't. So in this case, I didn't see the menu, which is usually because you move the mouse. But we can still access these relations on the side here. So we're looking for the equal relation. And now they are equal. It may look like nothing's changed, but if I drag this one around, you can see they're not really changing size. But I'll also show you one more relation here is I'm going to make this endpoint fixed, which looks like a little anchor. And this relation, you don't use it too often. It's kind of cheating if you do. So don't try and use fixed points too much unless you really have to. But in this example, I need to fix this point so I can demonstrate the equal relation between these two. So this point is now fixed. It can't move anywhere. And if I just move this line around, as it changes size, you can see that because they're equally related, that this line also is equal size to this. Another thing, if I quickly show you a dimension being added and say this has a length of 33 mils currently, if I was to change that to say 20 millimeters, you'll see that they both update. So this is a good way when you have multiple lines, but they all share an equal length. You can just set a dimension to one line and make the other lines equal to that. And therefore you don't have to set dimensions for every line. You can just use one. So we're going to undo that and show one more sketch relation for these straight lines. So we're just going to keep going back, go back, go back. Actually, there's 2 more relations for these points, and then we can move on to circles. But one we need to look at is midpoint relations. This is maybe similar to a perpendicular, except perpendicular, it's always going to be 90 degrees. Midpoint, it's always you can adjust the angle between that point. And it just means that an endpoint is always going to be on the middle point of this. So if I wanted to make this always be middle of this here, so I can pick this endpoint, pick this line, and we're going to go to, where is it? Midpoint. We can see it here on the left side, so we can go midpoint. So now this line is always in the midpoint of the other line. Another thing we can do with midpoint relation is actually add a point on the line and then make this always associated to that point. So it's a little hard to understand, but if I just show you quickly, up in our sketch tools, you'll have a point tool. So this is just going to add a point on this line. What we want to do is say, pick this one, hold down Control, pick this line, and then we're going to go to midpoint, and then we can escape. You can go OK, but there's no need to. You can just push escape at that point. So this line here is always at the midpoint related to that endpoint here. The final one to look at in this situation with straight lines is the symmetric relation. So symmetric is symmetry, one side to be equal to the other side. Say, like, you're drawing like a face profile or something. But when you're using symmetry, you need a center line. So what I'm going to do is on our sketch toolbar, we're going to draw a simple line, and that's just going to run down the center here. And once I've placed the line, pick the line, and then over on the left-hand feature panel, we have for construction. We want that to go for construction. Click OK. For construction just means it's like a center line now, and construction lines won't be used in features. So when you're trying to extrude something, you can't extrude a center line. You can also use it when you're revolving something, but We can go in more detail in another video, but you need a center line when you're doing symmetry. So if we just move this over here, say we want these 2 points to always be symmetrical based on this vertical line. So we can, holding down Control, pick that endpoint, pick this endpoint, then select the center line, and we want to go to symmetric over on the left-hand side. And now these 2 points are always symmetrical on that center line. So the distance between this point and the center line is equal to the distance from the center line to this point. Okay, so let's take a look at a final set of sketch relations. And this time these relations involve using arcs instead of straight lines. The first one we'll look at is called a co-radial relation. So on the screen you can see I have a couple of circles and a couple of arcs. So let's just pick these 2 arcs and we're going to go to co-radial. So what's happening with the co-radial is it is making sure the radiuses both match and that the center points are also merged to a common point as well. So when I drag this out, the arc, the center points for both arcs stay where it is, but also the radius will match on both of these arcs. The next sketch relation that involves arcs and circles is called the concentric relation. So in this case, the center points will match, they'll merge to a common point, but the radius will be able to be adjusted. So say, for example, we take these 2 circles. In this case, we're going to just not move the mouse. It's weird that the menu does that sometimes, but anyway. And then we're going to go make concentric. So you can see here the center point for both circles now is a common center point, but the radiuses can be independent of each other. Another sketch relation is the tangent relation. This works for either bringing circles and arcs together, or you can actually use straight lines and circles as well. Typically, I'll use this a lot when you're trying to make 2 arcs merge together really smoothly, so you get a nice curve through them, or you might have a straight line that then continues onto an arc instead of, kind of straight and then you've got a circle bulging out to the side. It sort of keeps that smooth tangent through. For example, if we say we're going to pick these 2 circles and go make tangent. So if I grab this circle, you'll now see that it is a tangent relation. So it's always going to just basically exactly where they intersect is where it's going to match. We could also say, if I just delete these 2, maybe I'm going to draw a straight line. So I'm going to draw a line and I want this line to be tangent with this arc here. So what I can do is I'll select these 2 and I'm going to make tangent. And now you can see that this line is tangent to that arc. Finally, we have the equal relation. Now this is pretty much the same as the equal relation we saw earlier, but this case we're using it on arcs and circles. So if I select these 2 and go to equal, now the radius, or if it's a circle, the diameter is going to equal on both sides, but the center point is both free to move. If either of these change in radius, the other one's going to match as well. Another example of the equal relation is if I had these 4 arcs and circles here, but I wanted them to all match. So I might actually say, I might put a dimension on this one actually. So I'm going to make this one 10 millimeter diameter. I can then have all these arcs and circles match that 10 millimeters simply by dimensioning one of them. So I can pick all of them, go to equal, and you can see they are all now 10 millimeters. There are more sketch relations that you can use, such as intersections, pierce, on surface, but these are more advanced sketch relations and not really needed to be covered in this lesson. The sketch relations you learn in this lesson so far is pretty much all you're going to use. You may only use a few of them, but it is important to sort of know these sketch relations to really use your sketching well in SolidWorks. All right, one more thing we have to look at, which is dimensioning. So the first thing we need to do is go to the Sketch tab, and we're looking for the Smart Dimension tool. Click on that. Smart Dimension tool will actually change based on what you're trying to dimension. And to give you an example, if I click on this line here, it will measure just the length of that line. and I can drop it down here. Click OK. If I just delete that dimension, which I can do by selecting it and pushing delete, another way I could dimension that is by clicking the outside lines and then dropping it like that. Now, why would you want to do that? Well, because in some cases, like for instance, this radius edge, this filleted edge, we don't want to just measure the length of this line. We actually want to measure to the outside distance as well. So in that case, you would need to do the dimension in multiple steps by clicking on this line and then clicking on the next line and then dropping it that way. Another thing when it comes to dimensioning is it will, like I said, based on how you place the dimension is how it's going to measure it. So if I do this line here, and you can see it's trying to do like a linear straight dimension, but if I keep going down, it's trying to do a horizontal dimension. Or if I go out to the side, it's doing a vertical dimension. So it sort of changes depending on where your mouse is. Another thing to note is if I actually right click, it will lock it to that dimension type. So now I can sort of place it here and here, but it's always going to be on that angle. If I right click again, then it will unlock it and I could now do it, say horizontal, lock it again, and it's stuck in that, it's set in that dimension type. We might want an angle of this line. We can do that, click the first line, click the second line, and you'll now see that it's trying to place an angular dimension. If you continue your mouse around, it will actually change where it's doing that angle from. So you can do from the bottom side to the line. You might just want the 27 degrees here, or you might want the full outside angular dimension. The next thing is when you dimension to a circle, if I click this line, it will actually by default always want to do the dimension from this to the center of the circle. So we'll make that 20, we're happy with that. But if I want to dimension to the outside edge, there's another way we can do that. What we'll do is we'll measure dimension from here. And if you hold down Shift, it will actually want to do the dimension to the outside edge. If I hold down Shift, we can drag it over to this side. So we might make this one 35. We also want the dimension of the circle. So by clicking on the circle, you can either place it this way or you can place it this way. And 25 is fine. We can also dimension arcs. So we can click on the arc and we might want that radius to be 15. And that did not seem to change. So if you want to edit a dimension once you placed it, you just double click on it and change that to 15. You can also do angular dimensions between two lines that don't even match. So we could click this one here and go here and make this 45 degrees. And then we might make an angle here of 20 degrees. And we could continue adding dimensions to this and fully defining the sketch, but it's not really going to serve a purpose in this video that can be covered properly another time. There is one more thing before you go on to the next lesson is this video series I'm creating completely for free to help people out there improve their SolidWorks skills and hopefully lead you towards doing the CSWA test. All I ask in return is that you please just like the video and subscribe to the channel, and that will help me in the future as well create more content like this. All right, that's it for this lesson. I'll catch you in the next one. Lines and center lines are one of the most common sketch entity types, and you'll use them often when sketching in SolidWorks. The first thing we'll do is sketch a simple rectangle shape. We'll do this by using the line tool. So over in the sketch tab, and you'll see line, click on that and it will be in the line sketch entity tool. From the midpoint, we will click on the midpoint and then just draw a line horizontally. You'll notice that it will snap to that horizontal or vertical point when you sort of get to that angle. Otherwise, you can also just draw off in any angle, but we want a horizontal line out to the side. We'll click, then we're going to go up, then over to the left side. And you'll notice what these dashed lines are. These are called inference lines. And they're just showing you that if you were to click here, that it's going to be in line with this point down here, or that it is currently in line with that point. So it's good to pay attention to inference lines just to make sketching a little easier and place points where you want them when you want them at these kind of angles or specific points on the drawing. So we want to click on there, and then to close this profile, we're going to go down back to the original starting point. You'll notice that a bunch of automatic sketch relations have also been added. So you can see some horizontal sketch relations and some vertical sketch relations. So when you are sketching, there are sometimes, depending where you place points, it will automatically add sketch relations for you. Another thing we can do with lines is create center lines. Center lines are unique in that they are not used for feature geometry, but they can be dimensioned and they can be used to create sketch relations from. So to create a center line, again, you can just go to the line tool, drop that down, and you'll see center line. And then we can just create a center line from point to point here. And we're also going to go from this point to this point. So we now have some center lines. To finalize this, we could create a dimension, an angled dimension, and just make this 50. And we've completed a little sketch of a cube with some center lines. Now let's do a few more things with the line tool and center line tools. I've created a quick little sketch here of this weird little rectangle shape. We're going to reproduce that over to the right hand side. Now we can just go to the line tool, but there's also a few other ways we can access this tool. You can right click in the graphics window and go to sketch entities and click on line. And we want it to be as close as possible to matching the same points as these lines over on the left. So if we make sure we're sort of using those inference lines, and we can see it's horizontally aligned to here, and we're going to start our first line, and we're just going to draw over. And if you want to stop using the line tool, you just push the escape key. We now need a couple lines going vertically, and I'll show you something with the line tool in the options. When you click on the line tool, you'll notice some extra settings over to the side here, and I'll just take a moment to explain them. The orientation, the as sketched, it just means that whenever you're using a line, it's just going to do it as you sketch it. So if I do it off in this direction, it's going to be in that direction. Another is the horizontal and vertical. So you could preset horizontal or vertical sketch relations by clicking this first. I don't use this too often, but you can do it. So in this case, let's give it a try. So we are going to need to create a vertical one. So we are going to start from here, and you can see even if I move my mouse off to the side, it's just going to keep it vertically aligned. So we will use that tool in here and place it in this direction. Personally, I just like to use the automatic sketch relations. So I'm just going to click on there, wait for it to be vertically aligned, and then drop it in place. Another way of starting a line is to actually use the shortcut menu. You can do that by pushing S on the keyboard, S for shortcut, and you'll notice this menu pop up. And from here, I can pick my line tool, click this point, and then we're just going to drag off to the side, roughly this angle, put a point there, and we're going to then come back at a 90-degree angle. And you'll notice that it actually has automatic relation for a perpendicular. So we can go up to the side here, and we'll just put it about here, and then a final point, which will go back to here. It's not looking completely the same as the one on the side, so we do need to add a sketch relation here. What we can do is make it perpendicular. So we can select these two, select make perpendicular, and you can see now it looks more like on the left hand side. Finally, there's center lines. As I was explaining before, center lines are used. You can create sketch relations from them, or you can run dimensions from them, but they aren't used in feature geometry. So when you can't extrude a square made out of center lines, for example. It may help with our drawing to have some center lines in the middle of this part. We can access that by going either to this line tool, dropping it down, and going to center line. And we are going to create one from this point to this point, and then pushing escape. And you can see it's a center line because of the dashed pattern that it puts in. Another way is, again, we can push S for shortcut, dropping down the line tool and going to center line. And we're going to go from this point to the midpoint. The final way is you can actually just right click in the graphics area, go to sketch entity, and then center line. And we can finish this by going to the center point to straight down to the center point. One final thing about center lines is you can actually convert normal lines to center lines and then back again if you need to. So it may be easier that you might say create a normal line here to here, and then from here to here. We can now pick those lines by holding down Control, so we can select multiple objects and picking those 3 lines. If you don't move your mouse, this menu should pop up, so you can either change it to construction geometry from here, or if you don't see that menu because you moved your mouse, you can actually see it over on the left-hand side. In the options, you can tick for construction. And you can now see those lines are center lines. You can also right-click on it, and that will also make the menu pop up. This is the construction geometry switch between button. So we can click on that and make that back to a normal line. So that's lines and center lines. Very good tool. You'll be using lines a lot when you're doing your sketches. So start playing around, doing a few sketches and learning how to use it, and using center lines where you need to use them as well. Don't forget to like the video and subscribe to the channel, and we'll move on to the next lesson. In SolidWorks, there is a variety of rectangle tools that you can use to create a rectangle in a sketch. There is the rectangle tool, the center rectangle tool, the 3-point rectangle tool, the 3-point center rectangle, and the parallelogram. These are mostly self-explanatory, but let's take a closer look at each one. As you can see, I've already created a 2D profile using each of the rectangle tools available, and we're going to recreate this ourselves. We begin by editing the sketch by clicking on the sketch and going to Edit Sketch. There are a few ways you can actually activate the rectangle tool. The first is by going to the Feature Manager, making sure the Sketch tab is activated, and you'll see the rectangle tool. The little arrow next to it, you can click on to drop down, and here you'll see the rectangles available that you can draw. Another way is to go to Tools, Sketch Entities, and again you'll see the rectangles available. A third option is you can right-click in the graphics area, go to Sketch Entities, and you will see the rectangles available here. And finally, you can also push S on the keyboard, S for shortcut. This will bring up the shortcut menu, and in here you'll also see the rectangle tool, which you can click on and select the rectangle you need. So let's start our first rectangle, and we're going to use the corner rectangle by pushing S on the keyboard, which is my preferred way of activating the sketch tools. I'm going to drop this down and pick corner rectangle. Also note here that when the rectangle tool is selected, you still do have the option of changing between the rectangles available. So here you can see the corner. I could switch to a center or a 3-point rectangle directly from here. So you don't have to actually cancel and then select another rectangle if you pick the wrong one. You can change it once it's activated. You'll also notice there are some extra options available as well. For example, the Add Construction Lines. And I'll just demonstrate this quickly for you using the center rectangle. So here I have Add Construction Lines, and it is going to be from the corner. So when I do a rectangle, you'll see the construction lines are from corner to corner. But if I was to say from midpoint and do a rectangle, you'll notice that the center lines are cutting through from the midpoints. To begin recreating this 2D profile, I'm going to start with the corner rectangle. So pushing S on the keyboard, making sure that corner rectangle is selected. And I'm just going to hover my mouse over the corner here and then drag it over to the right, and you can see the inference line. So you can tell that it's going to be in line with this when I start. So I'll click here, and again, having the inference lines start, I'm just going to put it about here. So that's the rectangle. All you're doing is picking one corner and then picking the opposite corner. Let's do a center rectangle corner. So as you can imagine, this is going to start from the center point and then you pick the outside corner. So we can use the center inference, drag it across, or even from this edge, clicking to begin, and then going up to the corner. So that's a center rectangle. The next one we can do is the 3-point rectangle. Self-explanatory, you just pick 3 points. So you're going to pick one, and then another corner, and then another corner. So what we can do here, if we're going to copy this area, which looks like it's going to the midpoint, so we can start from this corner, bring it to the midpoint, and then using the inference lines, it's not going to... There we go. Sometimes you might not, it might be too far away. So just move your mouse around until you can actually see an inference line. That should be close enough. So that is the 3-point rectangle. So the next one is the 3-point center rectangle. Pretty self-explanatory again, but you pick the center and then the outside, middle, and then down to the corner. So we can use this inference line to drag across and begin the center about here. We can then drag it over to the edge of the rectangle and then bring it down to the corner. So that's a 3-point center rectangle. The last one we look at is the parallelogram. The parallelogram is simply a rectangle that's on a slant. So we can use the inference line over to the side here and dragging it to about here. Click to start, drag it down to this point. That's our second point, and then our third point is the opposite corner here, and that is the parallelogram complete. Also, you'll notice that the little tick is available when you complete a command, but you can simply escape to finish the command. So that's the rectangle tool in SolidWorks. It's obviously very handy because instead of using lines to draw 4 corners, say for example, instead of drawing a rectangle like this, I can draw it much faster just by using the rectangle and drawing it like this. And this automatically puts in center lines if I want it. It adds any sketch relations that are automatically applied. So it's much quicker if you're drawing some sort of rectangle shape to use the rectangle tool. Hello everyone, welcome back. You are now up to lesson 5. So you're getting through this. Keep going, you're doing good. I know it can be a little boring with this early stuff, but it's important to learn the basics, especially if you're new to SolidWorks. You need to learn those basics and it'll make your 3D modeling so much better in the end. So just stick with these early couple of chapters, and as we get into more advanced stuff, it'll become a lot more interesting and much more fun. Anyway, the next thing we have to learn about is one of the sketch entities again, and this time it is for circles and arcs. So we just learnt about rectangles in a previous lesson. Now it's time for circles and arcs. In this case, we are going to use circles and arcs to recreate this sketch I have here. So if you're following along, first create a sketch. You should have learned that in a previous lesson. So create a sketch and then create 2 center lines as I have on the side here. And to make it a little easier, I actually fixed these points with a fixed constraint. So I put one here and on the outside edges. That just makes sure that it's not going to move around when we're drawing these entities. So there are 2 things to look at here. First, there are circles and then there are arcs. Circles can be done in 2 ways. There's a center point circle and then there is a perimeter circle. Arcs can be done in 3 ways. There is the center arc, the tangent arc, and the 3-point arc. So we're going to use all types of circles and arcs to recreate this sketch. First things first, we need to actually know how to create a circle or arc. And this can be done a few ways in SolidWorks. First, you could go to the tools and then to sketch entities. And in here, you'll find all your circles, circle here, perimeter circle, and also your arcs, center point, tangent, 3-point arc. Another way is to use the command manager, which is this area, making sure the sketch tab is activated, and you'll see circle. And it defaults to circle, but if you want the perimeter circle, you just click on the little arrow and you'll see perimeter circle. Another way is to right click in a blank space in the graphics window and going down to sketch entities. And here you'll also see 2 circle types and the 3 arcs. And finally, my preferred way is just by pushing S on the keyboard, S for shortcut, which brings up the shortcut menu. And similar to the command manager, you can just see this default circle or clicking on the triangle to drop it down to select perimeter, and also the arcs, and again clicking on that to see the other expanded options. Let's begin by starting with the basic circle. So we're going to use my preferred method. We're going to push S on the keyboard and clicking on the circle tool. And what we want to do is create this large circle in the middle. The way the default circle tool works is by picking the center point and then you just drag it out to pick a diameter basically. It's also worth mentioning that there are some additional options here when you start the command. So you could have diameter dimensions or add dimensions, or you can actually still change to a perimeter circle if you selected the wrong one. So you don't have to cancel the command and then start perimeter. You could just click on perimeter and do a perimeter circle from here or a normal circle from here. And the same thing goes for the arcs as well. So we want a default circle. We are going to click on the center point, making sure that center becomes highlighted, clicking on that. And then we're just going to drag out until it locks into that position there and snaps to the endpoint and clicking on that. So that's how you do a standard center point circle. Now we're going to use the perimeter circle to create this circle kind of in the middle outside. By making sure our perimeter circle is activated, we'll click on the center point, and then we're going to drag over, lock into this outside edge, and then it's not snapping onto this center line. So we're just going to place it about here. And we want it to actually be coincident to that line. So what you can do, finish that command, grab this point and drag it around until it wants to snap onto there. And that's how you can do that. A quick pro tip here, you can actually set the dimension of a circle in one step. So you don't have to actually create the circle and then use the dimension tool to size it. You can do it in one step, and I'll show you how. So we'll create a circle. We're going to just pick a random center point, start dragging it out, and you can see it has a little measurement box sitting there already. So you can just, without doing anything else, just type in a measurement, say 40 millimeters, and it's going to create the dimension and size it to 40 mils for you. So that's a really quick tip. Otherwise, you will get into the habit of, say, drawing the circle and then escaping and then giving it a dimension, setting that to 40, dragging that over. It didn't work, so I need to put in 40 again. So you can see it's much more quicker to just start the circle and then give it a size. It doesn't work in every case, like you don't always need to do it, but it is very handy when you can generally just do that on the fly in most cases. So anyway, we're going to delete those because we don't need them. And the next thing we're going to look at is the arc. So you got the center arc, the tangent arc, and the 3-point arc. First one we will look at is, of course, the center arc, and we're going to use that to draw this inside line. Using S on the keyboard, which is my way of doing things, I'm going to pick the center point arc. What you need to do here is pick the center point and then 2 outside points. So we're going to, it's not the center point here, it's actually here. So it needs to be here. That's the center point of this arc. We click here, and then we're going to use this corner and we drag it down. If you drag the other way, it's going to start drawing it in that direction, but we actually want it on the inside. So you need to bring it back, make sure it's drawing on the inside, and then bring it down to this point, and we're done. Instead of always clicking on the close dialog box button, you can actually just push escape on the keyboard. That's another way of doing it. Now we will use the tangent arc to create this outside arc. So we're going to go to our shortcut menu, drop that down, go to tangent arc. And with this arc, you just pick 2 points and then sort of drag it out to the size you want. So we're going to click on this and then go down to here, and you'll notice that it doesn't look like it does on the outside edge. And that is because with the tangent arc, it's going to usually default to a particular arc it's looking at. So what I mean here is that we have 2 arcs that it could actually work from, and it's actually trying to draw this arc from the outside one. So it's thinking it just needs to complete a circle like this. So what you need to do is actually bring your mouse over to this line here so the endpoint gets highlighted, and then quickly drag to the endpoint and click on it and then drag out. So what you do, quickly hover over here, quickly go over, pick that point, drag it out. And this is the painful thing about this tangent arc when you got competing edges it wants to work with. So we're going to try that again. Going to bring it to there, and it still doesn't want to do it. We'll give it one more try. Start a bit further out. Okay, so that time will work. So you can see it's a little annoying sometimes. With tangent arcs, there's one more way you can do it, and it's to do with something that's called auto transition. What I mean is you can actually draw an arc from a straight line, and it will automatically transition to an arc from a straight line and then back to a straight line again. What you do in this case, if I draw a straight line and drop a point there, and it wants to draw another straight line, but if I go back to that point without clicking anything and then just bring the mouse out again, you'll notice it actually wants to draw an arc. And then if I click, and then it goes back to straight line, and I click, and then it wants to draw another straight line, but I drag it back to that point and then drag it out. And so that's another way of drawing a tangent arc. So let's use that here. So if I delete that, I can actually use my line tool, having this highlighted, quickly go to the end, and you'll see it's trying to draw an arc. I drag it back and then out. And there we go. And I'll just delete this because I didn't need it. So that's another way you can draw a tangent arc. And it's quite smooth flowing when you're drawing something, and you can do a line and then draw an arc and then do another line and an arc out. So it makes things really quick rather than having to switch between multiple tools. So that's a good pro tip to know that. Final one we need to look at is, of course, the 3-point arc, which is what we're going to use to draw this final arc on the outside here. Going to our shortcut menu, dropping that down, going to 3-point arc, and we need to pick 3 points. So we're going to pick this corner, and then just drag it out to about here. And you'll notice it doesn't want to actually snap to anything else. So I'll show you what we can do to make it match the other side. So we're just going to click there to drop it, and we're happy with that, pushing escape. What we want is this arc to be the same as this one, and we can use sketch relations to do that. And if you can remember from the previous episode or from the previous lesson, we can use a equal relation. Picking these two lines, letting the little context menu come up, go to make equal, and you'll notice it moves out a little bit to match the other side. Pushing escape because we're done, and there we go. We finished. So using arcs and circles is very powerful. It's obviously one of the base sketch entities you need to know. Make sure you practice around a little bit and get familiar with drawing these different types of circles and arcs, and you can move on to the next lesson. In SolidWorks, there are two curved closed loop sketch entities to help you with your sketching. They are the ellipse and the slot sketch tools. An ellipse is a sketch entity that SolidWorks defines by first setting a major axis and then a minor axis. And this determines the height and width of the ellipse. There are two ellipse tools available. They are the standard ellipse and the partial ellipse. A slot is a sketch entity that is first defined using a linear or curved center line, and then the width is defined a constant distance away from that center line. There are 4 types of slot tools you can use in SolidWorks. They are the straight slot, the center point slot, the 3-point arc slot, and the center point arc slot. Let's begin by first showing you how to start the ellipse and arc tools. You can do this by either going to the menu up the top, going to Tools, and then Sketch Entities, and in here you will see the ellipses and also the slots. Another way of doing this is in the Feature Manager, making sure the Sketch tab is activated, and you will see the ellipses here. And to access the additional ellipses, you can drop this down. In this lesson, the parabola and conic are not covered. We'll just be looking at the standard and partial ellipse. And the slot tool can be accessed here, and again, dropping it down to access the extended feature ones. Another way you can start the tool is by right-clicking in the graphics window when you have a sketch activated. So right-click in the graphics window in a blank area, go to Sketch Entities, and then you'll see the ellipses here and the slots here. And the final way of doing it is by pushing S on the keyboard for shortcut menu, hitting S, and you can access the ellipse here and the slots here. If you don't see them, check out a video about customizing these menus in a later date. The first thing we'll do is create an ellipse, and just a standard ellipse. So we will click on our ellipse tool, and we will begin by just picking a center point for it and dragging out to our first major axis, and then dragging up for our minor axis. And you'll notice that when you place, you have options available on the side. So it'll show you any existing relations, any relations we can add, like a fixed point. We can make it for construction, so make this ellipse centerline. And we can also adjust the dimensions from within the options. So for example, if I wanted to preset dimensions on this ellipse without having to add dimensions myself, I could make this a major axis of 30 mil. And we're going to make the minor axis, let's say 18 mil. And then just pushing OK. And that way it is predefined to a set dimension. And it might just be a little easier with our sketching if we're doing this sort of thing, but it's not always required. The next tool would be the partial ellipse. And as you can imagine, what it's doing is simply drawing an ellipse, but only a portion of that ellipse. So going to our tool, we can drop that down and select partial ellipse, and we are going to draw that just under. So using the inference lines here, we're going to drag it down, pick a center point here, drag out And we can use the inference, but I'm going to use the dimensions in the options again to match it to the ellipse we just drew before. So I'm going to draw it out just a little bit more and then drag it up. And the final thing we need to do is actually draw how much of the ellipse we want. And remember, if it's not drawing the way you want, you can just circle back and go in this direction. Or if you do want it to the other side, you just circle back, go to here. So we're going to show about roughly 3/4 and finish it here. And before we click OK or escape, we're going to match it to the one above. So I think that was 30 mil major axis and 18 mil minor axis. And there we go. We now have a partial ellipse which matches above. We can make adjustments to these ellipses, of course, by dragging points around, and you can play around to see what changes when you move different parts. So for example, if I was to move the center point, you can see it's kind of dragging around and adjusting the size. If we move from the actual edge, it can move the whole thing without adjusting any dimensions. If we grab a point, it starts to move in that axis and also has a rotation. But if we do that with the partial, we can adjust the partial length. We can also adjust the axis and the rotation. We can move it by the midpoint, so a little different to the full ellipse above. But just play around with the different points to see what changes as you move them. But that's how you'll edit. Plus also you can add dimensions to resize it and so forth. We will now move on to the slot tool, and we're going to use each of the 4 slot tools to create a 2D profile on these center lines. To begin, we're going to pick the straight slot. And this works by picking 2 points and then you drag it out to set a width. Before we begin though, you will notice that there are options on the side, which is where you can actually change between the different slot tools available. If you wanted to change without having to exit the command and then start it in a different type, you can just simply change it to a center point straight slot from here. You can also create dimensions on the slot sketch once you've completed it. We actually don't want it in this case, so we're going to uncheck that. With a straight slot, you'll also notice there's different ways that it will be created. So it's either going to use the center to center points, or it could use the overall length. And then there are also options for creating construction lines once it's placed. We don't need that. And also setting parameters, but these are grayed out at the moment. Once you start sketching the slot, these can be changed. So making sure the straight slot is selected, we are going to create a straight slot here. We begin by making sure it is center to center, and we are going to pick this point and this outer point and then dragging up a little bit. It will probably be a little slow for your machine when you are drawing out the width, so just give it a little bit of time. It's weird that the slot tool seems to do this, but anyway. You'll also notice there's a little dimension on the side of it, and you can actually type in a number if you want to preset a dimension, or at least just a size for it instead of dragging it out to some random number. So you can see here it's like 19.42, but let's make it exactly 20. So we can do that just by pushing 20 and hitting enter, and that way it has created it at 20 mil width. We will move on to the straight center point slot tool. So we're going to click over here, again making sure add dimensions is not checked and for construction is not checked. As you can imagine, this time we pick a center point and then drag out to the outside edge and then drag up. So picking the center point, going out to either the left or right point and then dragging up, and we want it to be the same size, so without trying to place it, we're just going to type in 20 again and hitting enter. The next one is the 3-point arc, so we're going to make this one selected, and we need to pick 3 points. So you go 1, 2, and then the contour and then a width. We pick this side, we drag it up to here, and then it's going to want to sort of have a center line to base the curve on. So we're going to just make it tangent to this and then dragging it out. And like I said, it's very slow when it's trying to drag this out. So just be patient with it. Bring your mouse out so it starts to give you some width. And we're also going to make this one, let's make this one 25. And the final one we're going to look at is the center point arc slot. So activate that one. This time we're going to add dimensions, and I'll show you why. So make sure add dimensions is checked. For construction is not checked. This tool, we begin by picking the actual center point, dragging out to the first point, and then another point. If it's not drawing in this dimension, like if I drag out this way, it's going to start drawing out. So just rotate around until it starts drawing in that direction. Pick that point, and then we go to this point, letting it come out a little bit, giving it a little bit of time to sort of catch up with itself, and then we're going to match it to 25. So with add dimensions checked, you'll notice that it has actually put in the dimensions required to create this slot. So we've got a radius of 60, the 25 mils we set, and it's at a 90-degree angle. And you'll notice that because this is all sort of solid black lines now, that it's actually defined it by creating those dimensions. So this can be a faster way of defining your sketches by picking that add dimensions checkbox, and it might just sort of speed things up. And finally, just to modify these slots, you can, like we did for the other ellipse, you can just sort of drag points out. But because slots create auto relations, you won't have full control over what you can adjust. So you'll notice if I try and move this point, it's not going to do anything. If I try and, I can basically only adjust the width of this slot. So for this one, I would have to adjust it by just changing the dimension. So I can double click on the dimension and say, change this to 30 to adjust it. But if I was to create a straight slot, and we're going to take off add dimensions, and we're just going to draw it out here, drag it out, and drop it. Now this one hasn't been drawn on any centerline construction geometry. So in this case, I can actually modify it a little bit more by dragging points around. So you'll notice if I drag this around, it's moving it, the whole thing around. If I grab this point, it's adjusting the length and the width. What else can we do? This one adjusts the position and the width. So you can see, because it's doesn't have any of those auto relations, you have a little bit more freedom in what you can actually adjust by moving points. So that's the ellipse and slot sketch entities, very powerful tools. You're not going to always be using them, but if you're designing a lot of metal fittings and stuff, you'll often use slots. It's also will save a lot of time when you are sketching anything like this, because if you were to use lines and arcs and circles and then trying to trim away things and dimension things, it's obviously going to take a lot of time when you could simply do a slot and do that in one command. So they are very useful in specific situations, but they are worth knowing about so you'll know when to use them in the future. Sketch fillets and chamfers are sketch tools that are used to round out and break sharp corners. The sketch fillet tool trims away a corner and creates a tangent arc, resulting in a smoother edge. The sketch chamfer tool also trims away a corner but results in a beveled edge. In this lesson, you will learn how to use both the sketch fillet and sketch chamfer tools. Let's begin with the sketch fillet. And to start this command, you have to make sure you are in a sketch, so your sketch is activated. And I have a quick 2D profile I've created here to demonstrate the fillet and chamfers. These fillet tool can be found on your toolbar, so make sure the sketch tab is activated. You'll find sketch fillet here. Also, if you want chamfer, you can drop that down and select chamfer. Another way is pushing S on the keyboard, S for shortcut, and finding the fillet, or dropping it down to select the chamfer. So in this case, we want to use a fillet. You can see our command is now active. It's in the left-hand panel, and there's a few options here I want to cover. First is the entities to fillet. The entities are basically the lines that are meeting to a point, and that's where you want the tangent arc to be. You can do this in two ways. You can either pick the line and the other line, and this will create a fillet. It's not creating it in this case because the radius is too large, so we're going to actually change the radius here to a 5, and then we're going to pick that second line again. And you can see a temporary line is put in place to indicate where the fillet's going to be. Another way of doing it is actually just picking the point where the two lines meet. And you can actually add multiple fillets throughout the sketch by doing this, so you don't have to pick the command for each fillet that you're doing. You can actually start at once. As long as the fillets are the same radius throughout, we can pick this corner, and in this case we're going to actually just pick the corner of those two and then push OK, and our fillet has been created. We can then exit the command by pushing escape on the keyboard. So you'll notice the fillet has been created on these two edges, and it's placed a radius dimension here. This is where you can control the size of the fillets that we've just created. So if we want to adjust that, we can double click on that 5 radius, and we might change this to a 3. So we'll put in a 3 and enter, and you can see these now updated. Back to our default 2D profile, I just want to show you another thing in the options that's important. Starting the sketch fillet command again, you'll notice there is a checkbox for keep constrained corners. What this is doing is keeping the sketch relations in place when you create a fillet on a corner. So if we uncheck that, it may actually remove any sketch relations that we have in place. So I'm going to make sure that's unchecked in this case, and I'm going to put a sketch fillet here, and you'll notice an error comes up, or a notification comes up saying that there is geometry relations in place and they're going to be deleted if we create this fillet. So we'll say yes, and then we go OK. And you can see it has created, but it's removed this sketch relation that was involved in this area before to create that fillet. So there are certain cases where you will use this. It just depends on the situation. One more thing I want to cover is going back to our default 2D profile, starting the sketch fillet. There is another tick box here that is dimension each fillet. So if we pick, say, this corner and this corner, we're going to say no because we want to actually keep constrained corners in this case. Dimension each fillet. So normally, as in the first example, it will just create one radius, and that dimension, that radius dimension, will control all fillets that you just created. So you could create 10 fillets, have one dimension, and if you change it, it's going to adjust all those fillets that you created. But maybe you don't want to have that overarching control. Maybe you want to be able to individually adjust each one afterwards. So that's where dimension each fillet comes in place. So we're going to put a tick onto that and click OK. Looks like we didn't have our other one selected, so we're just going to pick this one as well. Click OK. So now we actually have 2 dimensions, and I could then change this one to say 2.5, and it's going to be controlled individually. And if there were more, they would also have their own dimension and also be able to be controlled individually. Moving on to the sketch chamfer. So the sketch chamfer is when you want a hard corner. A fillet is a rounded, and a chamfer is a hard edge. So we're going to go to the sketch chamfer, and in the sketch chamfer we have a few options of running this command. So the first one is angle distance. This will mean that you specify a distance from the corner to the point and an angle between it. So that might be 45 degrees. So to give an example, we're going to say 10 mils, 45 degrees, and you can preset these amounts before you actually drop the command in. And we're going to put one here. So you can see it's now done a 10 distance with a 45 degree, and we can adjust that if we need to by, say, changing this to 30 degrees and so forth. The next one is distance. So in this case, we don't worry about the angle, but we're going to use 2 dimensions to create that chamfer. So let's say we want a 5 and a 10 mil. We then pick this line and this line. It's created that 5 and 10. But be aware here that because of that unequal distance, it is based on which line you click first for which dimension you want in place. So if I actually wanted the 5 on this side and the 10 on the top side, I would actually have to pick the lines in the opposite order that I just did. So if we undo that, go back to our sketch chamfer, we have 5 and 10 with a distance. So the first time I pick the top line and then the line on the side. This time we'll pick the side and then the top. So you can see now it's actually done the 5 on this side and the 10. So it does depend on which line you click for which dimension is set when you're doing the distance. And finally, with the distance, there is the equal distance. So that just means that you can check that box and just have one number or one distance. So we'll make that a 10, and let's pick on this corner and just make that 10. So this way we don't need differing dimensions on each side. We just know it's a 10 by 10. Another way of doing this would be using the angle distance and just saying 10 by 45. So it really depends on what control you want afterwards would be what sort of options you're using. And that's it. That's sketch fillets and sketch chamfers. Very easy. You can either do these in the sketching environment, but you can also apply radiuses or fillets and chamfers to 3D solids, but that will be covered in another chapter. This just covers the sketching side of fillets and chamfers. The Trim Entities tool is a command used to trim or extend sketch entities. There are several ways to trim or extend geometry in SolidWorks using the Trim Entities tool. This lesson will teach you a variety of ways of using the Trim tool. To start the Trim Entities tool, you can do this a few ways. In the Command Manager, in the Sketch tab, we can click on Trim Entities. You could also go to the Tools in the menu, down to Sketch Tools, and then either Trim or Extend. You can right-click in the graphics window in a blank area and go to Sketch Tools, and then Trim Entities. Or finally, you can hit S on the keyboard, S shortcut, and go to the Trim Entities tool. With the command activated, on the left-hand side, you'll see an Options menu, and there'll be multiple options on how to use the Trim or Command Entities tool. Also, as you click on each one, you'll notice a information dialog box come up, which will give you additional information on how you can use the tool. The first one we're going to look at is the Trim to Closest. And Trim to Closest will just trim an entity to its closest point. So using this, we could trim away the center here. We could trim this middle section. We could trim one here. So it's always just trimming to the closest point or the two closest points. And the next two are similar. They are trim away outside and trim away inside. These will work by picking a boundary area, either arcs or lines, and then picking the entity that you want to trim in between or outside that boundary. So if we want to trim away this inside or the outside edges, we can use these 2 points as our boundary. And the third click will be whether we want the outside or the inside taken away. With trim away outside selected, we can simply have that trim back to the boundary. But if we switch this to trim away inside, and we still have our points highlighted, so we can trim away the inside here. If I was to stop the command by pushing escape and going back and using that command, I would then have to pick another boundary again, for example. So trim to corner trim corner will just bring two lines together to make an intersection or a corner point. We can, for example, pick these two. I don't really like this command. It seems to be causing errors, so I tend not to use that. And the final one is Power Trim. Power Trim is the most flexible trim tool you can use. With Power Trim, you can trim entities and extend entities, and a much easier process. All you need to do is, there's a few ways you can do this. So the first is you can simply hold down your mouse and this little line appears, and you can just drag over the points you want to trim away. If I went too far, I can actually go backwards over this little red square, and that will undo the last trim I did. So I could go back over this one and back over that one. You can quickly trim points this way, and if you do make a mistake, just go back. You can also trim lines by simply dragging them using the power trim. So I can pick any point and drag it back, and where I release is where it's going to trim to. I can also extend it by just clicking on the line and bringing it to a point. Or I can extend with the power trim by clicking on the line and then clicking on the line I want it to extend to. So that's one way of doing it. Or clicking on the line and then clicking on the line that I want it to trim to. But in general, the power trim is very powerful when you want to trim to intersections like this. So it's a very fast tool for trimming in that sense. A final couple of points with the trim tool is in the options, there's actually a couple of checkboxes to give you some more options when trimming. The first one is keep trimmed entities as construction geometry. This means that when it's ticked, as you go along and trim things, that instead of removing the line that's trimmed, it will actually just create a center line instead. So for example, using the power trim, if I drag across here and let go, the lines have been trimmed, but they're now center lines. Another option is ignore trimming of construction geometry. So this means that as you use the power trim tool, it's not going to trim away any center lines, but it will trim back regular lines. This is really helpful when you have a lot of construction geometry and you don't want to be moving around and trying to trim in between the construction geometry. You can just tick this option and it will ignore them, and you can go through using the power trim to trim back everything you need to. That completes this lesson on trimming. Trimming and extending is a very powerful tool when it comes to sketching. You'll use it a lot in between actually creating your 2D geometry and then trimming it back to the shape that you want, then going on to apply sketch relations and dimensions. So all these tools kind of work together to create really defined 2D profiles, and sketch trimming and sketch extending is a part of that process. When you have symmetric geometry in a design, You can save time by using the Sketch Entity Mirror tool. This allows you to mirror geometry from one side to the other side. In this lesson, I'll teach you 3 basic methods in which symmetric geometry can be created. First, I'll show you a method where half the geometry is already created, and we will use the Mirror Entities command to create the other half. Next, I'll demonstrate the dynamic mirror option, which allows you to sketch symmetric entities simultaneously. And finally, I'll show you a manual approach of adding symmetric geometric relations to a sketch to achieve a similar result as using the Sketch Mirror tool. So the Mirror Entities tool allows you to mirror sketch geometry about lines, center lines, or model linear edges. In this first example, I already have a part modeled, and you can see a 2D profile on the left, which I want to mirror over to the other side, and then we can cut through the object using those 2 profiles. To begin, we need to activate the sketch that this 2D profile is on. So I'm going to go over to here in my feature manager, click on the sketch, go to Edit Sketch, and we are now in the sketch mode. And to activate the sketch mirror, you can either go to Tools, Sketch Tools, and then Mirror, or you can find it in the Sketch tab, Mirror Entities. Once the command is activated, you'll see in the side panel over on the left, there are 2 boxes. So the first is Entities to Mirror, which is obviously the profile, the geometry that you want to mirror. And we can select either the lines. Sometimes you can actually just select the whole profile. So move your mouse around, see what highlights to maybe make the selection process easier. The next option is Mirror About, and in this case we're going to use this center line that's been created, and click on that, and you can notice that there is a highlighted profile showing what the result of the mirror can be. Before we push OK though, there is a copy box that is ticked. When that is ticked, it means that whatever you select and mirror is just going to copy to the other side. If I was to untick that option, what will happen is it will delete the original side, mirror it to the other side, and that's where your new profile would be. So just be aware of that option in case you find that the geometry on one side is being deleted and moving to the other side. It is likely because you have that unticked. So in this case, we want to copy it over to the other side, making sure the copy box is selected, and we can push OK. But before I do that, I just want to show you quickly, when you have entities selected, you can actually delete them and add more. So in case I accidentally added one line too many, I can just actually delete them, or if I right click in this option, clear selection entirely. So that is another way, if you do make a mistake, instead of restarting the command all over again, you can just clear the ones or clear the whole lot and then pick it again. So that's just something to keep in mind to maybe save some time in the future. Okay, so we're going to click OK. Our profile is now mirrored over to the other side. So that is the basic mirror entity option. And just to complete this process, if we can then cut these profiles through all, and there you go. So that may have been the purpose of mirroring the sketch geometry over and then using a single cut through the object. The second mirror tool we can use is the dynamic mirror tool. This works a little differently. So here we have another sketch already created, and we just have a single center line in the middle of the drawing. To access this tool, we go to Tools, Sketch Tools, and then Dynamic Mirror. This activates the Dynamic Mirror tool. With the tool now activated, you'll notice there is a message on the side that says, please select a sketch line or linear model edge to mirror about. So it is just asking for a line to actually create the mirror. So we will pick this center line that's been created. And when we do that, you'll notice these little icons on the top and bottom that look like little equal signs. So that just means that the dynamic mirror is happening on that axis or on that center line we've created. So if now I create some lines, you'll notice that whatever I do on this side, or if I was to do it on the other side, will be mirrored dynamically onto the other side. And if we put a circle here, we could move this point. So whatever we do, it is dynamically mirroring to the other side. So this could be quite a handy little feature. To stop the dynamic mirror, we have to turn the command off. So we could go back up to the tools and then sketch tools and then click on that. I want to show you a quick time-saving tip here. If we actually right-click, we can go to recent commands. And in here, you'll find the dynamic mirror entities as well as any other recent commands you've used. So we could just right click, go to recent commands and then dynamic mirror entities. And you'll notice those little equal signs are gone. So the command is now turned off. One final point on the dynamic mirror tool is that whatever we created in that command is still kind of symmetrically attached to each other. So if I was to move these points around, you'll notice that it moves dynamically on the other side or symmetrically on the other side. But if I was to create a line on this side, it's not dynamically creating it on the other side because that command isn't still activated. If I was to adjust any of these points, they are still in a symmetric relation. But if I was to delete it, it just deletes that symmetric relation on the other side, but doesn't actually delete it from the other side. And to demonstrate the final method of creating a mirrored geometry is we can manually create it using relations or the symmetric relation. So on this sketch, I have just a few basic lines and a couple of circles. The first thing we want to do is place a center line. So we can go to our shortcut menu and picking our center line, and we're just going to create it from the origin point and drop it here. We can use this center line as our kind of mirror point, our mirror axis. What we want to do is holding down Control so we can pick multiple objects. Hold down Control, pick the center line, and we're going to pick these two endpoints. When we let go of Control without moving the mouse, you should see a little menu pop up. If you don't see it, if you move your mouse out of the way and it disappears, you can still see it over on this left-hand side. And the tool we want to use is symmetric. We pick that and we go OK. So now you'll see that these 2 points are kind of like symmetrically mirrored about this center line. So again, let's use these two middle endpoints. So we're going to hold down Control, pick the center line, and then pick this point. And then we're going to make symmetric, clicking OK. And you can see now these 2 points are also symmetric. And finally, we want these two circles to be symmetric. And we could actually, by holding down Control and picking these two circles, we could actually use the make equal relation, which in effect would create a symmetric relation between those two circles. But just to follow the purpose of this video, we'll go back. We're going to hold down Control, pick the first circle, the center line, and then that last circle, just so we do see the symmetric relation, clicking on it, pushing OK. And now you can see that the circles are symmetrically mirrored about the center line. So that is how you use the sketch mirror tool. You'll often use this a lot. Whenever you see any kind of symmetric geometry, you can usually save yourself time by just doing half of it and then creating a center line or some sort of reference point to copy it to the other side. And this will cut down a lot of the sketching that you have to do. So that will come into more design intent later in the videos of this series, but it is something to be aware of. So whenever you do see that symmetric geometry in a model, that you'll think of this command and hopefully use it in an effective way. SolidWorks has tools which allows you to use existing geometry and model as the basis for new geometry in a sketch. In this lesson, you will learn about the offset entities and the convert entities tools. Offset entities selects existing geometry and offsets it by a distance you specify. Convert entities creates geometry by selecting existing geometry and projecting it onto the active sketch plane with relations that ensure the geometry created will always match the projected geometry. Convert entities creates geometry by selecting existing geometry and projecting it onto the active sketch plane. It also adds relations to ensure the projected geometry will always match with the existing geometry you're projecting. These are both powerful tools to use in SolidWorks as they allow you to leverage the existing geometry in the model, which means that if the original geometry changes, the new geometry will automatically update to reflect those changes. To begin, we'll look at the Offset Entities tool, which allows you to pick existing geometry and then offset it by a given distance. You can start this command by either going to the Sketch tab and then Offset Entities, or you can go to Tools, Sketch Tools, Offset Entities, or you can push S on the keyboard and go to Offset Entities. There's a few options available here, but we'll cover those in a moment. At the moment, we just have the Add Dimensions checked and everything else is unchecked. To actually offset an entity, you can do this in two ways. You can either left click on the line and just drag it out to a position you want, or you can specify an amount first and then click on the entities you want. Also, if you click on the entity again, it will remove the selection. Let's take a look at some of the options you can use in the Offset Entities tool. The first is Select Chain. Select Chain will just make sure whatever lines are connecting, it will select the entire chain. So you can kind of create a loop or a single entity selection without having to pick each one. We could just pick Select Chain and pick one of the entities, and it will pick all of them for us as long as they're connected. Another option is Reverse. So if you wanted to reverse the direction, you could click on this. You can also reverse the direction by just moving your mouse onto the other side and clicking it. Then we have the bidirectional option. If we tick that, it will mean that it will create the offset on both sides of the entity. And with bidirectional selected, you also have the option of cap ends. So if we tick cap ends, and I'll just zoom out a bit so you can see, but you'll notice it completes the profile by adding these two capped ends. And you can either have it set to arcs, so it's going to create like a circle, or lines, which is just going to be a straight cut across. So this is a good way of creating customized slots. If you needed a slot with this particular shape, that would be a very quick way of drawing it, is just to do the lines in the correct positions and then offset and cap the ends. And the final option we have is base geometry. So with that selected, it's going to make the original entities that we offset, it's going to change them to construction geometry. And the benefit with that is that construction geometry is ignored whenever you use it to create features from a sketch. So if this line was then construction geometry and I wanted to extrude that, it's just going to ignore that construction geometry and just extrude the outside profile. Also, because I had add dimensions checked, whenever you complete the command, it's going to drop in these dimensions for you. So this allows you to easily edit the offsets in the future if you ever need to. To change the dimensions, all you need to do is just double click on one of them. A dialog box pops up and we can change that to 30 and it's going to adjust it automatically. Or we could drop that down to say 10 millimeters. If we didn't have add dimensions selected, then you would have to manually add the dimensions afterwards, which would then give you that control in the future to make any modifications to the offset. Here we have a little spinning top I've created, which we're going to use as an example using the Offset Entities tool. What I want is a cutout at the top of this, and just so it recesses in, say, 5 millimeters. We can use the Offset Entities tool to do that. To begin, we'll create a sketch on the top of this surface, and we will use the Offset Entities. We don't want bidirectional, we just want one direction, and we'll reverse that, and we're going to make it 10 mils. Click OK. Go back to our isometric view, and we will then cut this profile. 5 mils is fine. And there we go. We now have our recessed cut in the top of this. But the beauty of the Offset Entities tool is that if we make any future modifications to this part, that 10 mils we set with the offset geometry is going to stay with it and stay at the 10 mils. So if I was to change this to 200 millimeters and then update, you can see it's now increased the size of the spinning top, but that 10 mil recessed cut is still 10 millimeters. Moving on, we're going to use this part to demonstrate the Convert Entities tool. Convert Entities lets you take advantage of existing geometry by copying it onto the sketch you're currently working on. This is useful because the copy geometry will automatically update if the original geometry is modified in some way. Here we have a part which has some holes on the back plate here, and we want these holes on the other side. The issue we have here is if we want these holes to go all the way through, and we can edit this feature, change it to through all, you'll see that it's going to cut through the existing geometry. So we don't want that. We just want the holes on the other side and for them to match this side at all times. What we can do is instead create a sketch on this back plate, and I'm going to rotate a bit just so you can see what's happening. And we are going to use the Convert Entities tool, which you can be found on the Sketch tab, Convert Entities, or of course the Tools, Sketch Tools, Convert Entities, or of course the S for Shortcut and Convert Entities. And with the tool activated, we have a few options here. The first is just a dialog box which shows the geometry you've selected. You also have Select Chain, which acts the same as the Offset Entities. So it's just going to pick any lines that are connected to create a chain loop. And finally, Inner Loops 1 by 1, which will just select all the closed loops inside the profile. And closed loops are like circles or ellipses. So we want for these circles to be projected across. So we can just pick this face and then go to select all inner loops. So that's going to pick all our entities for us, and we'll click OK. And you can see that the geometry is being projected across and it matches exactly as it would on the other side. Also, if you click on this circle, you'll notice a relation that's been created here, which is the on-edge relation. And this is a special relation, which means that entity, that sketch geometry, is being projected from somewhere else and it matches whatever that geometry is. So, for example, if I was to finish this sketch, and we are going to use that to create a cut. We're going to change that to next and click OK. So we now have our bolt holes on both sides. But if this was to ever change, say the diameter will change to 20, click OK. We'll update that. And you can see all of them have been updated on this side as well, because of that on-edge relation is matching whatever's happening on this side. So that's the Offset Entities and the Convert Entities tools. You'll use these a lot when you're sketching, especially the Convert Entities is very useful whenever you need to copy geometry from somewhere else onto a sketch that you're trying to build, and you're using some sort of previous geometry to bring that towards it. It's very useful in that case. The Offset Entities is also very useful when you're just trying to create recessed edges or some sort of like cavity. You can quickly use that to bring it in without having to dimension things. You can just sort of do it in one step. So they're both very powerful tools because they do leverage that existing geometry that's available in the model. When working with a sketch that contains contours, you can use the Contour Selection tool to select portions of the sketch you would like to use. This means that in SolidWorks, you can use a partial sketch to build features by selecting individual contours within the sketch. The advantage to this is that it allows you to make most of the geometry in a single sketch, which you can then reuse to create multiple features from the same common sketch. In this lesson, you'll learn a couple of ways of working with a sketch that contains contours to build multiple features from. Here we have a sketch that contains multiple contours, and keep in mind contours simply means regions. So the contour tool allows you to select specific regions in the sketch that you can then use to create features. There's a couple of ways you can activate the Select Contours tool. The first way is by simply right-clicking on the sketch, expanding the menu by clicking on this little double arrow, and then going to Contour Select tool. And you'll notice that the mouse cursor has now changed to a new symbol, which reflects the Select Contour tool is now activated. The second way of activating the tool is when you're actually in a sketch already, you can just go to a feature like the Extrude Boss base, and the Select Contours is automatically enabled. But we'll use this situation in a moment. Let's first use the original method by right-clicking on it, expanding the menu and going to Contour Select. When the tool is enabled, you'll notice as I move my mouse over the sketch, the different regions or the contours will highlight. To select multiple regions, you hold down the Control key. So I'm going to select these three and leave out the center hole. What this is doing is pre-selecting the regions or the contours that I want to use for the next feature, and that feature is the extruded boss. So you notice because I did have those regions or contours pre-selected, they show up in the Select Contours dialog box, which you'll notice whenever you use a cut or extrude command, you'll have this selected contours dialog in the bottom here. We are just going to make this a simple 10mm blind extrusion and select OK. Now we're going to use the original sketch to add some additional features to the model. We're going to use the second method of activating the contour selection tool by starting an extruded boss command. And this is going to ask us to pick a sketch or plane. We're going to pick the original sketch by expanding the feature manager, going back down to the boss extrude and selecting the original sketch and making sure the select contours box is activated. We can pick these two areas and we are going to make this a 30mm blind extrusion and push OK. You'll also notice that the sketch has changed the icon to a feature with a hand underneath it. Whenever you see this, it means that sketch is being used across multiple features. And now finally, to show the main advantage of the contour selection. Whenever you make additional changes to the model, because you're only working from one sketch, it's much easier to make those modifications. So if I was to go to the original sketch and edit, and say we wanted to change this to a 50mm length, and also this radius has changed to 70. And then we can exit the sketch, go back to our isometric view, and the whole entire model has updated. Normally, if you had done two individual sketches and two individual features from those sketches, you'd have to go to the first sketch and make the modification, and then edit the second sketch and make the modification. But because we all did the entire geometry in the single sketch and then use contours to build the features from it, we only need to make the modifications from that original sketch. So this is a very useful way of doing your sketching, is to try and combine as many features that you see using in the future into that one sketch, and then just making all your modifications from that one sketch. Global variables and equations can be used in SolidWorks models to create mathematical relations between dimensions. Global variables allow you to define a named value within a model, and these can either be set a specific value through a dimension or used in other equations. SolidWorks equations can make use of existing dimensions, mathematical equations, file properties, and model dimensions to build in the desired design intent. By taking advantage of global variables and equations in SolidWorks, you can fully leverage the parametric model and ensure that any features update as intended when modifications are made. In this lesson, you'll learn some techniques in adding global variables and equations, and then using them to control the geometry of your part. This lesson is an important one to pay attention to because global variables and equations are used quite heavily through the CSWA exam. So pay attention and learn everything you can in this lesson, because it will save you a lot of time in the exam, and also future modeling, you'll be able to use this a lot as well. In this model, we have the fillets done as separate features. So fillet 3, fillet 4, and the internal fillet 5 are all done separately. Normally you wouldn't do this if they're all the same dimension, but we're just using this as an example for these global variables. By setting these features to a global variable, we can then control all of them together at the same time. To access the equations dialog box, you go to the Tools menu and then Equations. You can adjust the size of this box by just hovering your mouse over the corner and dragging this out if you want to increase or minimize the size of it. Along the top, there are 4 different views, which controls the dimensions that you're actually looking at, the sort of view types that you're looking at. The first view is the equations view, and this arranges or organizes the global variables and the equations into categories, but only the ones that are available in the model currently. So here you can see our global variables. We don't have any, but there are already actually a couple of equations when I was making this part that are showing here. The next one is the Sketch Equation view. This area allows you to add equations that drive dimension values within a sketch. Here you can also reference existing dimensions or utilize other mathematical functions to drive a sketch dimension. The dimension view will list all dimensions that exist in the model, and dimension names and values can be modified here. And finally, the ordered view option shows global variables and equations in the order they are solved. And by default, equations are solved in the order that they are created. You can actually tick, and I recommend you do tick, the automatic solve order, which allows SolidWorks to determine the automatic order of equations and therefore help prevent any infinite loops that might cause an issue. If you want to search for any specific equations or values or variables, you can use the Filter All Fields area, type in whatever you need into this box. So if I was to say sketch 1, there is no dimensions called sketch 1 or sketches called sketch 1. But if I was to search for 3, you can see there's these two D6 at sketch 3. Or if I was to say D6, it's going to show me any values with D6, which happens to be D6 at sketch 3. So let's go back to the equations view and clear this search bar box that we're using so we can see everything again. And we're going to create a global variable to control these fillets by clicking in the first box. And we can use any name you want for variables as long as they are unique between them. It's good to try and keep them relevant to what you're actually doing so it's more obvious. Since we're creating a variable to control the dimensions of a fillet, they're going to be our smaller fillets in this case, we might just call it SM for small fillet. You can push tab to go across, and in the next box, you'll have a drop-down menu which you can pre-select certain properties if you wish, or even mathematical functions, but we just need to create a name. Sorry, we just need to create a value. So we're going to say equals and 3 for 3 millimeters. The final section is the comments. You can leave this blank, but this is a good area if you want to put in any comments just to help identify global variables. You can look at the comments and see what's described in that area. So here, just for the practice of this tutorial, we'll say small fillet value. With the comment filled, we could drop down to the next line and create another variable and continue doing this, but we only need one variable in this case. So we will then click on OK, and we are back at our main model. To assign the global variable to one of these fillet features, we can double click on the first one to kind of make it active, and you'll see our dimension that is controlling that. We can edit this dimension or this value by double clicking on that again. To assign a equation or global variable, the first thing you need to do is simply push equal on the keyboard, and this kind of tells SolidWorks that you want to use a variable or equation. You could type in the name, but because we've already created the variable, we can just hover our mouse over the global variables, and you can see the SM fillet and the value of 3 is already there. So we can just click on that and then push OK. Whenever there is an equation or variable assigned to a dimension, you'll notice this equation sign that represents that it's being controlled by a global variable or equation. You can click OK, and we're going to continue through that. You'll also see it has a little rebuild icon here, which if you wanted to rebuild the model, even though there's no change, but you'll notice that disappears when we do click on the rebuild. But to continue on, we'll also assign these other fillets. So we can highlight this one. We can just bring this dimension over so it's a little easier to see and repeat the process. So we go equals global variable SM fillet. OK, click to confirm. And our final one, drag this out, double click on it, click OK. You can notice that if you do start to type in, it will also narrow down your selections as well. So if you had a lot of global variable names and you just type in the first few characters, it will refine that selection down. In this case, we only have one. So if I was just to type SM, it's going to be the only one that shows anyway. So that's another way you can quickly select your variables. And you can see it wants to rebuild the model, even though there's no change, but we'll just click on rebuild so that goes away. So now each of these fillets, the fillet 3, 4, and 5, are controlled by by that SM Fillet global variable. So if we simply change the value to that variable, it's going to update all fillet features within the model. So to control or to modify the values of a global variable, you can go back to the equations dialog box. You'll notice, or you should notice in your model, that once an equation or global variable is in your model, the equations folder will show up on the side here. And you can also expand that folder, which will show any global variables that you've assigned or created. If you also want to show this equations folder all the time, you can right click on an empty area in the feature manager tree, go to hide show tree items, and you should see in this feature manager equations, it will by default set to automatic, which is what I was talking about before. It will only show when there is an equation or global variable created in the model, but you can change that to show or hide if you really wanted to for some reason. But personally, I set it to show and push OK. That way it is always just there. I don't have to create a variable or go to the dialog box separately. It's just there every model I do from now on. So I recommend turning that on. Anyway, to change the value, you can either right click on the equations folder or right click on the variable itself and go to manage equations, which is going to bring up the equations dialog box. And I'll just move this out of the side a little bit so we can see our model, because I want to demonstrate what the automatically rebuild checkbox does. I recommend you turn this on because then it acts as a preview to whenever you make changes in the dialog box. So this way I don't have to change a value and then push OK and update the model. It can just do it as I change in the variable box without pushing OK. For example, if I was to change this value to a 5 and tab, you'll notice that the geometry of the model has also updated because of that automatically rebuild is selected. If I was to change this to a 1 and push tab, you can see the fillets are all changing for those features which were assigned the global variable of SM Fillet. And to finish, we'll just change that back to a 3, which is a little close to this line here. So let's just make that a 2. And that gives us just a little bit of room clearance through there. Push OK, and we are done for part 1. Let's move on to part 2, where we can look at controlling the model a little more with equations. Moving on to our last section of this lesson, this model is actually being created using kind of a symmetry type of design. So if I roll back the feature manager past this mirror, you'll see that half of the model has actually been created and then it's been mirrored over to the other side. And what we can do is create global variables to control the width of this part. So let's show you what I mean. We roll that back and we're going to go back into our equations by right-clicking, going to manage equations, and we're going to create 2 variables. We're going to create we're going to call one overall base, and we will set that to 125. And then we are also going to create one called overall boss, and that will be 245. Click OK. We now want to assign those variables to some of the dimensions and start driving them through equations. So if we actually double click on the face of a feature, which is this extrusion, we want to control this 125. So this way we don't have to actually go into the sketch and then access and edit the dimensions. You can just double click on the face of a feature and see the dimensions associated to it. So we can now double click on that dimension, and putting in the equal sign is going to activate it as an equation or a variable. And here we want to assign this 125 to the overall base, which is also 125. No, we're going to change that. We're going to change that to overall boss. But since the dimension is actually half, because we're looking at a mirrored object, we actually want it to be the overall boss divided by 2. So this is how you create equations, and we'll tick the little OK box. Now, if this little symbol here, if you click on that, it'll actually toggle between the resulted formula, which is showing it as 122.5. And if you click on it again, it's just showing you the function. So you can toggle between what you want to display. And then we're also going to control this extruded top section by clicking on the face here. We want to do the 60 millimeter, again, equal sign, global variable, and we want the overall base. And again, because it's half of the width, we want it to divide by 2. So now if we go back into our manage equations, we can actually adjust these values here, say from 125 to 140, and making sure the automatically rebuild is checked. Quick tab, so updates. And we might even change this one to 250. And you'll see the geometry updates automatically in the background too. And then clicking OK to close the dialog box. If you don't see any change, you can force the change by clicking on the rebuild up at the top here. So that completes the lesson on global variables and equations. It's really important to have a good understanding of this lesson, especially variables are used so much through the CSWA exam. So if you can at least become familiar with this, it's going to help you a lot through the exam. And also later on in your 3D modeling experience, it's going to be really beneficial to know how to use equations and variables in your dimensions. In SolidWorks, the status of a sketch depends on the geometric relations and the dimensions that define it. The three most common sketch status types are underdefined, fully defined, and overdefined. This status is shown in the status bar at the bottom of the SolidWorks interface. A sketch has the status of underdefined when it doesn't have enough sketch relations and dimensions to fully constrain the geometry of the sketch. A sketch has the status of fully defined when it has enough relations and dimensions to fully constrain the geometry. And finally, a sketch has a status of overdefined when you might have too many relations or dimensions that are trying to control the same geometry. As an example, you may set a line to be perpendicular to itself, so it should be a 90-degree angle. But then you try and add an angular dimension and set it to 60 degrees, that's going to cause a conflict, and therefore put the status as overdefined for that sketch. Fully defining a sketch in SolidWorks is best practice as it allows you to create features without any geometry issues or rebuild errors. In this lesson, I'll use this underdefined sketch and add relations and dimensions to make it a fully defined sketch. So here we have an undefined sketch, and the status can be seen that it's undefined, which will be down in the status bar just about here. Unfortunately, you won't see it because of my webcam is centered in this position, but it would be in this sort of location just here. And I can see it says underdefined. So there are a number of sketch relations and dimensions that are missing to make this sketch fully defined. Visually, you can tell when a sketch is underdefined without looking at the status bar because of the color of the sketch entities. So when a line is black, like these lines around the side, this means they are defined, they cannot move. But the lines that are in blue means they are underdefined and they can move around. For example, if I try and drag this element around, it won't move anywhere because it's defined in place through sketch relations and dimensions. But if I was to take, say, this blue line and drag it around, you can see that not only does the element move, but anything sort of connected to it also moves. So this means that they are undefined and need either relations or dimensions to constrain them in place so they cannot move. So what we need to do is add any final relations and dimensions, and this will fully constrain the sketch and then it won't be able to move out of place. To do this, we need to identify what relations and dimensions are actually missing. And the first most obvious way of finding these or identifying them is to use whatever reference imagery you have of the sketch you're actually creating. So in this example, I have this screenshot of the part that we're actually trying to make a sketch of, and it has all the dimensions and sketch relations already on it. So we can use this as a reference to see what we're missing, and this is good practice as well. Whenever you're dimensioning something from reference like this, try and keep all the dimensions in the same place. So when you're referring back to it, it's easy to check off, even using like the pen tools to mark off any dimensions that you have in place. So in this reference image, we can see that there are some dimensions missing for the arcs of the radius of the arcs. There is also some overall height and length dimensions missing. And there are also some sketch relations in these areas which look to be tangent relations. There is also a point here which isn't implied there is a relation there, but there is actually a relation. And that's because we only have one dimension in the vertical, but we don't have a horizontal dimension. So therefore, we have to assume that the center point of this arc is coincident to this line. Now let's go ahead and start adding these relations and dimensions to our sketch to fully define it. It's also important that it makes the job a lot easier to add any sketch relations first and making sure they are in place, and then adding dimensions in place. It just helps with the sketch process, makes things less trying to fight against each other when you're putting these in place. So do the relations first and then the dimensions if you can. So for this example, we're going to have to add these tangent relations and then this coincident relation here. We can do that by, if you've seen the earlier lessons on sketch relations and dimensioning, if you haven't watched it, check it out before this video. But to add a relation and tangent relation here, we can hold down Control, select this line, and then select the arc, releasing the control, and then you should see this contextual menu pop up, and we want to pick the Make Tangent relation, and we can click OK. Going down the bottom, we also need a tangent relation between the arc and the line here, and then also a tangent relation between these two arcs. So again, holding down Control, clicking the first line and then the arc, letting go, selecting the Make Tangent, and then again, selecting the first arc, selecting the second arc with the Control held down, letting go, making tangent, and clicking OK. So we can now see our tangent relations in place. And if you don't see those relations, you can just go up to the view and drop that down and then click on the view sketch relations. That way you can always see them, or you can turn them off if you want to as well. The final relation we need to add is a coincident from this the center point of this arc to be coincident with this line. So we can click on the center point, click on the line, letting go of Control, and then selecting the Make Coincident, and then clicking OK. So that's all our sketch relations in place based on the reference image we were using. Now we need to add any dimensions. We want to identify any dimensions that may be missing, and the first obvious ones are the overall length and the overall height, which may be a bit hard to see on your screen, but the length is 81 and the height is 57. And you can see on my sketch here, we don't have those dimensions. So using the Smart Dimension tool, we can first add the overall length. So we can click the furthest left element and then the furthest right element. So that's giving us an overall dimension, and we can just place it down here. So that first one was 81, clicking OK. And in some cases like this, you may find that things get really messed out of proportion. And that's just because it's trying to fit things around the constraints you're putting in. And so you may need to go back and start sort of adjusting little bits here and there, just pulling things back in place as much as you can so you can actually get the dimensions working again. And you might have to fight with this a little bit, but eventually you can see, here we go. We've pretty much got it back to how it should be. And if you go back to, if I just undo and try and tighten it up a little bit, but I think that should do for now until we add some more dimensions in. So the next dimension we needed to add was the overall height. So let's put this one in and see if it wants to play nicely. So we'll pick the bottom line and the top line, place this over to the side, and this one was 57, clicking OK. So you can see that's tightened up again now, and these arcs are still wanting to mess around, but we can further refine those in place by adding some more dimensions. Again, you can just push escape and we can just move these elements around again just to kind of get them into an area we want. So just bit by bit you can adjust these so it looks similar to our reference image. We might just bring that about there, and then having a look back at our reference image, that's pretty close to the shape. So if we go and add more dimensions now, it shouldn't throw it out too much like it did in that first example. You'll notice that a few more lines have now turned black, so they're constrained in place. And the only ones that are really left are these arcs on the top and the bottom. And that's because these arcs need dimensions as well. We need a radius for these arcs. And if we have a look at our reference, again, it may be hard to see on your screen, but the top one is a radius of 19. And then we have a 5 and then a 29. So again, using our Smart Dimension tool, we can just click on the radius and place it in the spot you want, and then put in a 19. For this arc, we want a 5, and the final one I think was a 29. So all this is constrained, but we can still see these two arcs are not constrained. And because that means there is one final dimension probably missing. If we can't see what's obviously missing, you can actually play around by moving elements around to see what's allowing it to kind of move out of place. And that should give you an idea of what you need to put in place to actually constrain it. So if we were to take, we know these arcs are somehow not constrained. So if we just start dragging one around, maybe just trying a few points, so we can see what's happening here. Everything seems pretty locked in place except for this center point of the arc here. So what that is indicating to me is that we need a vertical height. And if we look back at our reference, there is a vertical height of 19. It doesn't have a horizontal because it doesn't need one because of that coincident relation on the diagonal line, but it does need that vertical dimension. So if we go to our Smart Dimension tool, we'll click on that center point and then the bottom line, drag it off to the side, and that was 19. And that locks it all in place. And you won't be able to see, but down the bottom, like I said before, just about here on the status bar, you should see that the sketch is now fully defined. And we can test that by just moving anything around as well. We can see that nothing is moving out of place. Everything is constrained, and we can then use this to build features from. Remember, it's good practice to use sketch relations and dimensions to fully define any sketches you're creating. For one, it's going to help minimize any issues you have when you're creating features and getting any geometry conflicts. But number two, which I found was most important to me, was it avoids making accidental mistakes either by yourself or maybe a coworker. Say, for instance, you're away for the day and a coworker had to continue working on this model and you didn't have this dimension here. And so therefore it's not a fully defined sketch, and the co-workers just accidentally just move something out of place and they don't realize it. This happens, and then they start building from it. And later on you're thinking like, why is this part not correct? There's something wrong with it. And then you realize someone's moved it, and that's because it wasn't fully defined and it happened. So I find that is the most important reason why you want to fully define your sketch, just to avoid any of those accidental issues that are really hard to track back when you're not expecting it to be because it wasn't fully defined. Welcome to the final lesson of Chapter 1. Well done, you've made it this far, you're doing great. So Chapter 1 has all been about sketching in SolidWorks, and sketching is really the fundamental to part modeling in SolidWorks. So it may be a bit of a boring topic, especially if you know a little bit about this already, but for the complete beginners, this is where you start. You have to start with this sort of information. Once you get used to it, you can pretty much draw whatever you want and model whatever you want, but it really comes down to these fundamentals of sketching in SolidWorks. So what are we going to do for the last lesson of the chapter? And what we'll probably do for the other final lessons in each chapter is to do a bit of a review and a little bit of a put you to the test kind of exercise. So what we have here on the screen is actually the sample CSWA exam, and we'll cover more of the exam later on as we complete this series, but we're just going to have a quick look at this for the moment. So this is the CSWA sample exam, and you can download that in the description of this video. So open that up and you want to go to this page here, which is part 2, modeling. What we're going to do in this lesson is, using all that we've learned so far with sketching in SolidWorks, is to recreate this model using all our sketching tools, dimensioning, sketch relations, and even some variables where it has these A and B notations. We're going to recreate this, and then to finish, we're just going to do a simple extrusion to create the final part. In Chapter 2, we'll start to move on to actually extrusions and cuts and more of that 3D modeling. But in this lesson, you'll just get a very small taste of what it it's about. So if you want to challenge yourself, I recommend to pause the video at this stage using the sample exam in the description of this video. You should be able to download it and go to this page, the part 2 modeling, and try and recreate this. You don't have to extrude it at this point, but just try and recreate this sketch using all these dimensions and any relations like these tangent relations here, which was also actually covered in the previous lesson. Some of that was covered. And then you want to get to a point where the sketch is completely ready. And if you want to push yourself a little bit further, use variables for these as well. So you might make variables of, overall length and overall height or width, then going on to the next page and actually setting in those variable values. So pause the video if you want the challenge, try to complete the challenge or this exercise, and then come back. And what I'm going to be doing is actually going from scratch right to the end of making this part, just so you can see how I would do it. All right, so if you just pause the video and try to complete the exercise and you completed it, great. You're probably ready to move on by this stage into chapter 2. Otherwise, if you struggled a bit, that's fine. Now let me do it and you can see how I do it. So the first thing we want to do, of course, is we're just going to put this off to the side. We need to, of course, create a sketch or a model. So we can go to the new, we want a part file, and we click OK. With our model ready to begin, we need to pick a plane, and design intent will be covered, I think, in the next chapter. But for the moment, we need to pick a point of where we want the origin to be. The origin point is simply the 0 point of the model, the absolute center of the universe of the model, basically. And you want to try and pick a point that works with your model as you go forward and start extruding and such. This kind of comes with practice of just knowing where to put it, or the best places to start your model. Otherwise, try and look for features in the model that kind of represent a point to use. And looking at this, it's quite an odd looking shape. So you don't really have any sort of corner mark or any real set area, but we do have this center point of the circle. So in this case, I would actually use that as my origin and build the model all around that center point. So here we can see it from a side profile, and in an isometric, it'd be right in the middle of that cylinder. So it'd be right in here. That's where your origin would be. And you also want to look at how the model is structured. So I generally try and follow the reference working files we have. And you can imagine this view being probably the front view and this being a side. And then this, of course, is your isometric. So try and build around like that. There's no point putting this front view on the top view, unless you really had to, unless you had some specific reason to do that. But otherwise, that's my front view. So that's where we're going to start our first sketch, would be on the front view. If you can imagine that face of the sketch being here and then extrude it out. So we want to start a sketch on the front plane. I'm going to have to sort of switch back and forward between this window. But what you want to do is first just start roughly sketching in the shape as best as you can. And in this, I'm going to use a lot of shortcuts and such as well. So try and keep up with that. So we got a circle there, and then we have kind of like this cut and a bit of an arc, and then it drops down, another arc, and then across. So let's just try and quickly use our lines and our arcs to draw that shape. So selecting my line, I'll probably start from here. I know it goes up and across, and then I know it cuts down. Whoops, so I made a little bit of a mistake there, but I can just go back and delete those two. Going back to my line again. I know there's an arc here, so going back to that point and then dragging it out a little bit so that arc begins. And then what do we have? We have the arc goes up to the top and goes back, so we can come across here. There's a little 45 again, another cut down here. Then it goes across here. We have another arc, so bring it back to that starting point. Try not to do a full circle because we know it's going to be tangent, so you don't want to be kind of locked in with any relations. So you sort of want to get it to a point like here. And then we have our secondary arc. And then I think we have our third arc, don't we? So we bring it back to here. So you can see it kind of wants to do a 90, but we just want it to like be here just in case we need to fix it up. And I'll just check that because that doesn't seem right. Okay, so we got one arc and then it turns in. So I actually did these arcs the wrong way. So we can just go back, delete those, go back to my line. So that first arc was this way and then it went back that way. So you can see here it's trying to do a really weird sort of one. So let's just drop it here, going back to the point, back over, and then it goes across. And then it goes 45 and up, but I don't want another secondary line here. So I'm just going to go right up to this point. Okay, so we got a very, very rough shape there, but now we can start putting in our relations and dimensions and tidying it up. So the first thing I want to do is do this circle in the middle, because the first dimension that you place, the rest of the model will automatically adjust to it without throwing everything out. So if I put 14 for this, which is 14 mil, and you can see it sort of throws out and comes back down, but everything's still where it is. If I'd start with another line, it might start to throw out the circle. And anyway, it's just user experience. I know what it's going to do. So that really bases the rest of my model around that point. The next thing I want is any relations. You want to do your sketch relations first and then do your dimensions afterwards. It just makes things a little easier. So we want to put in some, can we do a 45? I don't think we can. No. Okay, we'll come back to those ones. We do have a tangent here already. If you don't see your sketch relations on screen, you can drop this view icon down and enable the view sketch relations. Otherwise, we need a tangent here. We do know that. We have a tangent here already, and we have one here. So those are fine. So we just need one tangent relation there. And we also need this center point to be coincidental on this line. And if we move it around, we'll see if it's going to break things too much. It doesn't look like it. Let's just see what happens. So we'll hold down Control, click the center point and the line. Going to make coincident, and it has thrown it out a bit, but that's fine. We can, whoops, and I accidentally went. If you accidentally do this, see I've actually rotated it because I was holding down the middle mouse button. Just click on the sketch and then go normal to, and that's going to throw it back to looking at that sketch front on again. So here we've kind of made a little bit of a mess of our drawing, but if we just sort of move things around, we can probably get them back into the correct place. It can be quite frustrating sometimes to try and fix things up, but see how we go. And if you find it really just doesn't work, just delete the line and just put another one in. Like, there's no harm in just doing that. We can trim this off. So all this is sort of like in the wrong area. We need this back around here. And we've got our tangents in here now. So we can start actually adding some dimensions. So let's have a look what we have and try and place the dimensions as they are with our reference images as well. Let's begin with the angular dimensions. So we know all these are 45. This one's 45. And this one is 45. And this one is not 45. It's got a different angular dimension. Okay, so this one, we might delete this line because it's a little bit different to what it should be. Sometimes it can be really frustrating with what SolidWorks wants to do and what you want it to do. Okay, so we have all those. Let's see what else we can do. It's good to try and start dimensioning things away from our origin point just so it can kind of constrain outwards from that point. So let's start using these dimensions here. So we've got 14 and 14 from the corner. So if we go from the center, this one is 14 and this one to here doesn't want to play nice. We could try that again, just escape when it doesn't work. Okay, there we go, 14. Okay, and again, that's really thrown it out, but we just need to go through, start adjusting things so they play nice again. So you can see what I mean. Sometimes you just have to throw things back in place, and if it's really too difficult, just delete it and then add the lines in manually. The next ones we need are this 7, and this one is also 7. We have a total height of 32. We have a 10 to this location, and we also have an angular dimension of 10 degrees. So it's getting there. It's still quite thrown out of proportion, but we can try and adjust this a little bit. There we go. And what's next? So we have a radius of 19. We might as well put this one in. There we go. What else? We have a radius of 5. That might help tighten this up a little bit if we put the 5 in. And a radius of 29 for this one. But yeah, let's give it a try. Let's see what happens if we do this one. Actually, we're going to try and put this coincidental in here And then we're going to try and adjust it out a little bit. Let's see how we go. Really doesn't want to play nice, does it? Okay, that's, geez, it's really messing up on there. Okay, what I'm going to do in this case, I'm going to delete that one for the moment. Come back down, go across, draw that in. I'm going to try and make these back to tangent, which was incorrect. It should be actually the other way. Selecting these two, making them tangent. I think what we need is to put some of these lines, like more dimensions around here before we can get that coincidental in place. So in some cases, you can't put those sketch relations in first. You have to do the dimensions so it will actually work. So what we want here is 29. This one is 5, 24. And what else do we need here? We can see this arc in the base here is really messed up. So what we're going to do is we're actually just going to delete all these parts and come back and do them again. So we're going to pull this one across. We got our 19, we got our 29, we got our 5 and our 24. So all this is pretty much in place. Seems a little high though. So I think we just need to bring this down a little bit like that. And then we need a line here and we're going to go across. We have 29 to this. So let's chuck in this 29 at least. So that might help. Okay. And then we just need these last curves coming in. Might try and use a 3-point arc. So I'm going to go 1, 2, and just like make it a little less steep. And then same for here. 1, 2, 3. So that's tangent. We need to make this tangent as well. We need a dimension back on this one, which was 5. And I think now we'll be able to put in that coincident relation. So yeah, there we go. That's working in this case now. We can tighten that a little bit. We can then give it a height to that point, which was 19. Looking much better now, and a radius of 29. Okay, so the final, if you can go through if you want to, you don't have to, but it's nice to just clean these up a bit so you know where your dimensions actually are. And when you're looking at the reference image, you know you're looking at the correct, oh, see, we can see this one should have been 14. So we know this is wrong because we had it matching our reference. And that's pretty much it. Now to save our work, because we don't want to make a mistake here, don't click the cross because that's going to exit without saving any changes. So you want to click on the top one. And at least now you can go ahead and save your work as well, which of course you do by going to File and Save or Control S for save. We'll go back into our sketch. It's good practice, really, really, really good practice to always save your work. Whenever you make changes, save your work. There's no point doing 3 hours of work only for SolidWorks to crash and you just lose everything. Get used to saving. So we just need some dimension that is going to finally constrain the rest in here, and that would be a overall height and an overall width. And if we go back to the reference image, you can see we have a variable, global variable of A and B. So we can actually go to create our variables now. So we can go to Tools and Equations. And our first one is A. And I might just make that A length, just so I know my own. Or you could actually put it as A. We're going to put in a default number for now. It doesn't really matter. A 100. And comments is width. And then we need B, which we're going to say is just 60. I need to double check these, but this will be comment of height. We go back. It is going to say in the first question, A is 81, B is 57. A, 81, B, 57. I don't know, you want to change 57. And just double check 57. And there is a C, which would be, okay, so C is the extruded width, so we don't need to worry about that yet. We can put C in since we're in here already, and it was a 43 value, and we're just going to make that the extrusion. I cannot spell extrusion. Okay, I know that's wrong, but we're going to keep it as that. And then we're just going to say, okay, go back into our sketch, and we first will do the overall length. And if you remember, you put in an equal sign to make it a global variable, and we want to select the 81, click OK. And then we want to do this top and bottom, equal sign, global variable B. And even though we've done those, there seems to be one more thing missing because we can see it's not fully constrained yet. If we check our status in the bottom here, right about there, it says underdefined. So what we need to do is just move a few things around and see what moves. So if we drag this, okay, so we know there's some sort of height, some sort of vertical that's controlling this that is not showing up. We look back at this image, we have, let's have a look, we're kind of, it's gonna be something around here. Okay, I found it. So it is this 19 here. That's what we're missing. That's setting that base point from here, so it's locking it in. So if we go back, we add this final 19, click on that and make that 19. And that finishes it. Everything is locked in place. It's all black. It says it is fully defined. And so our sketch is ready to move on to the next part. So we can exit our sketch. And we need to now extrude it. So this is going to be more into the chapter 2 stuff where we start looking at actual part modeling. But to give you an idea, what you can do is you go to features. We want to extrude the part, give it some volume, and we pick our sketch. We are going to set it to a mid plane because we want it to be equal on both sides. We don't want it to extrude just on one side. And we are going to set the dimension to a global variable, which you can do also in this area. Go to C and we are complete. But we actually made a mistake here. We need to go back, edit the feature because we need to use our contour. We actually do not want this section here. And there we go. We finished our little model. And if we wanted to go in and adjust any, the overall length or the overall width, or probably an easier example would be this extrusion, we might make this extrusion 100 mils. And we can just do that through the equations dialog box without having to go into any sketch. So that completes Chapter 1. I hope you've enjoyed it. Now, if you can do that, you can move on to the next chapter and we can start going into more exciting stuff such as extrusions and cuts and revolves and really get into some more part modeling. And so jump into Chapter 2 and let's continue our SolidWorks beginner series. To begin Chapter 2, I want to take a moment and talk about what is design intent. The basic meaning of design intent is that it is a method of design in SolidWorks to create relationships between objects. And due to these relationships, if a change is made to one area, it automatically propagates to another. But design intent goes further than just the basics. Design intent is a way of thinking when you model a part. You think about how a part is best created. You think about where the origin point should be used and then your part created around the origin point. You think about what feature tools should be used and in which order. You preempt what design changes could be made in the future and how that may affect your model and what the most efficient way you could incorporate that into your design. Can you use global variations and equations in the design process so that changes can be easily made, possibly even creating variations of the part on the fly? And after all this, you need to think about what is the most efficient and effective way of modeling this particular part in SolidWorks. That is what design intent is in SolidWorks, and it is something that becomes over time through experience. You'll begin to understand all these little things without even really thinking about it, and it will become an automatic process whenever you begin a new part in SolidWorks. To give an example of some really basic design intent, we're going to use this image on the screen. Let's imagine that a designer has given us a sketch of this part and he says, I want you to recreate this in SolidWorks, but there is one main condition you need to consider. And so the designer says that this cutout through the center here, it's always going to be based around the center of this part. So he says, keep that in mind, draw it as as it is now, as I've given it to you, but just keep in mind that there may be some changes in the future of that cutout in the middle, and it's either going to be, maybe it's going to be in the center or the other side of the part, but just do the model as quick as you can so that we can make those changes in the future. And so you go back to your desk and you begin modeling this part. So here I have the basic extruded rectangle already created, and we need to create this cutout on the side here. And this is where some design intent starts to come into play. So we need to think about this cut shape through the middle. And we know from the designer, he said specifically that it's always going to be in the midpoint of this part, and that design changes may happen and it's going to be somehow related to that center mid plane of the part. So we know that there's no point doing a sketch on this side of the face and then cutting it to the center, because if that change was to then be put to the other side, we would have to delete that feature and then do the whole process over again on the other side. Same goes if the designer was to say, okay, we need that cutout to be in the middle now. We would have to then delete the feature we created on this side and then create a sketch in the mid plane, and etc. So it's not really effective or efficient to be creating a sketch on this side. And we need to think about, okay, we know that it's always going to be in the mid plane. We know that any change is going to be related to it. So maybe we should be creating our sketch on the mid plane of the part and then controlling the cut from there. And that's what we're going to do. So we're going to create a sketch on this front plane. Like, I've already created the origin point of this shape to be in the center of the part, as you can see here. The origin is the center right here, knowing that later on I'll need to create the mid plane in the middle there. So again, design intent, I don't have to actually create my own plane to try and get the center of this part. I can just simply use the front plane because I know that is the center of the part. So moving on, we create the sketch on that part, and we're just going to draw that basic shape. So we know it goes across, comes down, comes back up, and then finishes there. We can exit our sketch, go back to our isometric, and we can then cut the part. So we want to flip the direction, and we can probably just say up to next, and then cut the part. And there you go. We have our first design created for our designer, and we give that part to him. Next week, he comes by and says, okay, we need that cut on the opposite side now. We don't want it this side, we want it on the right side. And because of our design intent, we know that all we need to do is edit the feature that we created originally. So we go, okay, no problem. We go to this feature, we edit feature, and we just flip direction, click OK, the part's done. We give that to the designer. He's happy. Took us, no more than 10 seconds. Otherwise, we would have had to delete the feature, create a sketch on the other side, etc. That is design intent. It's knowing, it's preempting these changes that could happen. So now the designer comes back. He says, we just need the cut through the middle now, and it's going to be 30 millimeters wide. I go, okay, no problem. So we can go to edit feature. We will change that to mid plane, change the width to 30, and we push OK. And we now have a cutout directly through the middle. Again, thanks to the design intent, it is very easy to just modify that one part. And finally, the designer says, okay, we need that cutout again in the center, but we want it to the left of the mid plane. So it just needs to be moved over. It can't be in the center. It just needs to be on the mid plane. No worries. We go back to our edit feature. We're going to just do our regular blind, flip the direction, and we keep it at 30. And there we go. So as you can see, because we thought about where those changes are going to be taking place, knowing that it's all going to be based around the mid-plane, that's where we started our feature and our sketch so that we could create those changes without having to delete features and then adding new ones or anything like that. We could control it all from the one feature, make the changes super, super simple, and just do it on the fly like that. So again, design intent comes with experience. It is something you just get familiar with, and after a while, you don't even think about these little details. You simply know the best way of doing something, or at least probably the best way of doing something, and just going straight into it. You don't have to think about those small minor details every time you design something. But until you get to that point, there are some great resources available to help you with your design intent in SolidWorks. First, take a look at my part model challenges. This is where I find some interesting working drawings online and then try and recreate the parts in SolidWorks. This gives you a step-by-step process to how I personally would create these parts as a SolidWorks professional, and gives you some really interesting information along the way. Another resource to use is to jump onto YouTube and search for the SolidWorks Model Mania challenges. This is a big series. I think there's maybe 15 or 20 videos of professional SolidWorks challenges. The Model Mania is a competition that is held by SolidWorks each year, and they take a really complex part, or what may seem simple that is quite complex once you start to think about it. And in stage one, you have to create that part as quick as you can. After part one is done, they will show you a design change that needs to be done, and you then have to make that change and model it as quick as you can. And so the winner is whoever can do it the fastest. These videos showcase some amazing SolidWorks drafting from very professional SolidWorks users. So I really recommend, once you become a bit more familiar with SolidWorks and you get the hang of just basic modeling, definitely check out the Model Mania videos, because it will give you some really good tips on how to create complex parts in SolidWorks, and some really good design intent information on how they do that as well. When creating extruded boss or cuts in SolidWorks, the end condition must be specified. End conditions can either be set by a specified distance or by utilizing existing 3D geometry. There are three types of end conditions that are defined by a specified distance away from the sketch plane. They are the blind end condition, the through all end condition, and the mid-plane end condition. The blind and through all end conditions are set by specifying a set distance away from the sketch plane, while the through all end condition continues through all material in a single direction. There are 5 types of end conditions that are defined by using existing 3D geometry. They are up to next, up to vertex, up to surface, offset from surface, and the up to body end conditions. The offset from surface end condition also requires a distance to specify how far it should stop before the selected surface. In this lesson, you will use a combination of end conditions to create this custom block and determine which end conditions are most suitable based on the design intent for this part. Let's begin by starting a new part model file, and we want to create a sketch on the front plane. We will use the corner rectangle, and starting from the origin point, you could just drag a rectangle out and then set some dimensions. So it would be 125 millimeters high by 65. And then exit the sketch. Our first feature will be the extruded boss base using a mid-plane end condition. This is an end condition that doesn't require any pre-existing 3D geometry. To start this feature, make sure the sketch is selected and then go to the extrude boss base. Make sure features tab is activated first. And by default, it will be selecting the blind end condition. The blind end condition just extrudes it to a set distance, and it doesn't really take into account any 3D geometry. By default, only one direction is selected. So we can see it is extending out from the mid-plane or our sketch plane out in this direction, but you can actually do 2 directions, so it's extending on both sides, and we can drag this out. The difference here when you're selecting direction 1 and direction 2 is you can set independent distances on each side. So I could have a short side here and a longer side on here, or however you want to do it. You can actually specify independent distances on either side. But for our part, we just need a symmetrical mid-plane end condition, as it's going to be the same on both sides. So unticking direction 2, we change the direction 1 to mid-plane, and we are going to select a distance of 65 and clicking the green check box. So we now have a symmetric feature directly over the front plane as the middle of our block, and both sides are equal on either side. The next feature we will create is an angled cut on the side of the part using a specified distance, which will use the blind end condition. Again, we are going to use the front plane, clicking on that and creating a sketch. And then you can just use the line tool to draw a profile similar to this. And then we can dimension it. So we're going to have 20 here, 20 to this point, and an angle of 60. That's fully constrained, and we can exit the sketch. This time we're going to use the extruded cut feature, so we can select our sketch and activate the extruded cut. Again, notice that the blind end condition is selected by default. It's basically always selected by default. You can currently see that the cut is going to this side of the block. If you want to make that cut on the other side, you can click on this reverse direction, which will reverse the direction like that. Or you can actually just click and drag on the arrow and drag it to the other side. Another way of creating the cut is by offsetting where the cut begins by changing the from selection box. So if we change that to surface face plane, and then we can pick this face here, and now the cut is going to start from that face. We can use the blind end condition. We'll reverse the direction, and we want to use a measurement of 25. Click the green check mark, and we have our cut on that side using the select face surface. The next feature we will create is a circular cut, which ends on the face of this block here, this angled face. And we can do that by using the up to next end condition. To create this sketch, we can rotate the part so we can see the back, and clicking on the back face and then starting a sketch here. We want to do a circle, which is going to be 8mm diameter. We want this to have a distance of 12.5 from this top edge. And we want it to be in center of this line. So if we click on the center point of the circle and then the center point of the line, and then selecting the vertical relation, and this will fully define it into that location. We can exit the sketch and go back to our isometric view. Having our sketch selected, go to, again, the extruded cut. And here you can see by default the blind end condition again. And we could use this and create that cut through so it finishes. But if there was any other geometry on this side, it's just going to continue cutting through all that material without any regard apart from the distance you set. So we actually want it to finish on this face of the angled surface. We can do that by dropping it down and going to up to next, and that will stop the cut at the next detected face. So it's going to finish the cut there. Click on the check, and there we have our cut finishing on that surface. This is a geometry dependent end condition. So as long as this face exists, it will always cut to that face. If that face was to move in a different position, it will still cut to that face. But if that face was removed for some reason, the geometry changes, you'll then have a rebuild error, and it will say that it can't make that cut because the face is missing. So just be aware of that. The next feature we will add is a cut on the underside of this block, and it will always match the angled face a set distance below it. This will require the use of the offset from face end condition. Rotate the part so you can see the bottom face, and click on the bottom face and go to create sketch. And then using the rectangle tool, the corner rectangle, just pick a spot and drag it across. Select the center point and the origin point and make coincident. This will align it to the center, keeping both sides symmetrical, and then add a dimension, and we will make this 30mm. You can then exit the sketch and go back to your isometric view by pushing Ctrl+7. In the Feature tab, activate the Extruded Cut. And in this case, we haven't selected the sketch beforehand, so you can either go to the Manager tree here and select the sketch, or you can just click on the sketch to activate it. By default, the blind end condition is selected. We will change that instead to offset from surface, and making sure the face plane selection box is activated, we will pick this face and change the dimension to 15. That might be a little too small. We will change that to 10 and click OK. So you can now see this cut is always in line with that face there. Our last feature will be another circular cut on top, going right through the part. So we can select the top face and create another sketch. We're going to use a construction line from the origin point straight across, making sure it is completely horizontal. And then that way we can create a circle at its midpoint, so we know that that circle is created right in the center. And we want a diameter of 6mm. We can exit the sketch and go back to the isometric view. So having that sketch selected, we can go to Extruded Cut. And as you can see, if I was to just drag that down, I could make a cut through the whole part. But blind end conditions will only ever cut up to the distance you specify. So if this block ever changes height and becomes longer beyond the cut length, it's not going to cut all the way through the block. So we want an end condition that will always cut through the entire block. And what we can use is the through all end condition. So this will mean that no matter what, it will always cut through the entire block from one side to the other, and any geometry beyond that as well. If for some reason you had geometry on the other side of the sketch plane that you wanted to cut away from as well, you could actually change that to through all both, and that way it is cutting through both directions for infinity. But in this case, we only need through all, making sure the direction is going down, and you can click OK. This end condition is only available in extruded cuts. It's not available in the extruded boss. And our custom block is now complete. So using a combination of different end conditions, we were able to put some design intent into this block and create specific cuts and extrudes to fit the situation in the most effective way possible. Knowing which end condition to use for extruded cuts and extrude bosses will just come with practice, but play around with each one in different situations to get an idea of how they work. And from that, you'll learn which are the best to use in specific situations, and that way use them the most effective way possible. Finally, don't forget to subscribe to the channel and like the videos if you have found them helpful. Models are produced in SolidWorks by creating 3D geometry from 2D sketch profiles. This is accomplished by using extrusions, which extends a profile along a path, and this then becomes solid geometry. The two most common types of extrusions in SolidWorks are extruded bosses and extruded cuts. Bosses are used to add material by taking a 2D profile and extending it along a path. Usually it's perpendicular to the sketch profile. Cuts are used to remove material by taking a 2D profile and extending it along a path, which again is usually perpendicular to the sketch profile. So a cut is the opposite to an extruded boss. So both are used in the same way by taking a 2D profile and extending it along a path and either adding material or removing material. In this lesson, we'll take this base plate and we'll add a cylindrical extrusion to the top, and then we will cut away a rectangular hole through the middle of that extrusion. So here we have a simple part that uses a basic profile. It then uses an extrude boss, an extrude cut, and a fillet, which just goes around the outside edge here. And we are going to use this part to first create a sketch, which then we can use to create an extruded boss, a cylindrical shape up the top. And then in the middle of that, we want a square cut out through the part. On the left-hand side of the screen here on the feature manager tree, you can see that the boss extrude, the original one, is already here. And if you expand that, you can see the sketches that were used to create that feature. If you were to click on the sketch, you can actually make this sketch visible in the graphics window at all times. And you can do that by clicking on the sketch and clicking on the show icon. And you can see the sketch is now visible in the graphics window. You might want to do this if you need to use it as some sort of reference. It's not often used, but you can do that. You'll also notice that the icon has turned blue to say that the sketch is visible. And if you want to turn that off, you can just click on it again. Click on the eye icon, which now says hide. It will change to a grayed out icon and the sketch is now gone. The very first thing we need to do is actually create the 2D profile that we can use to extrude. So of course we need to create a sketch on this top front face. And as you know, we can create a sketch by just clicking on the face and going to sketch, or by going to the sketch over in the tools. With the sketch activated, the first thing we want to do is create a circle. And this circle is just dragging out to here. And before we carry on, I just want to show you a quick tip in SolidWorks with creating entities and having the ability to set dimensions to them in the same command. So you may notice that when I create an entity like a circle, a little dialog box is showing, which is asking for a measurement. So if I was to say 50, it will put it in and add the dimension for me. Normally, the procedure would be that you may have to create a circle and then dimension it. So it's an extra step, and you can see my method is a little quicker. If you want that same feature available in your SolidWorks, you can change that in the options. So if you go up to the tool here, the little gear icon, drop that down and go to options. In the Sketch section, you'll see the Enable on Sketch Numeric Input on Entity Creation. You want that ticked, and you also want Create Dimension only when value is entered. So that means whenever you draw an entity like a square or a circle or a line, you can, before placing it, with the second click, you can just type in a number for the length you want or the diameter or whatever it is, and it will create the dimension and size it to that dimension. So it just saves an extra step of creating it and then creating the dimension on top. So you can do it all in the one command. So I recommend having that on. Anyway, we don't need these, so we'll delete them. Next thing we need to do, we actually want this circle to be concentric or co-radial, sorry, with this filleted edge. So we want to click on that line and click on the inside filleted edge and click on the co-radial relation. So this will just make sure it's always following that same radius on the outside there. And for the second part of our profile, we need that square cutout, which is going to be in the middle. So we can use the center rectangle and just drag it out. I could put in a dimension, but I want this to be a perfect square. So I'm not going to put in a dimension in this case. I'm just going to click on there. And I want to pick two of these lines, this one and this one. I want to make the relation there equal and click OK. So this will mean that those two sides are always equal, which will make all the rest of the sides equal due to the other relations. And that way it's a perfect square. And I just need to make a dimension here. So I'm going to make that 35. And you can see now that our sketch is now fully defined. So we can exit the sketch and clicking Control-7 to go into an isometric view. So we now have our two profiles in the one sketch, which is our circular extrusion and the center rectangle or square cutout. The next part will be to actually use the extruded boss to extend the 2D profile and create material. This can be done by going to Features and then click on the Extrude Boss Base, or you can click on the sketch in the Feature Manager tree and then going to Extrude Boss Base. And in this case, I had the 2D profile already selected, so it's just gone ahead and use that as the profile. But if I didn't have a sketch selected and I clicked Extrude Boss Base, it's going to ask you for a 2D profile or a sketch. So you can either click on it or you can expand this feature manager tree here and select your sketch that way. Once the command is activated, you'll notice a preview on the screen. So it is showing you a preview of what that extrusion is going to be. You can extend the extrusion by either dragging this arrow in that direction or dragging it the other direction. This is setting a length to the extrusion. Or you could set the actual length in the options on the side here. So you could say 100 millimeters. To change the direction, you could either drag it the other way, or you could just click on this reverse direction button, which is going to switch the direction, obviously. So we want it in this direction. And we also want it to be 40 millimeters for our extrusion. The merge results checkbox, most of the time you'll always have this ticked, and it just means that whatever you're extruding, if it's connected to some other body, it's going to merge it into one solid body. So if you for some reason wanted two separate bodies, so you're doing like a multi-body part, which will be covered in a later lesson, you would untick that, and then any extrusion is going to be separate to any other model bodies in the drawing. In this case, we want the merge result because we're just after the single solid body. Also, you'll notice there are a few other options over on the left, so we'll just cover them quickly. The from sketch plane you can change, so by default it's always going to extrude or cut from the sketch plane that it's been drawn on. You can change this to say like surface plane, vertex or offset, so there are some options here. Also the type of extrusion, there are some options here, so blind, through all, to surface, etc, etc. I recommend that if you don't know what these are, to watch the previous video, which is about end conditions, which will cover those two areas. In this case though, we just want a blind extrusion. You can also set a secondary direction. So there is an option to do a mid plane, which is going to extrude it equally on both sides. But what you could do if you needed an extrusion to have a particular length on one side and then a particular length on the other, you could make it two directions. So therefore you could say, I want 10 millimeters on the left and 50 millimeters on the right. So you can do that with a direction too. Or you can even play around with that more. You could even say up to surface for the other side, but the direction 1 is a blind. So you have some options there as well. Thin feature is another option. And what you can do with thin feature is use a simple 2D sketch to create an extrusion. One way of looking at this is this profile we created is just a circle and a square. And if we pick thin feature, you can see here it's trying to extrude like the whole contour. But if we picked thin feature, you'll notice that it's kind of giving it some thickness. If we adjust that to say 5 millimeters, you can see it's changing. So what's happening here is, imagine drawing a circle. If you wanted just a tube, normally you'd have to draw 2 circles and then extrude that profile. But with thin feature, you could just draw the 1 circle and then it will create thickness around that 2D profile and extrude it. It also has the ability of extruding open paths, which means normally you'll need a full closed profile to be able to extrude it, but an open profile is when it doesn't connect back to the original point. So you might be drawing a square but only do 3 sides. Normally you can't extrude that because it needs to be closed off to create the profile to extrude. But with thin feature, you can be extruding just the 3 lines and creating thickness around those parts. I won't go into more detail about that in this lesson, but just be aware thin feature is something you can look into in the future. So make sure that is unticked. And then selected contours. This is selecting the actual profiles or the contours that are being extruded. And I'll show you more on this once we actually do the extruded cut. But for now, that's just how we want it. So after all that, we can click OK, and we now have our extruded cylindrical material. The next step is, you'll notice that there's no hole in the middle, and we want to punch that and cut it out to the other side. And because our original 2D profile, we created both the cylinder and the square, we can use that same sketch again to create our extruded cut. So by going to the features, this time we want extruded cut, and it's asking us for a sketch, making sure our feature manager tree is expanded. We can expand this boss extrude that we created and then click on the sketch. And you'll notice at the moment it's still trying to use the whole profile to cut backwards, but we only want that inside square. And this is where the selected contours comes into play. So if you drop that, right click in there and say clear selections. And then while making sure this is still highlighted, which you can tell because it's blue, we want to click that inside square contour, as that's the only thing we want cutting back. And in this case, we also want to use a different end condition. So the end conditions are these ones here. At the moment, it is set to blind. So it's just blindly cutting away up to the length of, in this case, 40 millimeters. But we actually want that to always cut all the way through the part. So we want a through all condition. This will make sure that no matter how far the part changes, it may become thicker, it will always cut all the way through, at least in that direction. If we needed it in both directions, of course, then you would change it to through all both. So it's cutting front and backwards, but due to the way we extruded it, it's always going to have the hole in the front anyway. We just want it to cut all the way to the back. So through all condition, and click OK. And we can now see that we have our extrusion and our cut through our base part. One other thing that you might not be aware of is you can actually rename any of the features on the side here. So if you wanted to make a little more clear for yourself, or maybe someone else that is working on the file, you may want to rename these features. You can do that by either clicking twice slowly on the feature and then typing in a name. So we'll call this one cylindrical extrusion. So you can do it that way, or you can do it by just clicking once to pick the feature and then pushing F2 on the keyboard, which will rename an object. And in this case, we want it to be square cut. So the name can be anything. You can also rename sketches as well. So we can just rename this one to say like default sketch or whatever you want. It can be any name. It's just whatever you feel might help you understand your model more. So this video just covers the basics on the extruded boss and the extruded cut commands, which are probably the most common material sort of modifications you're going to make in SolidWorks. If you want to get more detail on the end conditions, I recommend watching the previous video specifically about end conditions. And so that's the end of the lesson. If you enjoyed it, please subscribe to the channel, like the video, and let's move on to the next lesson. As a designer, you will at some stage need to make some changes to a 3D model. When a model's design intent has been redefined, it is important you understand how a model was created, and then you can identify which features to edit in the Feature Manager tree. In this lesson, you will learn how to use the rollback bar to see how a model was created, and I will also explain a concept called parent-child relationships. To finish, you will learn how to use a variety of editing tools in SolidWorks to make changes to features, sketches, and sketch planes. Just a quick reminder, if you want any of the part files from this lesson, you can check that in the description. There will be two files. One is the beginning file, which is the one you see on screen now. So you can use this to follow along with the lesson. The second part file is the completed part file from the end of the lesson. So in case you want to just check how it should look at the end with all the changes we make, you can take a look at that one as well. Both of these files are for SolidWorks 2019 version, so you'll need 2019 or higher to be able to actually open the files. Before we begin, it's important to understand how a part file was made in SolidWorks. This will allow you to identify whether you need to edit features or sketch profiles whenever you need to make a change to the geometry. One way of doing this is to use the rollback bar in the Feature Manager tree. The rollback bar is this blue line in the Feature Manager tree on the left, and it allows you to go back in history through the part file. What it's effectively doing is suppressing any of the features afterwards, and so as you move the bar higher, you're going to an earlier and earlier state of the design process for that part. To give you an example, if we roll this bar by clicking and holding and then dragging it all the way to the top between the first boss extrude and the fillet and let go, you'll see that it's taken us back to the very first extrusion of the part. This was the very first feature of the part, and if we expand that, we can also see the sketch that was used to create the feature. Later in the lesson, we will need to edit this 2D profile as we're going to want the arc to be intangent to the top face of this part. If we move the rollback bar forward to the fillet, we can then reactivate the fillet feature, and you can see that the fillet has been applied to these two top edges of the part. So as you can see, the rollback bar is suppressing any features afterwards, and it's giving us a feature by feature or a step-by-step process on how this part is being created. If we then move the rollback bar to the next one, to the boss extrude, we can see that it's been used to create this circular tab on the side of the part body. Again, taking another step forward, a mirror feature is then used to create the circular tab on the other side of the part. Next, the shell feature has been used to hollow out the part as well as adding holes through these circular tabs on the side. The shell feature works by removing material up to the thickness you specify and also any faces that you select on the part. This means that because the circular cutouts have been produced using the shell feature, it means that those cutouts are directly tied to the shell feature. Later in the lesson, we will want to decrease the size of that hole, which means we're going to have to edit the shell feature to be able to change it. Moving along to the final feature is the cut extrude, which has added a simple hole cut through the side of the part. In this lesson, we will want to remove these holes completely, but we'll be able to reuse them in the circular tabs on the side later. This will require us to move the sketch plane and edit the sketch profile. Now that we understand how the part was created and what features need to be changed, we can now go ahead and modify the geometry. As we already have a shell feature, we want to first rearrange this order so that it comes directly after the fillet. This will remove the holes from the circular tabs so they're no longer directly related to the shell feature. To do this, we can click and hold and drag the feature up and down the Feature Manager tree. You may notice that it prevents us from moving it any higher, and this is because of parent-child dependencies that exist in the features. This currently makes it impossible for the shell feature to exist before any other features. A parent feature is an existing feature that other features depend upon in order to be defined. A child feature is an existing feature that depends on a parent feature. In this case, the shell feature is the child, which references the side faces of the circular tabs, which makes the boss extrude feature the parent. We can also check the parent-child relations by right-clicking on the feature and going to parent-child. In the window that is displayed, we can see that the shell feature has 3 parent features that are tied to it, a mirror feature and 2 boss extrude features. This means that the shell feature cannot exist without the base shape and the 2 circular tabs. If we want to reorder the shell feature, we are going to have to remove the dependency on these circular tabs. We can do this by editing the shell feature. So if you click on shell and go to edit feature, we want to remove the dependency on these two circular tabs, which is being caused by using the face of those tabs. So we can just click on those two faces to remove them from the shell list and click OK. We can see that the shell has been modified to still cut out the internal, but we no longer have a full cut through the circular tabs and therefore removes the dependency on it. If we again right-click on the shell feature and go to parent-child, we can see that now only the Boss Extrude is the parent of this shell feature, which allows us to now reorder the shell feature to just after the fillet feature. So now the shell feature only affects the base shape, and the holes we can add back in later on in the lesson. The next modification we will want to adjust is the contour of the back face, so that it is tangent with the curved face, which will make the fillet run all the way to the end. We know that the sketch profile of the first extrusion is what drives this shape, and so we need to modify the sketch to make the change. We do this by clicking on the Boss Extrude and going to Edit Sketch. Here we can see the curve in the top line come to a sharp corner. And because this sketch is fully defined, we're going to have to remove something to allow some movement back into the sketch. We want to keep this 3-degree angle and we want to make this arc tangent to it. So what we can do is right click on this radius dimension and delete it, which will give us some control back. While holding Control on your keyboard, click the arc and this top line and then make it make tangent. Click OK to accept the change and then exit the sketch. If we go back into an isometric view, you'll now notice that it is staying in a tangent relationship and curving down nice and smooth. But why was this fillet feature automatically applied all the way to the end? Well, if we take a look at the fillet feature, we will be able to see why. If we edit the fillet feature by clicking on it and going to edit feature, you'll notice that the tangent propagation is checked. What this does is add fillets to all edges tangent to the edge selected originally. The last modification we want to make is to remove these holes in the side of the part, and we may as well reuse it and relocate it to the circular tabs on the side. So again, by clicking on the feature, we can go to the feature and click on Edit Sketch. We want this circle to be concentric with the circular tab. So we can do that by clicking on the circle, clicking on this edge and going to concentric. This will make sure that these two circles always align centrally with each other. Clicking OK and exiting the sketch. If we go back to our isometric view, you may wonder why nothing has changed, but if you turn it around, you'll actually see there is a cut on the insides of the part. So what's going on here? Well, if we go back to our feature and edit it, we will see that it just has a blind extrusion of 60 mils, and that is going from the original face, which was this outside face. So really it's only cutting away from the inside edges, but there is still too much material on the outside with these circular tabs. We can change this by moving the position of the 2D profile to be on the outside of the tab and then cutting all the way through. So to change the position of the sketch profile, you can expand the feature, click on the sketch and go to Edit Sketch Plane. Here you'll see what is currently the sketch plane and click on a new face, which we want to be this outside face of the cylindrical tab. Click OK, and you can see it now has updated and it is now cutting, but it's not cutting all the way through. So the final modification we need to make is to the cut feature, clicking on it, going to edit feature, and instead of using a blind, we can just use a through all end condition. So we'll change it to that and click OK, and we can see our hole is cut all the way through the part. So this is how you would take a part file and look through the history of it to see how it was created. This is useful when, say for instance, someone sent you a part file and they want you to make a change. You can go through the history of the part and see what features were used in what order to create that part. And then you'll be able to identify which features and which sketch profiles need to be changed to edit the geometry in the way you need it. So that ends this lesson. Don't forget to subscribe to the channel, like the video, and let's move on to the next lesson. Revolve features are created by revolving a 2D profile around an axis. The process is similar to extruded features. The difference is that revolve features use a circular path, while extruded features use a linear path, which is usually perpendicular to the sketch profile. Revolves require axis-symmetric geometry and a line that is used as the axis in a sketch. In the right conditions, a sketch line can also be used as a center line. In this lesson, you will learn how to create a piston head using the revolve feature. to create a revolve feature, we first need to create a sketch. So let's use the front plane, clicking on the front plane and going to Sketch to begin our sketch. Using the line tool, we can start from our origin point and go directly up and then hitting escape. Reason being is I want to change this line to a construction line. So we can click on it and go to construction geometry. Now this line will act as our center axis of revolution. Using the line tool, we can continue from that line we created, go across, going down, across, waiting for that inference line back to the origin point, and then across to the origin, pushing escape to finish. Before we dimension the rest of the profile, we want to make sure that we're using diameter values instead of a radius value. And we can do this by using the construction line we just created. Be aware that because we created a construction line, it has actually changed this profile to an open loop instead of a closed loop. But we can still use this profile to create a revolved feature. In many cases, the profile won't be directly connected to the axis of revolution. Now we can begin adding dimensions to fully define this profile. Using the Smart Dimension tool, click on the construction line and then the outside edge. And you'll notice that we just have a regular dimension, which if we place now would act as a radius for our revolution. We want to use this as a diameter value, and you can do that by just going to the other side of the construction line, and you'll notice the dimension changes to a full diameter value. SolidWorks automatically recognizes that you want to use a diameter whenever you dimension to a center line and then go to the opposite side of it. So if we now place this and put in a value of 150, we now have a diameter value of 150 mils. We also want this piston head to have a continual wall thickness. And one way of doing that is by selecting our construction line and this bottom line and giving them an equal relation. Now, if we use the Smart Dimension tool again and either dimension this construction line or the bottom line, as they are both equal, we can just dimension one of them and we're going to give it a value of 20 millimeters. This way, the wall thickness is always continually 20 millimeters due to that equal relation between those two lines. The final dimension we need is the height of the piston head. So again, using our Smart Dimension tool, we can click on this outside. We want a height of 125 mils. Clicking OK to select. And if you want a quick shortcut to zooming the extents of the drawing, you can just push Ctrl+1 on the keyboard. The sketch is now fully defined and we can exit this sketch. To create a revolve feature, there are two ways we can do this. We can either go to the menu at the top, going to Insert, Boss Base, and then clicking on Revolve, or in the Feature Manager, we can make sure our Features tab is selected and then go to Revolve Boss Base. We want to select the sketch as it's asking to select a sketch. And you'll notice that it's saying that the sketch is currently open. Would we like to automatically close the sketch? And we will say yes. So that is due to that construction line we created and the loop not being completely closed, but SolidWorks can automatically close it for us. In the options of the Revolve feature, you'll notice that the axis of revolution has already been selected. That is because in our sketch profile, we created that construction line, and SolidWorks is smart enough to realize that it's going to act as the central point of revolution. So it automatically selects it for us. But if you wanted to change it for some reason, you could right-click on that area and go to Clear Selections and then pick something else to act as the axis of revolution. But in this case, it is correct and we'll just leave it as it is. Also, you'll notice in the graphics window, there is a preview of the revolution showing. If there did happen to be other contours that you wanted to select, you can change this in the Select Contours and then go through your sketch, picking individual contours to revolve. Similar to extrude bosses and extrude cuts, the options are very similar. So we have our direction 1 and our direction 2. We also have a thin feature option, as well as the just mentioned selected contours. In our directions, we also have the ability to select different end conditions. Finally, you have an input value, which is the angle of revolution. So, of course, a full 360 degrees is going to be a full revolution, but you could change that to 180 for a half revolution, or 90 degrees for a quarter, and of course, anything in between as well. You can change the direction of the revolution by clicking on the reverse direction. But in our case, we do want the full 360 degrees. With our options all selected, we can just click on the green OK check mark to complete the feature, but there is also another way which you should get familiar with. Whenever you're creating features, normally you can right click and go to OK to complete the feature. And this might be just a slightly faster process to going over to the top and clicking all the time. Our piston head is now complete with the center cut out as per our sketch profile. And before we move on to a revolved cut, I want to show you a quick way of checking measurements. Normally you would use the measure tool, but there is also another way you can check measurements. If we were to click on the face, you can see down around about here in the status bar, it'll say diameter 150. Unfortunately, you can't see it in this case because my camera display is covering it, but that is a quick way you can check dimensions. We are now going to use the revolve feature again to create a revolve cut around the outside face of this cylinder. To begin, we need to create another sketch on the front plane. So clicking on the front plane and going to Sketch. This time we're going to use a center rectangle and using the outside edge of the cylinder, just dragging out and dropping. This is going to create an automatic relation between the center point of the rectangle and the outside edge of the cylinder, therefore making sure this cutout is always on the outside edge of our cylinder face. This will give our model better design intent by making sure if the cylinder ever changes shape, the center point of the rectangle is going to follow the edge with it. Also notice that the way we placed the rectangle, the edge of it is outside of the face of the cylinder. This is best practice when creating revolved cuts, as it makes sure that all the material is actually being cut away from the body of the part. Using our dimension tool, we want to create a height of 15 millimeters for our rectangle. We are going to give it a distance from the top of our cylinder head of 25. And the final dimension is from the outside edge of the rectangle to the silhouette edge of the cylinder, and we're going to make that 5 millimeters. This makes sure we always have that 5 millimeter overhang from the face of the cylinder. We are now ready to exit the sketch and create the revolved feature, but I want to show you a quick little shortcut. Whenever you plan to use a sketch profile to create a feature, instead of exiting the sketch and then starting the feature, you can start the feature directly from the sketch, and therefore it'll automatically select that sketch to create the feature. So we haven't exited the sketch, but we want to go to the features and we want to create a revolved cut. So SolidWorks automatically knows that we're going to use our sketch profile to create this revolved cut, but it does need an axis of revolution. You may also need to select some specific contours, but this process should save you a little bit of time. Now for the axis of revolution, we didn't create one in this profile, and that's because we want to use the original sketch profile we did and the axis we placed in that profile as the axis for this revolved cut. This way ensuring that the revolved cut is always central with the original revolved feature. If we just drag out and go to a bit of an isometric view, what we want to do is expand our design tree and go to the original revolve so we can see the sketch, right click on that sketch and go to show. And that way we can see the original sketch in our graphics window. And so for the axis of revolution, we can click on that and pick our center line. So SolidWorks is now giving us a preview of the cut and all the options are the way we want them, and we can click on OK. The last thing we want to do is hide that sketch we just showed. So we can right click on the sketch and go to hide, and this hides it from the graphics window. So our cylinder head is now complete. So we have our revolved cut through the outside face, and we can also see the inside of it like this, and that completes this lesson. There's one more tool I want to show you as a bonus in this lesson. That is, whenever you create a part which may have some sort of internal geometry like this, and you want to get a better view of it instead of trying to sort of look underneath or to the side, you can actually create cross sections. And you can do this up in the top here of the SolidWorks. You'll see a sectional view. If you click on that, you get this sort of sectional view created. You have some options here which you can play around with, which will act as different planes you can work from. So we can either do it from like a top or a side or this. You can drag where the sectional cut begins. You can also rotate and drag around a bit more and then click OK. So you can create some really interesting sectional cuts, and it's not actually removing anything. It's just sort of hiding it from the visibility. And it might just give you a better view so you can sort of play around and do some more sketching and referencing. And then when you're finished with it, you can just go back up and click on the section view to bring it back to its normal state. So that was just a quick bonus tip in this lesson, but that does bring us to the end of the lesson. So don't forget to subscribe to the channel and like the video, and let's move on to the next lesson. When modeling in SolidWorks, you often want to add rounded or angled edges to the part. The feature used for this is called the fillet feature and the chamfer feature. Fillets create a rounded edge by removing material and smoothing out the edge. Chamfers are done in a similar way but provide an angled edge. There are some general rules to keep in mind when using these features. Number 1, leave cosmetic fillets until the end of the modeling process. Number 2, try and create multiple fillets in the same command if they have the same radius. Number 3, when you need fillets with different radiuses, it's often best to create the fillets with the largest radiuses first and then work down from that. And finally, number 4, the order in which you create fillets is important, as when you're creating fillets, it's also creating additional surface faces, which can then be used in turn to make more filleted edges. In this lesson, we'll use the fillet feature tool to create fillets on this part, and then we'll move on to another part to create some chamfer features. As always, don't forget you can find the exercise files in the description of this video. These files are created in SolidWorks 2019, so you'll need 2019 or newer to actually open these files. There are 2 files for each part. One is the beginning stage and the second part is the finishing stage. So you can check what it should look like at a completed stage compared to the beginning stage of the lesson. You can start the fillet feature command in 3 different ways. First, you can go from the Features tab in the Command Manager and then click on Fillet. You can go to the Insert menu and then go to Features and Fillet Round. And finally, right-clicking on an edge of the model, you can then select Fillet. So let's start the fillet command by the first method of the Features tab in the Command Manager and clicking on Fillet. Before we begin adding fillets to the edges, I'll first explain some of the options available in the Property Manager on the left. First, let's make sure the option is set to manual. Under that, we have the fillet type, and we have a few selections available here. So the first one is constant size fillet. Then we have variable size fillet, face fillet, and full round fillet. Each of these will control the fillet in different ways, so it's worth playing around with them. But I'll show you a little bit more in depth on each one. Before we go into detail on each one of the fillet types, we'll cover a few more of the options. Again, we see the tangent propagation option. This allows for all edges tangent to the selected edge of face to be filleted. Below this are some options for the preview. We have a full preview, which is going to show a preview of the fillet on every edge you select. Then there is the partial preview, which will only show the preview on the first edge that you select. And we finally have the no preview, which is obviously not going to show any preview of the filleted edge in the graphics window area. For this section, we are going to make sure that tangent propagation is selected and full preview is enabled. Also, down the bottom of these options, you'll see fillet options. And if you click on that to expand, there are 2 more options to enable in here. They should be on by default, but they should be select through faces and keep features. So make sure those 2 are ticked. With our options set, we can now begin selecting the edges that we want to fillet. As we selected the Select Through Faces option, you'll notice that I can actually click on lines that are hidden behind the model face. So if I wanted to click on this back edge here, I actually can pick that line through the face by just hovering my mouse over the correct area. So that is what Select Through Faces do. It can just make it a little bit easier for selecting faces behind things instead of having to rotate the model around and pick different areas. Whenever you select an edge by clicking on it, you'll notice a menu that pops up. This allows you a quick access menu of selecting different edges that are kind of related to the original edge you pick. So as you just hover your mouse over and move it over these different options, it's going to give you a preview of the additional edges that it may select So if we go to the connected to start virtual face, it's going to pick 7 edges. So we'll just pick that. And as you can see in the preview, it is selecting the original edge plus these edges inside and outside and also on the bottom. We want these 7 edges selected, but we don't want these 2 bottom edges selected. And therefore at any time you can actually deselect edges simply by clicking on them again. You'll also notice this little call out that is coming out, and you can move this around if you wish to by clicking and dragging. This is the radius for the fillet. So you can change the radius either by updating it in here, and we can change it to 5 millimeters, or you can change it in the fillet parameters over in the left-hand panel. Before we finalize this fillet, we also want these inside edges to be filleted with the same radius of 5 millimeters. So clicking on this, it will select the rest of the loop because of that tangent propagation that we enabled earlier. With all the edges we want selected, we can just click on OK, or as I mentioned in a previous video, you can actually right click and go to OK to finish the feature. So what if I wanted to make an edit to that fillet radius? Well, as with the same thing with other features, you can simply click on the fillet and go to Edit Feature, and then you can change the radius either through the call out or through the fillet parameters, and let's just change that to 2.5 mils. Right click, go OK, and you can see all the fillets have actually updated to the 2.5 millimeters. That is because all the edges that you select that create that fillet are controlled by that one radius. So in saying that, we want to finish this model by adding a fillet to the rest of the edges, but we want it to be a larger fillet. We want this fillet to be 5 millimeters. So that's why we need to create yet another filleted feature. Going back to our fillet, we want to have the fillet parameter set to 5 millimeters, and this time we want to click on this top edge, and you'll notice that it is now selecting a loop all the way through, and that is because of, again, the tangent propagation due to the first fillet we created. It has actually created these lines to be tangent to each other and therefore created a loop within it. So we want both this top edge and this top edge, which is going to do the loop on the other side. Checking that our radius is 5 millimeters, right click and go OK. Control 7 to go back to an isometric view. This completes adding all the fillets to this part. Next we'll move on to the second part, which we will use for creating chamfers. Here we have a new part that we want to add some chamfers to. The chamfer tool can be found in the 3 ways that are similar to the fillet tool. The only difference with the first one is that in the Features tab in the Command Manager, you can find it by clicking on the arrow of fillet and finding the chamfer there. The other ways, such as the Insert, Features, and chamfer, you can see here it has its own individual selection. And same when you right-click on an edge, you can also click on chamfer. So let's start a chamfer by clicking on that arrow for the fillet and selecting chamfer. Similar to the fillet feature tool, we have options on the side here to control how the chamfer behaves. Again, we have a variety of chamfer types that we can select from. These are the angle distance, distance, vertex, offset face, and face. Continuing through the options, in the Property Manager, we also have tangent propagation, the 3 types of preview options, and a section for parameters which will control the distance and angles that you select. And finally, the chamfer options, similar to the fillet feature, has both the Select Through Faces option and the Keep Features option. Let's take a closer look at each of the chamfer types. The angle distance type specifies how far away from the edge to begin the chamfer and at what angle the chamfer should cut at. To demonstrate this, we'll use a distance of 5 millimeters with an angle of 30 degrees. We will then select these 6 top edges of the part. So looking at the preview, you can see what the chamfer will look like using that 5 millimeter and 30 degree angle. We can flip the direction of this by clicking the flip direction. But if we do that, it's going to make the chamfer a little too close to this hole cutout. So we're going to go back and disable that. The distance type specifies how far away the 2 resulting edges of the chamfer should be away from the selected edge. For this particular chamfer type, the chamfer parameters has 2 options, asymmetric and asymmetric. By selecting the asymmetric, you are able to specify 2 different distances. So let's set the first one to 5 millimeters and then the second one to 2.5. We don't have an option to reverse the directions here. So to change this around, we would need to just change the values in the parameter boxes. Next, the offset face chamfer is defined by offsetting the faces that form the selected edge and creates the chamfer based on the intersection of those offsets. This option is especially helpful for non-planar faces as it will generate more predictable results. The face-face chamfer requires faces rather than edges to create and has expanded parameter options to create more specialized chamfers. Let's switch back to the distance chamfer and clear the selections by right-clicking in the Items to Chamfer dialog box and going to Clear Selections. Now I can show you the last chamfer type, which is vertex. This chamfer type uses a single point as the selection and uses 3 distant values to define its shape. So if I select the vertex or like a corner point, you can see it's creating a chamfered cut on that corner. And we have 3 options here to control how that chamfer will look. To finish this part model, let's clear the selections again and go back to our distance type. Make sure symmetric is enabled and we will set the distance to 3 millimeters. Reselect the 6 top edges of the part, and then you can either click on the green check, but as I've been promoting in these lessons recently, you can just right click and go to OK to finish the feature. So that is how you create fillets and chamfer features in your model. That is the end of the lesson. Don't forget to subscribe to the channel and like the video, and let's move on to the next lesson. The Hole Wizard is a fast and easy tool to use in SolidWorks to create many different types of holes in your model. It can create simple, tapered, counterbored, countersunk, and tapped holes for both standard and customized sizes. One of the most intuitive aspects of the Hole Wizard is that you specify the size of the hole by the fastener that goes into it. Another reason is as you start to do the working drawings for the model, any holes that are being created with the Hole Wizard will be automatically annotated in SolidWorks, this way saving you some additional time. In this lesson, you'll use the Hole Wizard to create a couple of different types of holes and how to position them on the model. Here we have the model that we're going to add a couple of different type of holes to. You can download this part file in the description of this video and then follow along with the lesson. Be aware this file was created in SolidWorks 2019, so you will need SolidWorks 2019 or newer to be able to open and use this file. A key point of the Hole Wizard feature is that it creates the majority of the sketch profiles for you. All you need to do is create the sketch profiles for placing the position of the holes. The Hole Wizard feature can be accessed by either going to the Insert menu and then going down to Features and Hole Wizard, or in the Features tab of the Command Manager, you can find the Hole Wizard feature there. Click on it to activate the tool. Once activated, you should see some options in the left-hand panel of the Property Manager. There are 2 tabs here, one for the options that control the type of hole, and the other is the Positions tab, which controls the position or the location of the holes. First, we will define the shape of the hole in the Type tab, and then select where the hole or holes are to be placed on the model using the Positions tab. But before continuing, let's go over a few of the options. The first section we have is the favorite section. So here, if you're finding that you're using a common type of holes, whether they be like M10s or M5s, you can add or remove these from your favorites. That way you don't have to create these settings on the fly each time you use the Hole Wizard. Next, we have the hole type. And in this, we have the counterbore, countersunk, hole, straight tap, tapered tap, legacy hole, counterbore slot, countersink slot, and the straight slot. For this exercise, let's select the counterbore. Make sure the standard is set to ANSI metric, and then the type is going to be set to hex screw. For the hole specifications section, set it to M8 and the end condition to through all. Also make sure the fit is set to normal. If you click on the Show Custom Sizing, it will give you some additional areas to put in values to further control the size and shape of the hole. But for this exercise, we don't need it, so just make sure that is unticked. There are also some tolerance position values that you can control as well. Be aware that some of these options will change depending on the type of hole you are working with. Leaving the rest of the settings to the default settings, let's move on to the Position tab and actually place our hole. You'll notice in the dialog that it's asking us to select a face so that we can place the location of the holes. If you were to be placing holes on multiple faces, you could use the 3D sketch option, but this will not be covered in this particular lesson as it's more of an advanced technique. If you did need to put holes on multiple faces of the part, you could get around that by just using the hole wizard feature on each of the faces. Also be aware that you can place holes on planes and non-planar faces. That means you could place a hole on a cylindrical face. In this exercise, we just need the hole on the top face. So we will click on that in the graphics window, and you can see it's now asking us to place the hole. What you're looking at now is basically the sketch environment. So you do have all the sketching tools such as lines and circles, but the main entity, the main sketch entity you want to work with is the point. The point is just a single point in space, and SolidWorks automatically knows to use those points for the center location of each hole. So if you wanted to create multiple holes, you could just use that tool and place multiple holes around the face. In this particular exercise, we only need to use one. And due to using sketch entities and being in the sketch environment, you can also fully constrain and add dimensions and relations to lock in and fully define that sketch. This also means that we can take advantage of the automatic relations in the sketch environment. For example, in this exercise, I want to place this hole so that it is concentric with the circular body of this part. So if I hover my mouse over the edge, this will wake up the center point of that shape, and then I can click on the center point, therefore creating a concentric relation between the hole and the body of the part. Just remember, you can place as many holes as you want on the face for this hole wizard. So with our hole placed in the correct location, you'll also notice that the sketch is fully defined in the status bar down here, and we can move on. So by clicking the green check mark, we'll accept the hole wizard feature, and we can push Ctrl+7 to go back to an isometric view. So as I said earlier, the hole wizard works by automatically creating the sketch profiles and then basically cutting out the shape of that profile to create the hole. So if you go over to the feature manager tree and expand it, you'll see that there are actually two sketches created for this feature. The first, if I click on it, you can see is the profile shape of the hole. And all that is doing is automatically creating that sketch profile based on the values we put into it, and then it's Revolve cutting it through. The second sketch profile is actually the location point of the hole. It's not recommended to edit these sketch profiles directly, so if you did need to make any changes to the hole feature, as with all other features, just click on the hole wizard feature and in the menu go to edit feature. You could then on the fly change this to a completely different hole type if you wanted to, and that is the beauty of the hole wizard feature, is that you can create one specific type of hole and use that, or you could go in and edit it and completely change it to something else. We don't need to make any changes in this case, so just exit out and we are back to the main model. Let's do one more example before we finish. This time we will create two holes simultaneously by using the one feature. Again, launch the hole wizard feature, select the hole type as hole, standard will be ANSI metric, and the type will be set to drill sizes. Change the size to 7 millimeters. And you may have to scroll down a bit to get there. So 7.0, and make sure the end condition is set to through all. Move over to the positions tab and click on this side face here. Again, normally you would place your holes first and then use the dimension and relation tools to fully define those locations. But again, we can take advantage of the automatic relationship and hover our mouse over the shape of this body so that we can see the center point and then click on the center point. This way we are creating that automatic concentric relationship to that area. If I just rotate this model a bit, you'll see that because of the through all condition, it is actually going to punch a hole through both sides of the part all the way through. So if we click OK, you can now see that a hole is created and it's punched right through the part. As mentioned earlier, the other aspect of the Hole Wizard feature is that when you start doing your working drawing, any holes you create with the Hole Wizard will automatically be annotated for you, thus saving you some time in that secondary process of creating the shop drawings for the part. This won't be covered in this lesson as it's a separate lesson to go through, but in this lesson we just sort of practice using the Hole Wizard to get an idea of how it works in a modeling environment. That brings us to the end of this lesson. Don't forget to subscribe to the channel and like the video, and let's move on to the next lesson. The Linear Pattern tool allows you to replicate geometry in a linear fashion. It allows you to pattern geometry in a single direction or two separate directions in a single step. The copies are referred to as instances and are based on the original geometry, which is referred to as the seed. If changes are made to the seed, the patterned instances will automatically update to reflect the changes. In this lesson, we will see a few examples of how the linear pattern feature works and also cover some of its options. Please consider subscribing to the channel and like the video, and let's begin the lesson. In this exercise, we're going to use this model on screen and use the linear pattern feature to create a pattern of the button. The button would be considered the seed, and any copies of it would be referred to as the instances. You can download the exercise files in the description of this video. Please be aware that you need SolidWorks 2019 or newer to actually open the files. To start the linear pattern feature, you can either go to the top menu, go to Insert, and then Pattern Mirror, and from there you should see the linear pattern. Or with the Features tab activated on the Command Manager, just go over to Linear Pattern. Click on that and the command will then activate. When activated, you'll see all the options on the left-hand side in the Property Manager. These are all the options and parameters that can control the pattern you're generating. In the Direction 1 group box, you can specify the direction by selecting any entity that establishes a vector such as a line, axis, linear dimension, or model edge. So making sure that the selection box is activated, we're going to click on this top edge of the model here, and this will act as our direction. Before we adjust the parameters that control the spacing and number of instances, I want to show you something in the bottom of the Property Manager, which is the Features and Faces group box. This is where we select the geometry that we want to pattern. Selecting the geometry first will allow us to see a preview of the pattern, therefore making it easier to make any adjustments to the feature. In this area, there are a few ways you can select geometry to pattern. So the first one is features to pattern, such as extrusions or cuts or other features. You can also select faces, and you can also select entire bodies. Since our button is just made of a simple extrusion, we will use the features to pattern. So clicking in that box, we can then expand our design tree if you don't have it expanded already, and then click on the Boss Extrude. Now you should see a preview on screen of the pattern. Let's go back to the top of the Property Manager and we'll start adjusting the parameters of our pattern. In case you ever want to reselect or change the direction vector, you can clear it by right-clicking on it and either clearing selections or delete, and then picking another direction vector. In this exercise, we don't need to change it, so just make sure that top edge is still selected. If the preview instances are going in the wrong direction, you can change that direction in two ways. You can either click on the reverse direction button, or you can click on the arrow in the graphics window. So be sure that your previews are showing into the model like mine are. The next two areas define the distance between instances and the number of instances to pattern. So here you have the distance and here you have the number of instances. Patterns can be defined by distance and number of instances, or by patterning up to a reference and spacing them evenly across a distance. In our exercise, we actually want to change this to up to reference. We first need to pick our reference. So similar to the direction vector, we just pick a model edge and we're going to select this edge right here as our reference edge. We have a few more options. The first is a distance and a few other options here. And instead of set spacing, we want to change to set number of instances. So we're going to specify the number of instances as 4 to our reference. So you should see it like this. And then we want to change our distance here to 12.5 millimeters. And your preview should look similar to what I have now. You may also notice that the preview only shows 3 copies of the seed. This is because the number of instances is the total including the seed geometry. To create the pattern in a second direction, we are going to go down to the direction 2 and expand that and continue the process. So we first need to specify our direction, so we can select this as our direction. This way we're going to have the pattern both across and down. And this time we're going to stick to the default, which is the spacing and instances for our direction 2. Change the distance to 20 mils and our number of instances to 6. In this case, you can see that our preview is showing it in the wrong direction. So click on the reverse direction to make sure it is showing like it is on screen now. You will also notice the pattern seed only checkbox. And if you click on that, you can see how the pattern changes. What this is doing is taking the seed geometry and then just patterning in one direction. And then it is taking the seed geometry again and patterning it in the other direction. So therefore only creating a pattern of the seed geometry. But when that is unticked, you have something more like this full grid of instances. What's happening here is that it is taking that first seed geometry and patterning it across in a linear fashion. And then it is taking that full pattern and patterning it again downwards. So that's why you end up with this full grid look. Another option to be aware of is down the bottom here, instances to skip. And if you click on that to expand it, you'll notice all these little purple dots show on each instance. By clicking on these pink dots, you can actually cancel or hide or skip any instances that you like. So you can create these custom patterns if you wanted to. And if you wanted to bring those back, you could either just clear your selections here or just click on the pink dots again, which are now white, to change them back. With our pattern ready, click OK to accept the changes. SolidWorks also offers a convenient display option to show the seed feature within a completed linear pattern. If I click on the linear pattern here, you'll notice the different color for the seed and the instances. So one color is for the seed geometry and the other color is any instance copies of it. This allows you to quickly identify where the pattern is originating from and how the seed is driving the pattern. Also, if you hold your mouse over the linear pattern, you'll notice this flyout appear, which is full of information about the pattern. If this flyout is not appearing, it's likely because the option is turned off in the settings. If you click on the gear icon on the top of the screen, you'll open the options for SolidWorks. Go to the Display tab and scroll down to the bottom and you should see Display Pattern Information Tooltips. So make sure a tick is in that box and click OK. And then when you hold your mouse over the pattern, you should see the flyout. The linear pattern feature includes an option called Instances to Vary. When this option is enabled, it allows you to vary the spacing for each instance, as well as vary the dimensions for the pattern geometry itself. Let's go through a demonstration. Launch the Linear Pattern tool and go straight down to the Selecting Geometry section. Expand our design tree and select the Boss and the 2 Fillets. Back up on the top section in the Direction 1 group box, activate the Direction Vector Selection tool and click on the back edge of the model. This time we're using spacing and instances, and we want to set the distance to 40 and the instances to 4. Now let's go down to the very bottom of the property manager and you're looking for instances to vary. So click on that to activate it. The field at the top allows you to vary the pattern spacing by typing in a value that will increment with each instance. So let's enter a value of 10. This means the spacing between each instance will increase an additional 10 millimeters on each instance. You can also choose feature dimensions to vary throughout the linear pattern. In the graphics window, if we zoom in a bit and make sure the selection box is activated, you want to click on the 15 width and the 40 height. And when you do that, you'll see some cells appear like an Excel spreadsheet. So it will tell you the current value, which is 15, and the current height value, which is 40. You can double click on the cell and put in a value, which will increase the dimension as it varies throughout the pattern. So let's have the width increase by 5 millimeters on each instance and the height increase by 10 millimeters for each instance. You can also change these values in the little call out window here. It may help to add names to your dimensions so then you can add them quickly and vary them knowing what they are. Also notice that the direction to increments is grayed out and you cannot change this. This is because our current linear pattern only has one direction. If it did have a second direction, you would be able to make adjustments here. Click OK to apply the changes. And you can see as the instances continue through the pattern, it is increasing both the width and the height and also the spacing. If you want to edit a linear pattern, it is the same as any other feature. Just click on the feature in the Feature Manager tree and go to Edit Feature. Here you can make any further adjustments and then click OK to accept those changes. But while we're here, you may notice that, as in the previous example, these pink dots appear once we edit the feature. If we click on one of those dots, you'll see a menu pop up and you have both the skip instance, as in the previous demonstration, but also a modify instance. This allows you to make modifications to a specific instance in the pattern. So if we click on Modify Instance, and you'll see the new callout appear. And what we can do is change the values for this particular instance. So we might change this 20 to a 40 and the 50 to a 60. If you then click OK, you'll notice that one particular instance has now been modified with those specific changes. And you can do this for other parts of the linear pattern as well. So this modify instance is acting as like an override to that particular instance in the pattern. That brings us to the end of the lesson. Don't forget to subscribe to the channel and like the video, and let's move on to the next lesson. The circular pattern feature allows you to replicate geometry in a circular pattern. The copies of the geometry is called the instances, which is based on the original geometry, which is referred to as the seed. The circular pattern features many of the same options that are available in the linear pattern feature. For more detail on some of these options, please refer to the previous lesson on linear patterns. In this lesson, you'll see a demonstration of how the circular pattern works, as well as some of the options available. Also, you'll learn how to create a circular pattern when the geometry doesn't already have an existing circular reference. Don't forget to subscribe to the channel and like the video, and let's begin the lesson. The circular pattern tool creates instances of geometry spaced around an axis. Using this part, I'll show you how to create a circular pattern of this hole cutout. In the description of this video, you'll find links to the exercise files if you wish to use them. They are created in SolidWorks 2019, so you'll need 2019 or newer to be able to use the files. To start the circular pattern tool, you can either go to the Insert menu and then Pattern Mirror and then Circular Pattern, or on the Features tab of the Command Manager, where the linear pattern icon is, there's a little arrow underneath that, so you can click on the arrow to expand it and you'll see Circular Pattern there. So click on the Circular Pattern to start the command. Once the tool is activated, you'll see all the options available in the Property Manager on the side. We will go over some of these parameters, but first let's select the geometry to pattern. By doing this, we're able to see a preview of the pattern in the graphics area, and therefore it makes it a little easier to change the parameters for the pattern. So if you scroll down the options, you should see features and faces. And just like the linear pattern, you can select either features, faces, or bodies. Because our hole cutout is made by a singular extrusion and a fillet, we can select the features, making sure that selection box is selected. And then if not already, expand your design tree, find the circular cut and the fillet for it. You can also make selections for features in the graphics window, but I find it is easier to select them from the design tree most of the time. With the seed geometry selected, let's go back up to the top of the Property Manager to the Direction 1 group box. And this is where we can select our axis and set our parameters. So in the first field, this is where you select the axis, and you can either select model edges or cylindrical faces or axes or lines. There's a bunch of things you can select as the axis. So play around, see what you can select to do that. But in this case, we are just going to select the cylindrical face of this centerpiece, and that will act as our axis. And you can now see that a preview of the pattern is displayed in the graphics area once we select the axis. You can reverse the direction of the pattern by either clicking on the reverse direction button, or you can also click on the arrow in the graphics window as well. Depending on the parameters for the pattern itself, you're going to get different results when you reverse the direction. For instance, if I change the degrees to say 180, so it's doing a half revolution, and there are only 3 instances, you can see now that if I reverse the direction, it's going to go the other way. Whereas when it is 360 degrees and 4 instances, obviously the reverse direction is always going to have the same effect due to the way the pattern is actually being created. So continuing on, the next field is going to be where you set your angle. This is either going to be 360 for a full revolution or anything in between. So for instance, 90 degrees or 180 degrees or anything in between. The next parameter is the number of instances to pattern. So this is actually how many of the seed geometry you want to pattern through. Be aware that you can only see 3 copies of that seed geometry, and that is because the instances include the seed geometry as well as the instances. So you're seeing the seed plus 3 copies, which makes 4 instances. Notice that right now it is set to equal spacing and it is 360 degrees with 4 instances. So this means that all the pattern instances are equally spaced throughout that 360 degree revolution. If we change this to 90 degrees, you can see how that pattern changes. It is now spacing 4 instances equally through that 90 degrees. If we instead change that to instant spacing, the angle field now represents the angle between each instance, and this can also be adjusted. So here we have 4 instances and 15 degrees. So if we were to change that to 90 degrees, you can see it's very similar to the first equal spacing 364 instances. But in this case, it's making each instance 90 degree, and then there's 4 instances of that. So that is what instant spacing does. In the graphics window, you should also see this callout box. You can make changes to the parameters in this box as well as also changing them in the property manager on the side. So how you want to adjust those parameters either through the callout box or through the property manager is your choice in the end. One thing to mention here is if I change this to 6, one more thing before we move on, you'll notice that if I change the number of instances to 6, you'll see that the preview hasn't actually changed. This is all related to the parameters you're setting. So in the case where we're saying every 90 degrees there's an instance and we have 4 instances, obviously that's going to be a full circle. So you have something like this. And as you increase it to 5 or 6, every time it does 90 degrees, it's just adding another instance. And so what you're getting here is an overlap. We don't see them because once they overlap, they just become 1 instance, but you are actually seeing 6 instances here. So if I keep going up and say 8, 9, 10, 11, obviously due to those parameters of 90 degrees, you're not going to see any change. To finish our pattern, let's go back to equal spacing and we will make sure it is set to 360 degrees and the number of instances will be set to 6. Click the OK to accept the circular pattern. If you ever want to adjust or change a circular pattern, it's just the same as any other feature. All you need to do is click on the feature in the design tree, go to Edit Feature, and there you can adjust, make changes to it, and then accept again. While we're here though, let's have a look at a few additional options. Towards the bottom of the property manager, you'll see instances to skip. If you click on that and expand it, you'll notice the pink dots appear for the pattern. And this is very much the same as the previous lesson of linear patterns. When you click on one of the dots, it's going to hide that instance. And to restore that instance, you just click on the dot again. So this way you can skip instances and create custom patterns. Also, like linear patterns, there is the option at the very bottom of the property manager, which is instances to vary. I recommend watching the previous lesson about linear patterns as it goes into more detail about both the instances to skip and the instances to vary. But just be aware that these options exist also for the circular patterns. Moving on to the next model, I want to show you one more demonstration. With this part, I want to create a circular pattern of these 2 hole cutouts around the center of the part. But because this part doesn't already contain geometry that has a circular reference, we need to create an axis point in the middle to use as our axis of rotation. To create an axis, go to the Features tab in the Command Manager, and under the Reference Geometry icon, there is an arrow. Click on the arrow to expand it and go to Axis. The Property Manager should appear on the side. Select the top face of the part, and then expand your design tree and select the origin point. You should see a preview of the axis going straight through the middle of the part. If you do, click OK. So you should now have an axis right through the central part of the model. So this axis will be suitable for our circular pattern. There are many ways you can create an axis, which I won't cover in detail in this lesson. The important thing for this lesson is that you know an access point can be created in situations like this where we need one for a circular pattern. So let's now start the circular pattern by dropping it down, going to circular pattern. And first we will select our geometry, which is the hole cutouts. And then we can go up, activate our axis selection, and you can either click in the graphics window or you can select on the design tree as well. Make sure equal spacing is selected. The degrees will be set to 360 for a full rotation, and we'll change the number of instances to 8. It's also worth quickly noting that if you add too many instances, you will start to get cut out where they overlap and cut each other out. So always look at the preview and check for anything like that. But in this exercise, we just need 8 instances. Click OK, Control 7 to go back to isometric view, and our pattern is now completed. So that is how you can create a circular pattern even when there isn't any existing geometry to use as an axis of rotation for that circular pattern. Finally, to clean this up, you can click on the axis we created and just go to hide, and that way we don't need it anymore, so it can just be hidden. If you need to bring that back, you can just click on it and go to show. But in this case, we're finished, we can just hide it. So that brings us to the end of the lesson on circular patterns. Don't forget to subscribe to the channel, like the video, and let's move on to the next lesson. The mirror feature allows you to replicate geometry about a plane or planar face. This tool is really useful. Whenever you have a symmetric design, it will allow you to create and design half of the geometry and then simply copy it over or mirror it to the other side. You can mirror faces, features, or entire bodies. In this lesson, you'll learn how to use the mirror feature tool to replicate this cutout feature. Then to finish the lesson, we will mirror over the entire body to the other side. Don't forget to subscribe to the channel and like the video, and let's begin the lesson. To start the mirror tool, you can either go to the top menu and go to Insert, and then Pattern Mirror, and then Mirror. Or another way is in the Features tab on the Command Manager, look for the Linear Pattern, click on the little arrow, and this will expand the menu so you can see additional options, and you should see Mirror. So click on that to activate the command. The Property Manager should now be visible on the left-hand side panel, and this is where you can select both the mirroring plane and also the features or faces or bodies to actually mirror. The first selection box is the Mirror Face Plane, and this is where you'll select the plane or face to act as your central point of the mirror. In this exercise, we want to replicate this cutout feature using our mirror tool. So with our Mirror Face Plane selected, expand the Feature Manager tree, which is this area here. You'll notice as I hover my mouse over the 3 default planes, the front, top, and right, it should give you an idea of the plane that it's going to select. What we are trying to do is determine which plane will act accordingly for our mirror feature. So you can see the front isn't what we want because we want this cutout to be over here. So we can't use the front plane. The top plane obviously isn't going to work either. But the right plane looks like it's in the right position. So we'll select the right plane. This is also why design intent is important when you're designing your model and sort of pre-thinking the features you're going to use throughout your model. When I created this model, I knew one of the first steps would be to mirror this feature over. And so therefore, when I designed the boss extrude of the original shape, I made sure that the original right plane was in the central position of this part. Let me demonstrate what I mean. So we've selected our right plane as the mirror plane. Next, we want to select the features to mirror. And again, you can click on that box to activate the selection area and then expand the menu. You can either click on the feature itself, or you can use the tree on the side to select as well. So we can just click on this feature and you can see it's now giving us a preview of what our mirror feature is going to look like. So because of the design intent, I knew our plane had to be in this location so that it would mirror correctly. I'm not going to go into more detail about design intent in this lesson, but there was a previous lesson on design intent. I recommend you should watch that if you want more information about design intent. It's also quickly worth mentioning that if you were creating a part and one of the default planes was not in the correct position you needed to create a mirror feature, you can always create your own custom plane and use that. So moving along, we've selected our right plane as our mirror plane and our cutout feature. We can see the preview of what it's going to look like. Everything looks right. We can now click OK to accept. You may be wondering why, if we have a closer inspection of this part, we can see this feature is cutting all the way through. By default, the mirror feature is going to replicate both the geometry and the end condition of the features that is being mirrored. I suspect that our cut feature is using a through all end condition, and that is why it is cutting all the way through the part. If we click on the cut extrude feature and go to edit feature, and our suspicions are correct, it is using a through all end condition. So to fix our mirror feature not cutting all the way through the part on this side, we could change the through all end condition. But there is another way of doing that, so we can preserve the end condition of the feature, but not cut all the way through on this side. So if I just cancel this edit, I'll show you what I mean. So click on the mirror feature and go to edit feature. In the options, there is a tick box for geometry pattern. If we click on that, you'll notice that the preview is not showing the cut all the way through. What this option is doing is that it is only copying the geometry. It's only mirroring the geometry, and it's going to ignore any end conditions. This way, we retain the end condition of that original cut through, but on this side, it's only going to copy the geometry, which is what we want. So we can click OK to accept, and we can see now it is not cutting all the way through, even though this side is still set to through all end condition. Our final step for this exercise is to mirror the whole body across. So again, launch the mirror feature by going to the linear pattern, dropping down and going to mirror. The first thing we need to do is select our mirror face or plane. And in this situation, we're going to use this face of the part as our mirror plane. So we can click on that. The next thing we need is features to mirror, but we actually want to mirror the entire body. So if you click on here, bodies to mirror, expand that, now we can just pick any part of the model itself. And this way we should be seeing a preview now of the entire model being replicated to the other side. Due to us using bodies to mirror as our selection, in the options there's also a couple of new options. There's merge solids and knit surfaces. Now these are both more advanced techniques which I'm not going to cover, but just be aware that the options can change because of what you're using to mirror. For example, the geometry pattern is now gone. In this particular demonstration, just make sure merge solids is ticked and knit surfaces is unticked. Click OK to accept and Control-7 to go to an isometric view. And you can see our entire body is now mirrored to the other side, and this completes our part. Before finishing the lesson, I just want to highlight the time-saving component of using the mirror feature. When designing a part like this, you may have purposely selected the mirror feature in your design intent process, knowing that if a modification was made to this cutout, we could simply make the change to the original feature and have that copy through the rest of the part because we have mirrored the actual feature itself. Let me demonstrate this by going to the original cutout and going to Edit Sketch. So this is the original sketch to create our cutout. We are going to change this to 10, which, as you can see, completely changes the shape of our cutout. We can exit the sketch and go back to a isometric view. And as you can see, that new shape is copied all the way through our part. So that brings us to the end of this lesson on the mirror feature tool. Don't forget to subscribe to the channel, like the video, and let's move on to the next lesson. SolidWorks has many tools available for replicating geometry, such as linear patterns, circular patterns, and mirror feature tools. But there are some other lesser used, powerful tools that can be used to replicate geometry. In this lesson, you'll learn about the sketch-driven and the table-driven pattern tools. Don't forget to subscribe to the channel, like the video, and let's begin the lesson. To start with, let's take a look at sketch-driven patterns. Sketch-driven patterns allow you to replicate the seed geometry based on a sketch that contains sketch points. You can pattern features, faces, and bodies with the sketch-driven pattern. In this demonstration, we will use the sketch-driven pattern tool to replicate this D25 circular cut. Before launching the sketch-driven pattern tool, we first need to create a sketch, and this sketch will contain the sketch points which will mark the locations of the patterned instances. Also, don't forget you can download the exercise files in the descriptions of this video. These files were created in SolidWorks 2019, so you'll need 2019 or newer to be able to open these parts. Begin by clicking on the front face of this part and going to Sketch. We want to create a center line from the middle of this cutout straight over to the far side edge of the part. Up in the Sketch tab of the Command Manager, look for the Point command, and we want to drop 3 points on this center line anywhere. Click OK, and the next thing we want to do is dimension these points. So from the circle, from the center of the circle to the first point will be 80, and then from the point to the center of the circle again will be 130, and the final one will be 250. So you should have 80, 130, and 250 for our 3 sketch points on that center line. Exit the sketch, and you should be seeing something similar on your screen. It's also important to note here that the sketch-driven pattern tool only recognizes sketch points as the locations of the instances. This means that anything else in your sketch, such as lines, center lines, or other geometry, will just be ignored. We are now ready to start our sketch-driven pattern tool. You can activate this by 2 ways, either going to Insert, Pattern Mirror, and then Sketch-Driven Pattern, or on the Features tab of the Command Manager, look for the Linear Pattern tool, click on the little drop-down arrow which will expand that command, and you'll find the Sketch-Driven Pattern tool, so click on that to activate it. In this case, it's automatically selected the sketch we want to use, but in case it is not selected, you should see something like this. And so the first thing it's asking you to select is the sketch on which the instances are going to be based, which was that sketch we just created. So you can either click it on the graphics area. If for some reason it's too hard to do that, you can just expand the feature manager tree to see all your features and then select this sketch from that location, and that should fill it in. The next thing is to select features, faces, or bodies. In our case, we have a circular cut feature, so we want the features selection box activated. And again, you can either click it in the graphics window or through the feature manager tree. So click on the D25 feature. And when you do that, you should see a preview similar to what I have on screen now. There are some additional options such as geometry pattern. Geometry pattern will mean it will only copy the geometry, but it will not copy any end conditions of that feature. If you want more information on this, see the previous lesson, which covers this in more detail. The other options just control the actual preview, and we won't go into further detail on those. One option to be aware of is the reference point up the top here, and you either can select centroid or selected point. Centroid should be selected by default, but if our cut were asymmetric or made up of multiple features, we could also use the selected point option to select a position for locating the instances. For this demonstration, I have everything set up the way we want it, so if you have something similar, we can click OK to accept the pattern. And you should be seeing something like this on screen now. So we've just created our sketch-driven pattern. To edit an existing sketch-driven pattern, there are 2 things that we can edit it through. The first is to click on our sketch-driven pattern feature that we created and go to Edit Feature. And this is where we'll be able to control either the features you've selected or the actual sketch we're using. The other way we can do it is to actually, if we want to change the distances of the instances, we can edit the original sketch we created. So you should see the sketch there, and you may want to rename it for clarity. Otherwise, you can click on that and go to Edit Sketch. And from here, change our dimensions. So we could change that to 230 and accept, and you can see it's now updated the position of this feature. So be aware there are 2 ways of editing a sketch-driven pattern. Now let's take a look at a demonstration of the table-driven pattern tool. Table-driven patterns allow you to create instances of a seed feature, faces, or body based on XY coordinates. We first need to create an XY coordinate system, similar to how we had to create a sketch for the sketch-driven pattern tool. I won't go into too much detail about creating coordinate systems, but to create one in this demonstration, go to the Features tab of the Command Manager, look for the reference geometry icon, and click on the arrow to expand the tool, and then click on Coordinate System. You should see the Property Manager appear for your coordinate system. The first thing we need to do is select an origin starting point, which will be this bottom corner. So click on that. Next, it is asking for an x-axis. So click on the bottom edge of the part, and then it will ask for a y-axis. So click on this left side of the part. You should notice a little XY coordinate gimbal in the corner of your coordinate system. And you may notice that the Y or X axis is facing in the wrong direction. To change the direction of it, you'll see a reverse direction button. You can just click on that to switch the direction. So it should look something like this, with the X sort of pointing to the right of the part and the Y pointing upwards of the part. If it's looking like that, and the Z axis won't matter in this demonstration, so as long as it's X and Y like this, click OK to accept. And that is how you create a coordinate system for our table-driven pattern. Now we can launch the table-driven pattern tool, and to make it a little easier to view our preview and the pattern, we might want this part to be facing towards us. So to do that, you can click on the face and just look for an icon saying normal to. This should rotate it into view, so it's now perpendicular to our view. To start the table-driven pattern tool, similar to the sketch-driven pattern tool, you can either go to the Insert menu, Pattern Mirror, and find it here, the table-driven pattern, or look for the Linear Pattern tool, drop that down and go to Table-Driven Pattern. And when you do that, you should see this Table-Driven Pattern dialog appear. And you can just drag that around if it's in the way. So we'll just drag it off to the side here. If it has already selected features for you, we can just clear that by right-clicking on it and going to Clear Selections. So in this dialog box, the first is a read from file. So if you have some XY data coordinates in an Excel spreadsheet or Word document, you can browse for it and add it in this case. But in our demonstration, we're going to manually add the data ourselves, so we can skip this section. The next section we want to pick is the coordinate system. So click in this box, and we want to click on our coordinate system in our feature manager tree. The next is either features, bodies, or faces. And in our case, the cutout is a feature. So we can click on the feature selection box, and we want to click on the D35. And when we do that, you will notice that some cells appear, similar to like an Excel spreadsheet. So it's already added the values for the first cutout for us, the 220 and 70, based on our coordinate system. So it's looking in the X direction 220, and then it's looking in the Y direction 70, and that's how it's basing that first location. To create additional instances, all we need to do is double click on one of these cells and start adding data. So let's add a few instances. The first one is going to be 50 and 230. The one after that, 110 and 130. And the final one is going to be 250, 190. So as you do that, you should see these previews appear of our data points. If the preview I'm seeing is what you're seeing on your screen, we can accept that, click OK, and we have now created our table-driven pattern. To make changes to an existing table-driven pattern, you can just click on the feature and go to Edit Feature. And from here, you could change your coordinate system or change your features, faces, bodies, or just add more instances, or even change existing instances. So for example, maybe we change this to 230 and then we add another one, another 230 and 170. And we can see it is going to overlap a bit. So we'll give that a little bit more space, maybe 150. And there we go. So we can click OK, and that's how you edit an existing table-driven pattern. The final step in this demonstration is to hide this sketch for our sketch-driven pattern, as we no longer need to show this sketch. So you can do that by either clicking on the sketch and going to hide, or if it's a bit too difficult to click on it in the graphics window for some reason, you can just go to the feature manager tree, click on it and look for the hide icon and click on that. And now if we go to an isometric view, you can no longer see that sketch in the graphics window. So both the sketch-driven and the table-driven pattern tools are very powerful. It's best to be aware of these tools because you may not ever use them, but as long as you're aware of them, you may come across those situations where it's beneficial to use these tools. And that's why, as long as you practice using them once and just retain them in your memory, it's better than not knowing them at all. So that brings us to the end of the lesson. Don't forget to subscribe to the channel, like the video, and let's move on to the next lesson. Continuing on from the previous lesson, there is another patterning tool you should be aware of, and that's called the curve-driven pattern tool. Curve-driven patterns allow you to replicate instances of the C geometry along a curve, an edge, an entire sketch, or a single selected sketch entity. In this lesson, you'll learn how to use the Curve-driven Pattern tool to pattern this hex cutout along the perimeter of this part. As always, don't forget to subscribe to the channel, like the video, and let's begin the lesson. Just like the Sketch-driven Pattern tool, we first need some reference geometry to drive the pattern path. Since we want to pattern this cutout around the perimeter of the part, we'll first create a sketch and copy the contour of the perimeter, and then that can be used for our curve-driven pattern. To begin, we'll start a sketch on this top face of the part by clicking on the top face and going to Sketch. To select this outside perimeter, we could use the Convert Entities tool, which we will use, but to make our selection process easier, what we can do is just pick one of the lines of that perimeter, right click on it, and go to Select Tangency. This way it will select the entire tangent line that we need for our outside perimeter. And we can then go to Convert Entities, and we have created our perimeter sketch. By using the Convert Entities tool, we also create sketch entities with an on-edge relation, meaning if this part was to ever change dimensions or size, our sketch contour would follow that and update automatically with any changes. This is all we need for our reference geometry, so we can go ahead and exit the sketch and Ctrl+7 to go back to an isometric view. We might also rename this sketch to make it a little easier to select it later on. You can rename the sketch by right-clicking on it and going to Rename Tree Item. And we are just going to call this Pattern Path. So this is just going to make it a little clearer for us later on. We are now ready to launch our Curve-driven Pattern tool. So this can be accessed in two ways. Either in the top menu, go to Insert, Pattern Mirror, and then Curve-driven Pattern, or on the Features tab of the Command Manager, look for the Linear Pattern and click on the arrow to expand that tool and go to Curve-driven Pattern. Once the tool is activated, you should see all the options in the Property Manager on the side. As mentioned at the start of the lesson, the pattern direction for a curve-driven pattern can be either a curve, an edge, an entire sketch, or a single selected sketch entity. And this first selection box is for selecting that pattern path. In some occasions, it may automatically select something for you. If this is the case and it's not the correct selection, you can just right click on it and go to Clear Selections. So with that cleared and the selection box activated, we can now pick our path. If you select one of these segments of the sketched contour, you'll notice it's only picking that segment of the path, which isn't what we want. So if we just right click on that and delete, you actually want to select the sketch through the Feature Manager tree. So making sure the selection box is highlighted, click on our pattern path, which is the sketch we renamed, and this way it will select the entire contour for us. We will look at the other options in a moment, but go down to the bottom of this Property Manager to where it says Features and Faces. For curve-driven patterns, you can select either features, faces, or entire bodies. In this case, we want to select a feature, as it's just a simple cut feature. So have the feature selection box activated, and then you can either click on this feature by just clicking on it like this way, or you can click on it in the Feature Manager tree. Once you've selected your path and the feature that you want to pattern, you should see a preview of the pattern in the graphics window. So let's go back up to the top of the Property Manager and take a look at the other options and start adjusting the parameters to suit the pattern we want. If the pattern is going in the wrong direction, you can click on this reverse direction button like that, or you can click on the arrow in the graphics window. So make sure the preview should be showing the pattern in this direction. You can either set the pattern spacing manually, or you can use the equal spacing option to have the instances evenly distributed along the pattern direction. Put a check in the equal spacing box and change the number of instances to 5. You can also control these parameters through this little pop-up window box here. So you should see in your preview 5 instances that are spaced evenly along the perimeter. But if your preview is looking something like this, where the instances seem to be on the outside of the curve, this is the next option we need to take a look at, which is Transform Curve and Offset Curve. So if you see something like this, it obviously isn't correct. You'll want to change it to Offset Curve, which should bring the patterns to the inside and follow the curve nicely like this. Another option to pay attention to is the alignment method. You have the options of tangent to curve or align to seed. If we change our view to this way, you should have a better idea of what these options do. So tangent to curve, you can see the preview. The pattern is going to follow along with the curve. If we change that to align to seed, it's always going to reflect the same direction as the seed geometry. So as the pattern goes around, it's not going to rotate at all. For our exercise, we want the hex to follow along with the tangent of the curve. So we will select the tangent to curve option. And if you zoom out, you should see it looks something more like this. Also, this last instance is going to end up right on the edge, which is most likely not what you want. This is due to the curve length. If you were to do this properly, you might just finish this edge a little sooner, as the endpoint is going to reflect the center of that last instance. So what we might do is accept this pattern, and so you can see it's kind of cutting onto that edge. And we're going to go back to our pattern path and edit that. So you can click on pattern path sketch and edit sketch. And we need to adjust this line. So we might just delete this line and create a new one. And then we may just dimension this last one to be 10 mils and then exit the sketch. And you can see that our pattern has finished in the correct spot now. So just be aware of the pattern path. You may have to finish it a little early because it is going to be in line with the center of the last instance. Finally, to finish this lesson, I'll show you how to edit an existing curve-driven pattern. So all you need to do is go over to the Feature Manager tree on the side, click on our curve-driven pattern and go to Edit Feature. Then we can make any changes we need to. Say for instance, we might need a few more instances, so we can change that to 7 and then click OK to accept the changes, and it should automatically update. So that brings us to the end of this lesson. Don't forget to subscribe to the channel, like the video, and let's move on to the next lesson. The final pattern tool we are going to look at is the Fill Pattern tool. Fill patterns can use existing features or even predefined shapes such as squares, circles, diamonds, and polygons to fill a boundary area. In this lesson, you will take an existing circular cutout feature and use the Fill Pattern tool to perforate it across the entire face of the part. Don't forget to subscribe to the channel, like the video, and let's begin the lesson. To start a fill pattern, you can either go to the menu at the top and go to Insert, Pattern Mirror, and then Fill Pattern, or in the Features tab of the Command Manager tree, look for the Linear Pattern command, click on the arrow to drop it down, and then click on Fill Pattern. The first part of the Property Manager is asking us to select a fill boundary, and this is going to be an area where you want the pattern to be. A fill boundary can be a sketch, a face, or even multiple faces as long as they are coplanar. For this exercise, click on the top face of the part, and we will use that as our boundary. Like we have done for the previous patterning tools, go down to the bottom of the Property Manager, down to where you can see Features and Faces, as we're going to first select the geometry, and that way it will give us a preview of our pattern and make it easier to adjust the parameters. As with the other patterning tools, we can either select features, faces, or entire bodies. But notice in our features and faces, there's a couple of extra options here, and that is selected features and create seed cut. If we click on create seed cut, it will give us some predefined shapes to create a fill pattern with. So you have circles, squares, diamonds, and polygons. These can be useful in cases where you don't have the seed geometry created in advance. For our demonstration, let's go back to selected features and then making sure the features to pattern is activated. And you can either select the features through the graphic window, or you can expand our feature tree and then find the the feature we want to pattern. But because we haven't renamed it, it may be too hard to find. It might be easier in this case just to select it from the graphics window. Once we've done that, you should see a preview of our fill pattern on the screen now. So go back up to the top of your property manager and we can start adjusting the parameters for our fill pattern. The first option is the pattern layout, and this is going to control the style of the fill pattern. So from the selections, we have perforation, circular, square, and polygon. So as I click through these, you can see how the fill pattern is changing based on that selection. In our demonstration, make sure perforation is selected. Also, as we change through these options, you can see the additional options also change based on that selection. So anyway, make sure perforation is selected and then we'll start adjusting some parameters. All of the layout types have the instance spacing value field. So this is going to define the space between each instance of your pattern. Let's set this to 10 millimeters. For our perforation layout, our next option is the stagger angle option. This controls the angle between each line of the pattern and where it sort of staggers back and begins for the next row of instances. To give you a clearer idea of this, if I just change the view by clicking on the gimbal to bring us to a more front-on view, and we'll change this to 90 degrees. And so you can now see that each instance is directly in line with each other. But if we go back to 60 degrees, it now starts back at an angle of 60 degrees. And then the next one will start back at 60 degrees. So that's what the stagger angle is. The next field is the margin field, and this is also common throughout all the pattern layouts. This parameter allows you to define a safe distance between the boundary of the outermost instance in the fill area. So meaning that the distance between the outside boundary edge and the instance is your margin space. For example, if we change this to 0, you can see that our instances is going to be right on the edge here. If we adjust this to a higher amount, like 10 millimeters, you can start to see it's going to push more into the boundary area as that margin is expanding in size. For our demonstration, let's change the margin back to 2 millimeters and change the instance spacing to 6 millimeters. If we look towards the bottom of the property manager, you should see instances to skip, which should be familiar from the previous lessons. If we click on that to expand it, you'll see all these purple dots on our instances. And by clicking on a dot, it will remove it from the fill pattern. If you want to restore one, you can simply click on it again. So this is a great way of creating a custom pattern or just removing instances that may be problematic, such as these three, which were too close to the edge. Our pattern is now ready, so if we click on the OK checkmark, that should create the pattern for us. As a bonus to this lesson, let's see what would happen if a change was made to the model before the fill pattern even existed. To do this, take the rollback bar and move it back behind the fill pattern. Next, we want to create a linear pattern of this cutout. So go to the linear pattern tool and activate it. For our direction 1, we want this back edge. And for our feature, we can rotate the model and just click on this. And you should see a preview appear. We're going to change our distance to 22 mils. And you should see a preview similar to this. If that's what you see, just click on OK. Now we can restore the rollback bar by dragging it back down to the end. And you can see our fill pattern has updated with this cutout. But we may notice some instances are again too close to where we'd like them. And this is because the fill pattern only considers the outside border of our area. It doesn't look at any spaces inside that boundary. So again, we may have to edit our fill pattern just to skip some instances. So to edit an existing fill pattern, just like any other feature, just click on it in the feature manager tree and go to edit feature. And then we can go back down to our instances to skip, change our view to make it a little easier. And we might just hide these 3 instances here and probably these 3 here. Click OK to accept, and our fill pattern is now complete. So that brings us to the end of this lesson. Don't forget to subscribe to the channel, like the video, and let's move on to the next lesson. The sweep feature, which can either be a boss or a cut, is created by moving a profile along a path. The profile and the path must be created in separate sketches. Swept features can use 3D curves or model edges as the path. and the sweep section can be made to vary as it moves along the path using guide curves. In this lesson, you will finish this fan cover by creating a single spoke using the sweep feature. Then by using the circular pattern, we'll create multiple instances of the spoke to finish the fan cover model. Don't forget to subscribe to the channel, like the video, and let's begin the lesson. Here we have a start of the model of our fan cover, but we need to create some spokes. We can do this by using the sweep feature to create a single spoke, and then using the circular pattern tool to fill in the rest of the instances. To create a sweep feature, we first need to create two sketches. One is for the profile of the shape, and the other is for the path of the sweep. To make things a little easier in our selecting process, let's show the sketch profiles for the two currently existing geometry features. So expanding the rim feature, we can click on the sketch and click on show. And for the faceplate, same thing, expand that, click on the sketch and go to show. So we'll now see the two sketch profiles for those geometries. We can also change our view in the graphics area by going up to the top here where it's got the display style, clicking on the arrow, and then going to hidden lines visible. So this will give you a bit more of a see-through look. This view is useful when you want to try and click things that would normally be covered by geometry. So first, let's begin by creating the sketch profile that will control the path of our sweep. Looking at our model, we're going to need a sweep profile that's going to start from here and then sweep around and finish on this side. So if you're thinking about what plane we can use to create our first sketch, we obviously can't create a front plane, or we can't use a front plane, and we could use a right plane, but our sketch elements aren't in the right position. But if we look at the top plane, that lines up with everything we've got created already. So by clicking on the top plane and going to sketch, and we can begin creating our path. Also, if you want SolidWorks to orientate your view whenever you create a new sketch like mine does, if you go up to the top where it has your options, just go into your options, look for sketch, and this first option here, auto rotate view normal to sketch plane on sketch creation and sketch edit. So just make sure you have a tick box in there. That just means that whenever you create a sketch or go to edit a sketch, it's going to bring your view normal or flat against that sketch plane. And it just makes it easier to, or kind of saves a step from having to change your view anyway. So anyway, let's start creating our sweep profile. So we're going to use a standard line. Starting from this point, we're going to go across. And then we want to bring the mouse back so it starts to sweep out an angle for us. And using our inference line, so you should see something perpendicular like this. Actually, we want it a bit more up here, about here. And then our final line is going to go up to this edge. So we now need to define this path with some dimensioning. So go to your dimension tool. This line that we created, this first one, is going to be 21 millimeters. And then this dimension is going to be from our line to the inside edge. And this is going to be 4 millimeters. And you should have a fully defined sketch by this stage. You will also notice that our path starts from the inside of the model geometry and ends inside the model geometry as well. This is good practice when creating features such as sweeps, because you want to make sure the entire spoke is going into the model as much as possible. If you finish it on the face, it may end up creating a little bit of a gap, and you might not see that without zooming in really closely. So always go sort of beyond the face that you need to create the sweep to. So with this sketch created, we can exit this and go back to an isometric view, and we're ready to now create our profile. So for our profile, we need to create it to be perpendicular to our sweep, in most cases anyway. So in this case, we're going to use the right plane to start our sketch. So we can click on the right plane and go to sketch. And you may want to rotate your view just a little bit so we can see this inside part here. We're going to use an ellipse, and we're going to start from this point, this midpoint here. And you can just drag it up to define our first point, and then drag the second point anywhere you like. Clicking OK. We are going to then dimension this. So our width is going to be 2.5 and our height is going to be 1. So you should have a shape looking like this. And we can see it is not fully defined yet, even though we have dimensioned it. So if you just grab some points and move them around, we can see that there is no relation back to this center point. So we can just make sure nothing is selected. Click this point, hold down Control, click our center point, and just use a horizontal relation. And that should make our sketch fully defined. Once it is, we can exit the sketch. Go back to the isometric view. We no longer need our hidden lines to be shown, so we can drop that down and go back to shaded with edges. And we also don't need our sketches showing anymore either. So back in the rim, we can hide this sketch, and for the faceplate, we can hide that sketch. This sketch 3 is also no longer needed, so we can just click on that and go to hide. With our sweep profile and sweep path ready to use, we can now use our sweep feature. So we can do this by going to the top menu, to the insert, and then boss base, and then sweep, or you can just go to the features tab in the command manager and click on the swept boss base. And when you do that, it will activate and you should see the property manager on the side. So in this property manager, you'll have all the options and parameters for controlling your swept feature. The first option is to select a sweep profile, and the second option is to select the path. So making sure the first selection box is activated. We can either click on it, but if it's too small or too hard to zoom in, you can just expand this. Hovering the mouse over the sketches to see what is highlighting, we can see that is the profile, so we can click on that. It should automatically move to the path selection, and we can just repeat the process, highlight the sketch we want, and then click on it. And you should see a preview showing of our swept feature once those two are picked. This is also where it's useful to rename features or sketches. If I had renamed these before creating the swept feature and renamed the sketch to sweep path and the other one to sweep profile, it would have been easier to identify them and select them during our selection process. But anyway, going back to our property manager, we can see there are some additional options for controlling our swept feature. There are options for guide curves, options, start and end tangencies, thin features, feature scope, and curvature displays. So these all have different effects on our swept feature. Expand the options box, and you can see there is a profile orientation. If you click on that to drop it down, you have two options, which is follow path and keep normal constant. For our demonstration, just have follow path selected. The next one is profile twist. So this will create a twisting effect of your profile as it follows along the path. Here you have multiple options, but also just make sure this is selected as none. The main thing we want to make sure of is the merge result is ticked in this option. This will mean that once the spoke is created with our swept feature, as it is joining currently two solid bodies, it's going to merge them together and create one solid body. As for a lot of these options, I'm not going to cover them in detail. It's worth just spending some time with the sweep feature and playing around with these options to see what effects it has on your swept profile and learning the tool that way. The rest of the settings don't need to be adjusted for this exercise, so we can now click on the OK button to accept our swept feature. We are going to also rename this swept feature by either slow double clicking on it, or you can just click on it and then push F2 on the keyboard. And we're going to rename this to spoke. Next, we're going to finish our part by using a circular pattern to fill in the rest of the spoke instances. To do this, we just go to the Features tab of the Command Manager, look for the linear pattern, drop that down and go to Circular Pattern. For our direction, we can select this cylindrical face, and that will determine its central axis. And our features, we can select our spoke. For our instances, we're going to change that to 16, and the degrees is going to be 360. We can click OK, and there you should have a completed fan cover. Finally, to edit an existing swept feature, all you need to do is click on it in the Feature Manager tree and go to Edit Feature. From here, you could make some changes such as selecting a new path or a new profile or adjusting any of the other options in the Property Manager. In this case, we don't need any changes. We can just click on the X to cancel that. And that brings us to the end of the lesson. So as I mentioned earlier, there's a lot of options available in the sweep feature, and it's worth taking the time just to play around with profiles and guidelines and all your additional options to control the sweep and just learn the effects it has on your swept feature. It's quite a useful tool to know this one, as it can create some really complex shapes and some quite organic shapes as well. So that's the end of this lesson. Don't forget to subscribe to the channel, like the video, and let's move on to the next lesson. In SolidWorks, it is sometimes required to create reference planes in addition to the default front, top, and right planes. Reference planes can be created by selecting geometry to locate and orient the new plane. You can select geometry such as existing planes, faces, edges, vertices, surfaces, and sketch geometry to use as references to create the required plane. In this lesson, you will learn how to create reference planes using a variety of reference geometry. Don't forget to subscribe to the channel, like the video, and let's begin the lesson. To create a new reference plane, go to the Features tab on the Command Manager, and you should see Reference Geometry. If you click on the little arrow to expand that tool, you'll see Plane. So click on Plane, and you should now see the Property Manager for a new reference plane. SolidWorks makes the process of creating reference planes intuitive by allowing you to select the geometry you want to use as references. And SolidWorks will then create the appropriate plane based on those selections. So let's create our first reference plane. In the Property Manager, you'll notice there are 3 selections you can make. In some instances, you only need 2 references, and in some cases, you'll need 3 references. So let's go through some demonstrations to explain what options you have available. For the first reference, make sure the selection box is activated and click on the front face of the part. When you do this, a preview will appear in the graphics area, and several options should also appear in the Property Manager. So based on our first selection, we have some options here such as parallel, perpendicular, coincident, at angle, and offset distance. And these options will change based on the geometry you select as a reference. By default, the offset distance is selected for the geometry we just selected, and currently that is set to 10 millimeters. You have the option of changing the offset distance by simply changing the value, so we could change that to 30 mils. Below that, you have a flip offset. So if you put a tick in that, you can see it changes the direction of the reference plane. And you also have a number of planes to create. So to make that more clear, if I go back to 10 mils and start adding more planes, you can see that it's going to create multiple planes in the one command. When you create a plane, there is a message at the top of the Property Manager, which will tell you if your selections will create a fully defined plane. For instance, if we change this to a coincident, you can see it's going to create a fully defined plane. But if we change that to a parallel, it's now asking for additional references and constraints to be selected to create a plane. Such is also the case for perpendicular or at angle. It's still going to need more references to create a plane. If this is the case, it's referred to as an undefined plane. And if we try and click OK to accept it, you'll notice that a rebuild warning will appear, and that means you cannot even create the plane. So we need to select some more references or constraints to actually create a plane if we're going to be using some of these options. So let's further define our selections to create another plane. Change it to parallel, and then it should automatically change to the second reference. And for our second reference, just hover your mouse over this edge here until you get to the midpoint. And once the midpoint is highlighted, click on that. With these 2 selections, you'll now see that it's saying it is fully defined. So we could create a plane from this. And what we have done is told SolidWorks to create a reference plane that is parallel to the front face, but located at the midpoint of this edge. Let's clear both of these selections by right-clicking on them and going to Delete and try something else. For the first reference, I'm going to click this edge from the first demonstration. And with this particular selection, you can see the options have changed. So we now have perpendicular, coincident, and project. As we switch between these 3 options, you'll notice that all 3 are asking for additional references or constraints to create a plane. For the second reference, just rotate the model a bit and then select this edge here. You can see it's going to say there is a rebuild error possibly. So we are going to try a coincident, and you can see that it will create a fully defined plane using those 2 edges. Go back to an isometric view by pushing Ctrl+7, and again we're going to right click and delete to clear these 2 selections. In this demonstration, again, select this edge for the first selection, and for our second reference, click on this top face of the part here. You should be presented with options that are possible to use between the edge we selected for the first reference and face plane we selected for the second reference. If we use the angle option, we can flip the direction and then we can specify an actual degree of rotation. And you can go through and use any angle we want to. We can also create multiple instances of that, which would create multiple instances at a 25-degree between each plane. We can also use cylindrical faces as reference geometry. Again, clear the second reference by right-clicking on it and going to delete. And for our second reference, click on this top cylinder face. You can see it's going to create a fully defined plane, which is creating a plane starting from this edge, and it is in tangency with the face of this cylinder part. You will see a preview of a fully defined plane, which is going to be in tangent with the cylindrical face of the part. Notice what happens if I tick on the flip offset, and it's going to put the plane on the other side of the cylindrical face. Another way of defining planes is by selecting a combination of points and vertices. Clear both of our reference geometry selections, and this time for our first reference, select this point. It should automatically change to the second reference selection, which we will pick on this point, the opposite side. And then for the third reference, pick the bottom corner here. With all 3 points selected, you can see that it's going to create a fully defined plane, which is cutting through from these 2 points to this point. When you're finished selecting your geometry and creating a plane, you just simply click on the OK to accept your reference plane. You can see the plane we created is now in the Feature Manager tree and can now be used for other features. You can also rename this plane just as you can with other features by either slow double clicking on the plane and then changing the name, or just by clicking on it and then pushing F2. If you need to edit a reference plane, it's just the same as any other feature. You simply click on it and go to Edit Feature. You could then adjust the reference geometry or the position of the reference plane. Let's clear the reference geometry and go through one more demonstration. For the first reference, select the cylindrical face, and for the second reference, select the top face. Change the option of the second reference to at angle, and you'll see with this combination, as I change the degree angle, it is actually following the tangency of that cylindrical face. In this lesson, I'm unable to demonstrate every possible combination for selecting geometry and creating reference planes, but it should give you a base understanding of the process in creating them based on the reference geometry that you select. Before finishing the lesson, I want to show you a shortcut for creating reference planes based on existing reference planes. If we accept this reference plane we just created, click on the plane and then hold down Control on the keyboard. Move your mouse back over the plane and you'll see the icon changes to like a little move symbol. And then you can drag that out. And then when you let go, it will create a new plane, or at least be ready to create a new plane. From here, you can then specify a offset distance, which should be the default option. But you can also use the other options which have been covered in this lesson to create an entirely new plane based on that existing plane we just created earlier. So that's how you create a reference plane. You can use these to create other features and geometry. They're quite useful to know how to do, and you'll often use them in cases where you can't use those default planes, the top, right, and front planes. So you may have to create your own planes and then build geometry from those planes. Obviously, I can't cover every combination to create them, but it's worth your time to go through and just play around with the selections of geometry to see how it works and what planes are created based on that geometry. So that brings us to the end of this lesson. Don't forget to subscribe to the channel, like the video, and let's move on to the next lesson. Configurations allow you to represent more than one version of a part within the same file. It allows you to do things such as independently controlling the size of certain features between configurations, assign materials to the part between configurations, or suppress and unsuppress features from the model. Suppressed is a term used in SolidWorks meaning that items or features are removed from memory and SolidWorks treats them as if they don't exist. In this lesson, you will learn how to create several configurations of this bracket part. Some will adjust the spacing between holes, and another will suppress the hole features entirely. Don't forget to subscribe to the channel, like the video, and let's begin the lesson. The part you see on screen now represents like a bracket or mounting plate, and in its current state, we're going to refer to it as its full size state. This full size state includes the two smaller holes on the outside and the one large center hole. If we also look at this front on, it is also the tallest version in our configurations. As we add features to our model, they will appear on the side here, which is called the Feature Manager tree. At the top of this area, you'll notice different icons representing different tabs. If you need to see more, you can click on the arrows to move across, or you can simply drag the pane out so you can see more of the icons. The one in particular that we want to pay attention to in this lesson is called the Configuration Manager, which will look something like this. Clicking on it will switch to the Configuration Manager tree, and it will look something like this. And so to switch between tabs, you simply click on them. So going back to the Configuration Manager tree for now. You can also split this window into two if you want to. You can do this by moving your mouse up until it looks like a little double arrow looking icon. Click and hold and drag it down, and this way you'll end up with two tabs. And these two tabs can represent different tabs if you want to. So I could have one as the Feature Manager tree, and I could have another as the Configuration Manager tree. To remove the second pane, all you need to do is wait for the splitter tool to appear again, hold down your mouse button and just drag it back up to the top. And this way we're just back to having the one pane open. For this lesson, we'll just stick to one pane and just switch between them, the different tabs as we need them. To start with, make sure your Configuration Manager tree is activated, and in here you should see one default configuration. This default configuration always exists in any part you create in SolidWorks. To add a new configuration, go to the very top configuration and right-click on it, and then go to Add Configuration. The Property Manager should appear, and you can then use this area to name your configuration. So in the configuration name, let's name this Hole Spacing 1. You can add additional information like descriptions or comments, but in this case, we're not going to use it. So just click on the green tick to accept the new configuration. So the new configuration Hole Spacing 1 has been created, and it is currently the active configuration. You can tell this because it is the one that is in the white text, or it's highlighted, and the tick mark is green, whereas any other configurations will be grayed out as they're not active. Since our original configuration represents the model in its full-size state, let's rename that configuration to make it easier to identify. So you can do this by either slow double-clicking on that configuration, or just clicking on it once and highlighting it, and then pushing F2 on your keyboard, which will rename it. And we will rename this to full size. Just hitting enter or clicking away from it will accept the name change. To switch between configurations, all you need to do is double click on them. So currently our Hole Spacing 1 is activated. We can tell because of that green check mark. We want the full size to be activated. We just double click on it. And now this one is the active configuration. If we want to change back to the Hole Spacing 1, just double click on it again. So that is how you switch between different configurations. Obviously, there's no difference yet between our configurations because we haven't actually made any adjustments to it yet. So let's begin making those modifications so we can have some difference between our configurations. So double click on Hole Spacing 1 to make sure that it is the active configuration, and then we're going to go back to our Feature Manager design tree. So we need to change the dimension between these two holes and make it a shorter distance. One way of doing that is to go into the feature and then finding the sketch and then finding the dimensions. And so there's a little bit of a process to that. But a faster way of doing that is simply clicking on the face of the part. And by doing this, you can see some of the dimensions related to the features you see on screen. The one that we're interested in is obviously this 130 millimeters dimension, which is the spacing between those two holes. If we double click on this dimension, we can then edit it directly from the graphics area. So this is going to save time from having to go through sketches trying to find dimensions related to those features you want to change. So with this pop-up window appearing to edit the dimension, we are going to change that to 115 mils. And before we click OK to accept that change, I want to show you something here. If you click on this little icon just to the right of the dimension, you can set or specify what configurations that change is going to affect. So obviously we want this 115 mils to only affect the hole spacing 1 configuration, which is currently the active configuration. So we could click on this configuration only and then click OK. So that means that that 115 dimension change is only going to affect the active configuration, which is the hole spacing 1. And as a demonstration, we can see this by going back to the configuration manager tree and double clicking on the full size configuration, and you can see that spacing changes between the holes. So as we switch between them, there should be a difference in spacing now because we have assigned that specific dimension change to that configuration. Now let's create a couple more configurations that represent the bracket with even shorter distance between the holes, along with a version with no holes. Go back to the configuration manager tree if you're not already there and repeat what we did for creating the configuration the first time. But I'm going to show you a little shortcut this time. You can copy and paste existing configurations just by going to the hole spacing 1 and pushing Ctrl+C on your keyboard and then Ctrl+V to paste. Or if you're not using shortcuts, you can just go to the edit menu and then go to copy and then paste. Again, we can rename this by just clicking on it. You're looking for the copy of hole spacing 1 and then pushing F2 on the keyboard, and we'll change this to hole spacing 2. And one more time, we're going to click on the hole spacing 1, go Ctrl+C, Ctrl+V, find the copy of hole spacing 1, click on it, F2, and we will rename this to no holes. So you should have full size, hole spacing 1, hole spacing 2, and no holes. And the hole spacing 2 and no holes are just a copy of the hole spacing 1. Actually, I've made a bit of a mistake here, but this gives me an opportunity to show you how to actually delete a configuration. So the no holes should be a copy of the full size, but without the holes. And currently it is a copy of the hole spacing 1 with the smaller hole spacing. So to delete a configuration that you don't want, you can just click on it to highlight it and then right click and go to delete. And we're going to make another copy just to get that no hole spacing again. So click on the full size this time, Ctrl+C to copy, Ctrl+V to paste, and you should see a copy of full size. Click on that, go to F2 to rename it, and rename this one to no holes. So our list of configurations should be full size, which is going to be this wide distancing of the holes, hole spacing 1, which will have a shorter spacing, hole spacing 2, which is currently just a copy of hole spacing 1, and no holes, which is a copy of full size. Let's activate the hole spacing 2 configuration by double clicking on it. And remember that you can tell that a configuration is activated because the green check mark and the other ones will just be grayed out. So go back to the Feature Manager design tree, double click on the face of the part so you can see the dimensions, and the 115 we're going to change to 110. Before you click OK, make sure it is set to this configuration and then click OK, and then go up to the top and rebuild. Then we can check that it is working by going back to our configuration manager and double clicking on hole spacing 1. And you should see a slight change because there's only a 5mm distance there. And then the full size. Yep. So there is a difference between each of those 3 configurations. Our last configuration is going to be the no holes configuration. And you might think that to hide the holes, you would have to delete the feature, but there is actually another thing in SolidWorks called suppression. What suppression will do is hide the features in a sense, but only in the configurations that we want it to be hidden in. So double click on the no holes configuration to make it the active one and go back to the Feature Manager design tree. The feature that we want to suppress is this cut extrude, which is these 3 holes. If you just click on that, you'll see a menu that pops up and you want to look for one that says suppress. So just click on that and you should see a menu pop up and you're looking for an option that says suppress. So when you see that, click on the suppress. When you do that, there should be no more holes showing in your part. And if we check this with our other configurations by going to the Configuration Manager tree and switching between our other configurations, you can see that the holes are there and that distance between the holes is reducing until we get to the no holes, which is full size, but there is no more holes showing in the part. Just like assigning certain dimensions to certain configurations, we can also do the same with suppressed and unsuppressed states. Let's do this by going through a demonstration. Activate the No Holes configuration and go back to the Feature Manager tree and right-click on our Cut Extrude and go to Configure Feature. And you should see this window pop up. If you need to, you can just click and drag this to an area that's more viewable. So this Modify Configurations window is showing us all our configurations and whether this feature is suppressed or not, or suppressed or unsuppressed. So you can see currently in the No Holes configuration, there is a tick saying that it is suppressed, which is true. So if we wanted no holes and hole spacing 1 to not have any holes, you could put a tick in both of those areas and then click on Apply and go to OK. And then if we go back to our configuration manager and switch between hole spacing 1 and no holes, you can see that the feature has been suppressed. And then if we click on hole spacing 2 or full size, that feature is unsuppressed. So anyway, that's a demonstration of that working. Let's fix that up by going back to our Feature Manager tree and right-clicking on the Cut Extrude, going to Configure Feature, and then just unchecking that suppressed state for the hole spacing 1 and clicking OK. And then just making sure hole spacing 1, yep, it's working again now. So it should only be no holes where the cutouts are suppressed. So that is the part configurations tool. And obviously it's very useful for creating multiple states of one part in the same file. This is useful for things like maybe you're doing screws or bolts or nuts or base plates like this particular item, and you can quickly create different variations of it and have it all in the same file. That way you're not having to save out multiple files of just the one thing where there's minor changes or even drastic changes between each state. Anyway, that brings us to the end of the lesson. I hope you enjoyed it. Don't forget to subscribe to the channel, like the video, and let's move on to the next lesson. Design tables can be an efficient way of creating configurations of parts and assemblies. In this lesson, we will focus on design tables for parts, but design tables for assemblies can be done and will be focused on in another lesson. An important note about design tables is that it's an embedded Microsoft Excel worksheet that's saved in the file. This means that you need to have Microsoft Excel installed on your computer to use design tables in SolidWorks. But in doing so, design tables give you the power and functionality of Microsoft Excel to configure things such as dimensions and feature suppressions, as well as other things. This way you can quickly and easily create entire families of a design. In this lesson, you'll learn the process of creating a design table by using this model of a socket. We will create a family of 6-point sockets and then another family of 12-point sockets in various sizes by configuring dimensions and suppressing a feature, all through using the design table. If you want to follow along with this lesson in SolidWorks, you can download the part files from the description of this video. The files were created in SolidWorks 2019, so you will need 2019 or newer to be able to open and use these part files. Don't forget to subscribe to the channel, like the video, and let's begin the lesson. We will be using a design table to create a family of components based off this initial design. First, it's important to cover some of the details of how this part was created and the design intent behind it. Some of the features and dimensions have also been renamed to help identify them during this lesson. First, let's use the rollback bar to go back through the history of the features and see how the part was created. If we take the rollback bar and drag it up to the first feature, we can see that it's just been a simple cylinder extrusion. The next feature is a hexagonal cut, and if we click on the sketch and then double click on the dimension, we can see that this dimension has been renamed to hex flats. By default, SolidWorks will name dimensions as you place them, but they'll be in a generic syntax such as D1 at sketch 1. So this dimension has been renamed to hex flats just to make it a little easier to identify later. There is also some design intent behind this hex cut. If I change the 12.5mm dimension to 16mm and rebuild, you can see that the wall thickness is now much thinner. That is because currently there is no relation between the hex flats dimension and the diameter of the cylinder. For example, if we change that 16mm dimension to 20mm and then rebuild the part, you'll see it's causing an error because that hexagon cut is now too large for the diameter of the cylinder. So let's just go back and double click on it and change it back to our original 12.5mm and then rebuild the model. The design intent here was a very important consideration, as we will be using a design table to configure the dimension to drive other socket sizes. With that in mind, we will be able to use a formula to ensure the outer diameter maintains a constant wall thickness based on the hex cut. Move the rollback bar down one more position and we can see a circular pattern feature has been used to create the 12-point version of this model. It's doing this by replicating the geometry of the first hex cut and rotating it 30 degrees around the axis of the cylinder. Again, moving the rollback bar down one more position, the drive feature is a square cut at the base of the socket. And our final step is a chamfer edge to the top and bottom of the part. Now that you have a better understanding of the features and design intent behind creating this part, we can move on to creating the design table. Many of the dimensions that were used in this part will be used to create additional configurations through a design table. So what we can do is display all the dimensions that were used to create features in this part. To do this, go over to the Annotations folder in the Feature Manager tree, right-click on it, and go to Show Feature Dimensions. Now, you may not see all the dimensions like I am now, but that is probably because the dimension is being hidden inside the geometry of the part. For example, if I just rotate this around, there's a 6mm dimension on the base here, which I wouldn't normally see, and you can just click on it and drag it back and then go back to your view. So for example, if this was inside the part, you may not see it, so you can just click on it and drag them out so you can make them more visible that way. Next, go over to the Configuration Manager tree, and you can see currently we only have one default configuration. If you need more space, you can just drag this window out. The design table we create will add configurations to this list. To create a design table, go up to Insert, Tables, Design Table. In the Property Manager, there are options for how we want our design table to be created. Auto Create is generally the easiest way to create a design table. Auto Create will generate tables from existing configurations, dimensions, and features. This option is a good place to start when you're new to design tables. The blank option creates a new blank design table, where you'll need to add dimensions and features to it manually. The From File option will allow you to use an existing Excel document that's been set up to function as a design table. The From File option will allow you to select an existing Excel file that has been set up to work as a design table. SolidWorks needs a very particular format to the data in Excel worksheets. So it's important to have a solid understanding of how design tables work if you plan to use this option in the future. For this lesson, we will just use the Auto Create option as it will create the formatting for us. The Edit Control Group box lets you determine whether the table and model will be bidirectional, which means if you make a change to the model, the table will update automatically and vice versa. The other option is Block Model Edits that would update the design table. This means that using the design table is the only way to edit configured items. With this option enabled, you would not be able to edit dimensions that are in the design table through the SolidWorks interface, and instead you would have to modify them through the design table. For this lesson, leave it at the default option, which will allow for bidirectional changes. In this lesson, no other options are needed to be changed, so you can click on the green check mark to create our design table. When you do this, you'll see a pop-up appears on screen asking us to select the dimensions we would like to add to the design table. Remember earlier I pointed out one of the dimensions had been renamed to hex flats? Well, now it's easier to identify because all these dimensions are showing up in this pop-up window and we can see the hex flats dimension here. The hex flats dimension is one that we would like to configure using the design table, so click on it to select it. Also, the cylinder height dimension, as we will use this to create a family of short and long sockets. To select multiple options, hold down the Control key on your keyboard and then pick the dimensions that you require. Keep in mind that you can select as many or as few dimensions that you want to use in a design table. It's recommended to start simple, as you can always add more dimensions to the table later. The cylinder diameter dimension will also be useful as it will control the wall thickness of the socket, but we'll skip selecting it for the moment so I can show you how to add dimensions to the table manually. To continue on, click OK and the design table should now appear. Remember, you do need Microsoft Excel installed on your computer, otherwise the design tables will not work. Also notice that once the table is up, the command manager up the top has changed to a typical Microsoft Excel toolbar. These tables act and function the same as Microsoft Excel. So we can do things such as resizing the cells, copying and pasting cells, or formatting with different colors and styles. If you need the table to be a larger size, you can just grab the corner and drag it out. In our design table, the first row contains the title and the second row contains the properties, dimensions, and features that will be configured. The third row contains the first configuration. In this case, it contains the default configuration since we use the auto create function. Next to it are the values for each of the parameters that are being controlled by the table. Let's see how we can add additional items to be configured by the table. Say we want to add this circular pattern that was used to create the 12-point feature. The suppression state of that feature will determine whether the socket is a 6-point or a 12-point version. To add that feature to the design table, click on the next cell here, and you can click on the feature through the graphics window, or we can go back to the feature manager tree and select the feature from here. So double-clicking on it will add it to the design table. SolidWorks will add it to the table in the syntax of state at, and the name of the feature 12-point. In the row for the default configuration, the state of the feature is automatically set to unsuppressed. We also need to add the cylinder diameter dimension to the table. Because we have all our dimensions visible in the graphics area, we can select it directly from the graphics area. Click on the next cell and then double-click on the 20 mm diameter for the cylinder. This should add it to the design table. So you can now see the dimension is added to the design table along with its corresponding value in the default configuration row. If you want to reorder columns in the design table, it's the same as Microsoft Excel. You can just select on a column and cut, and then select on another column, right-click, insert cut cells. So you can move things around to make it easier to identify things. By this stage, the table contains all the dimensions and features we plan to configure using the design table. All we need to do is enter the names of the new configurations and adjusting the values for the parameters in each one. The default configuration represents our model in a state we will call 12.5 short 12. 12.5 is the size of the hex, 25 is the short length, and this will be a 12-point socket since the pattern feature is unsuppressed. Copy and paste this row by highlighting the cells and going to Control-C, and then going to the next row and go Control-V, and we can do this one more time. So you should have 3 rows like this. So this will create our next 2 configurations. Let's start renaming these configurations. So the first one will be 12.5 short 12. If you need to see the name more clearly, you probably just need more space. So click between the cells and just drag it out. To make it quicker to rename the next 2, we can just grab the corner of the cell and drag it down. And then we can rename these 2. So it's going to be 16 short 12. And the next one will be 20 short 12. The primary difference between these configurations and the default configuration is the hex flat dimension, and that controls the size of the hex cut. So we will enter the values for those now. At the start of the lesson, I pointed out that if the hex size changes, we need to consider the wall thickness of the socket. Right now, the original configuration, which has a hex flats value of 12.5 millimeters, has a cylindrical diameter of 20 millimeters. We would like to maintain this 7.5 millimeter wall thickness for each of the configurations. To do this, we can use a simple Excel formula. To create the formula, click on the cell that has 20 and type in equals, and then click on the hex flat cell next to it, and then add and 7.5, and you should end up with the same answer of 20 mils. What this is doing is it's taking that 12.5 hex flat dimension and adding 7.5 millimeters to equal the cylinder diameter of 20. So you may see that nothing's changed, but if you double click, you'll see the formula, and you can also see it in the formula bar at the top. To copy this formula to the cells below, just click on the cell and then move your mouse to the corner and then drag that point down. And this will copy the formula down through the other cells. So currently our configurations are all showing 20 mils when these should be a little bit larger based on that formula. And that's because the hex flats dimension is still the same throughout the configurations. So we also need to update these to be 16, and the next one will be 20. And you should see that the cylinder diameter dimension updates through the other cells. So these will now update to show 20, 24, and 28. Next, we can add the 6-point version of the socket. This can be easily done by first copying and pasting the 3 rows we already have and then making our adjustments to them. So we can click and drag to highlight all of this data, Control C on the keyboard, click in the next cell below, Control V, and that will paste it all. And then we can rename these configurations. We need to rename them to replace the 12 with a 6. So go ahead and replace each 12 with a 6. We also need to change the suppression state for these 6-point configurations. You can do this by clicking on the cell and typing in suppressed, but there is a shortcut. SolidWorks recognizes U as unsuppressed and S as suppressed. So you can just type in an S, and for the unsuppressed state, just change that to U. So you should have an S in each of the 6-point configurations and a U in each of the 12-point configurations. Another task for us is to create a long version of each of the sockets. With most of the information already there for us within the design table, this will be pretty easy to do. What we can do this time is highlight again all of our data, Control C, go down to the next blank cell and Control V. And then we need to rename each of these from short to long. So just go through and rename each of those new 6 configurations from short to long. The next step is to change the values for the cylinder depth. For the long configurations, change each from 30 to 60. We have now created an entire family of parts based off just one original part file in only a short time. Let's take a look at our new configurations. To exit the design table, just click anywhere in the graphics window area. When you do that, a pop-up will appear saying that our new configurations have been created, and just click on OK to close the message. Click on the rebuild part just to make sure that any updates are forced through, and then switch to the Configurations Manager tab, and you should see all of our new configurations created in this list. Notice that the configurations we have created have like a little X symbol. This means that any of these configurations with this symbol are being driven by a design table. So if you see that symbol in a part file you open, it is a good indication that the configuration is being created by a design table. So as we double click to activate our configurations, you'll see the model changes to fit the parameters we set. So as we move through them, you can see our short and then our long 12 and our long 6. Some of the dimensions on screen appear in magenta. This lets you know that they are being controlled by a design table. To edit an existing design table, make sure you're in the Configuration Manager tab, and you should see a Tables folder. If you click on the little arrow to the left, it will expand it and you'll see the design table. When you right-click on this, you'll see options to Edit Feature and Edit Table. If we click on Edit Feature, this takes us back to when we first created the design table. So you can set options for From File or Edit Controls and that sort of thing. So we can click on that to cancel. If we right-click on it again and go to Edit Table, we will be taken into our design table. But before it does this, it's going to pop up with a window that is asking if we want to add any dimensional changes or features that have changed in the model since we last used the design table. So you can either add them here, or you can just click on Cancel, and that will put us through to the design table. Once we're back in our design table, we could make any changes we wanted to, such as value changes or suppression states. And then once we're finished, we can just click outside the table again to close it, click on Rebuild to force any changes, and that's how you would edit an existing table. To finish our model, we can go back to the Feature Managers tab, to the Annotations folder. We can right-click on it and just again click on the Show Feature Dimensions. This is going to hide the visibility of those dimensions and clean up our final drawing. So as you can see, part design tables are extremely powerful. You can create common items like you see on screen, like a socket or a screw or a nut, and just start with one design, and then through the use of a design table, create many styles and different sizes, different lengths, whatever you need from that one original design, all within the one part file. It would be good to just at least get familiar with this tool, because I'm sure in a professional office, you will probably find a use for these in some stage. Anyway, that brings us to the end of the lesson and also the end of chapter 2. So don't forget to subscribe to the channel, like the video, and let's move on to chapter 3, which is going to be about assemblies. Welcome to chapter 3 of this SolidWorks beginner series. In this chapter, we will take a look at assemblies. First, we need to have a look at reference geometry. SolidWorks provides reference geometry tools to help in the creation of sketches and features, and for using measurement tools. Reference geometry includes items such as planes, axes, coordinate systems, and points. These reference geometry tools utilize existing part and assembly geometry, and the reference geometry updates according to the entities it's linked to. In this lesson, we will use two parts to demonstrate how the point, axis, and coordinate system reference geometry can be inserted into the assembly. These lesson files can be downloaded from the link in the description of this video. There are three files for this exercise. There is the block part, the pin part, and the assembly file. So to follow along with this lesson, just use the assembly file. Also, don't forget to subscribe to the channel, like the video, and let's begin the lesson. Here we have an assembly with a block part and a pin part, and we want to add some reference geometry to the assembly. In this lesson, we will add a point reference, an axis, and a coordinate system. To access the reference geometry tool, you can either go to the insert menu at the top and then reference geometry, and you can find all the reference geometry tools there, such as plane, axis, coordinate system, point, etc. Or on the assembly tab of the feature manager tree, just go over to the reference geometry and click on the little triangle to drop the menu down. And here you should see all the tools available. And so in this lesson, we are going to focus on the point, axis, and coordinate system. For this lesson, click on the point reference tool, and then you should see some options available in the property manager on the side. The first window displays the selected entities used to create the reference point. There are also other options below that assist in selecting the specific geometry in the assembly. With no selections made in the options, we can click any available point on a component in the assembly. For example, we could click this arc on the block part, and you'll notice that this automatically selects the midpoint of the arc. Whenever you start making selections, you should see a preview appear of your reference geometry. So here you can see a small purple dot, and that is representing the point reference geometry if we were to click OK and accept the changes. So if we click on the green check mark to select that, you'll see that there is a point added in our graphics area, and there is also a point added to our feature manager tree. So reference geometry acts as like any other feature in SolidWorks. So you can edit it by either clicking on the point and going to edit feature, or in this case, we want to delete it, which you can do by right clicking on it and going to delete, which will simply delete the reference point from our model. Just be aware that when you delete reference geometry, you may get a pop-up coming up. Usually this is because there may be parts of the model that have been designed around that reference geometry. And so by deleting it, you're sort of breaking the model because it doesn't have that reference anymore. So just be aware that when you do start deleting reference geometry, you may actually destroy the model by doing so. Let's create another reference geometry point, but this time we're going to take a look at some of these additional options. If the first option, arc center, is chosen, what this is going to do is place a reference point at the center of the arc on the plane. So if we click on this arc, just like in our very first example, it's going to place a reference point at the center of the arc. We want to move on to the next one, which is center of face, but to do that first, we may have to clear our selections. So in the selection box, you can right click on it and go to clear selections. And then we are going to move on to the center of face. So click on the center of face option. And this time it's going to create a reference point at the center location of the face we select. So if we click on this square face on the top of this part, you'll notice that the reference point is going to be right in the middle of that face. This also works for cylindrical or curved faces. So for example, if we clear this selection and we select this arced face here, it's going to put a center point right at the midpoint or at the center of that face of the arc. Again, clear the selections and we'll move on to the next option, which is intersection. With the intersection option, you need to choose two entities that intersect at a point. For example, if we select this top edge here and this edge here, where these two lines intersect or where these two edges intersect is where it's going to put a reference point geometry. Or another example just to show you that the edges don't always have to touch each other, you could select this top edge and then this edge, and the point is going to be where those two edges intersect. Again, clear these selections and we'll move on to the next one, which is projection. With this one, we need to select a plane and a point to project the point onto the selected plane. Keep in mind the projection path is normal to the plane. So for this one, if you click on this face on the side of the block and then click on the point here, it's going to project this point onto the plane of this face. So if you rotate this, you'll see that the point is sort of being projected onto this face, but it doesn't have to line up exactly or be exactly on that part. It just needs to be on that plane. So Control-7 to go back to an isometric view, and we will right click to clear these selections and move on to the next one, which is on point. With this, we can use a point in a sketch to create a reference point. Expand the feature manager tree and then expand the block part, and then go down to the Boss extrude and expand that. And you should see the original sketch that it has been based on. Right click on this sketch and then go to show. This way you can see the sketch in our model. Now for our reference geometry, making sure the on point is still selected, we could click on this point of our sketch and a reference point is going to be created at that location. Control-7 to go back to an isometric view, we are going to clear that selection, and also we are going to hide that sketch as we no longer need it. The last option is to enable multiple instances. This allows us to insert multiple reference points that are spaced by distance, percentage, or to be evenly distributed. So if we click on that, we should see those options of distance, percentage, and evenly distribute. If we select evenly distribute, and we're going to change this to 5 instances, and then for our selection, we are going to select this circular entity, and you should notice that 5 reference points are evenly distributed around that circle. Click the green check mark to accept, and you should see that our points have been added to our model and in our feature manager tree. At the moment, you may notice that we can't see our reference points that we have created, even though they are in the feature manager tree. And if we click on them or move our mouse over them, they will highlight. This is because the visibility of them is not enabled. So you can control this by going to the visibility options up the top here and just clicking on the arrow so it drops down. And you're looking for this dot, which is viewpoints. So you just click on that, and that way they are always going to show in your model. Or if you don't want them to show, you can just do the same thing and reverse the action. This completes how to add reference points to the assembly. Next, we're going to look at reference axes and coordinate systems. The Axis Reference Geometry tool can be accessed in the same way as the first tool, so either through the Insert menu or through the Assembly and then Reference Geometry. This time we're clicking on Axes. Again, we have a bunch of options to select from, so we're going to go through each one. The first option is the one line edge axis, and it can utilize any existing line, edge, or axis to create additional reference axis. So we'll click on this one, and if we click the right edge of the block, a reference axis will appear in that area. It's a little hard to see, but if I click on OK, you can see our axis is created there, as well as in our feature manager tree. We also don't need our other reference geometry points or this axis. So again, as with any other feature, we can just right click on it and go to delete. And we can just select these other ones by holding down Control on your keyboard, selecting each access point, right clicking on it and going to delete. Again, going back to our reference geometry tool and then axis, and we will continue on to look at the two planes option. The two planes option lets us choose any two faces or planes to create an axis where they intersect. So if we select this top face and this side face, it's going to create a reference axis where these two faces intersect. We can right click, go to clear selections. The next one we're going to look at is 2 points vertices. So the two planes, if we select this face here and this top face, it's going to create an axis where these two kind of intersect with each other. It's important to note that this axis does not physically coincide with either part in the assembly, but the axis remains linked to the assembly geometry. So to demonstrate what this means, if we click OK and then grab this pin and move it over to here and update, our axis will update to reflect those changes. To make it more apparent, if I click on this part, right click to rotate the part and then update, just click on our axis again, you can see that it's now updated to match where that kind of intersection would be between that face and that face. So using our undo button, Control Z, we are just going to step back. We don't need this axis anymore, so we can just right click, go to delete, click on our part, our green pin, and just rotate it back to sort of close to the original position, and then go back to our reference geometry, just making sure nothing's selected by clicking off into empty area and then going to the axis. And then we can take a look at the 2 points vertices option. So this option allows us to choose any 2 points in the assembly to create a reference axis. So for example, making sure our 2 points vertice option is selected, we can pick this point here and this point here, and it's going to create a reference axis between those two parts. Again, if we click OK, we can see our reference axis there, and I may even drag this part over here and then rebuild it and then have a look at the axis, and it's still going to be directly connecting between those two parts, so it updates as well along with any changes of the model. This also gives me an opportunity to show you how to edit an existing reference geometry, so it's just like any other feature. Simply right click on it or single click on it, go to Edit Feature, and then you can make any changes that are required. For example, we can clear our selections and then look at the next option, which is the cylindrical conical face option. So with this option, it allows us to click on any cylindrical or conical face to create a reference axis along the face central axis. What this means, so making sure cylindrical conical face is selected, we can pick this, and it's basically doing an axis directly in the center of that cylinder. Or if we clear the selections, we could select this arc, and it's going to put a reference axis right in the middle axis of the arc. So clear our selections once more, and our final option is the point and face plane. This allows us to create an axis by choosing a plane and a point. So to demonstrate this, we might again grab this part by right clicking so we can rotate it slightly, and then we can select the top face and this point, and this is going to create, it's a little hard to see here, but it's going to create an axis from this point, but it is normal to this face. To give you another example, if I was to clear these selections and then select this top face and then maybe this point, because this face is flat and then this point is just going to create an axis directly straight up because it is perpendicular to that face. If we were to click on the cancel button, obviously this is just going to cancel any changes we made, and then we can right click on our axis and just delete. Control 7 to go back to a isometric view and just try and right click on this part, rotate it roughly to the original position. That completes the reference axis, and now we're going to move on to how to insert a coordinate system. The reference coordinate system can be accessed in the same way, so just go to the reference geometry and then go to coordinate system. So a reference coordinate system, if you look down here, you'll see a little gimbal, which is the Z, X, and Y axis, and it just gives you a representation of what direction things are in a 3D space. So a reference coordinate system is kind of like adding another one of those, and then you can use that to sort of base your design around in some sort of way. So you can see our original reference triad down here, and then you should see here, starting from our origin point, is our reference geometry triad. In the property manager, you'll see 4 selection fields available, which are used to define our coordinate system. So you have our selections and then X, Y, and Z axes. The coordinate system requires an origin point and then 3 selections to define the directions of the axes. Notice that there is only 2 reverse direction buttons for the X and Y. That is because once you define those 2, it kind of locks in which direction the Z axis would be anyway. Basically, you can fully define a coordinate system by just having 2 axes selected. So to position our coordinate system, to define its origin point, we can select this point. So you can see our triad moves over to that location. And then we can define our X direction by clicking this line, and then our Y direction by clicking this line. And you can see it's actually got the direction of the Y going in this direction. So we could reverse that if we wanted to, just by clicking on this button here. And you can see that's going to fully define our coordinate system. So just to give you another quick idea of what I mean by these reverse buttons, if I was to reverse the direction of the x-axis, you can see that's sort of flipping the direction of our z. The direction of the z-axis is always determined by something called the right-hand rule. The right-hand rule is if you take your right hand and you point your thumb, that's going to be the x-axis. And then you use your index finger, that's going to be the y-axis. And then if you take your middle finger and you point it at like a perpendicular angle, that's going to be the direction of the z-axis. So if you can kind of imagine that as the gimbal in your design, this being the x, y, and the z-axis, it's always going to be sort of pointing, or the z is always going to be pointing in that direction, depending on where you rotate or place that coordinate system. So to accept your coordinate system, just click on the OK button, and you can see our coordinate system is now defined at that point in those directions. It's also now available in our feature manager tree, and so it can be either edited or deleted from here, just like you could with any other feature. This completes our lesson on reference points, axes, and coordinate systems. These tools are kind of used in certain situations, and you probably won't use them too often until you get more comfortable with SolidWorks. You'll sort of realize their purpose when you go to design something and you realize that to create a feature or to maybe create a sketch, you need some sort of reference in space to base that feature from. And that's usually where reference geometry sort of plays its part, because that point in space would be your reference geometry. So you'd put something in place and then you could start to build features or whatever you needed from that reference geometry. That's sort of what their purpose is for. That brings us to the end of the lesson. So I hope you enjoyed it. Don't forget to subscribe to the channel, like the video, and let's move on to the next lesson. A simple way of creating an assembly in SolidWorks is to use what is called a bottom-up design approach. With this design approach, it simply means that all the parts are created individually first. Then you'll start an assembly file and insert those components into the assembly, and then finally you'll constrain them all together by using something called mates. An alternative method is called a top-down design approach. Without going into too much details, this just means that the parts are created within the assembly. This lesson will just focus on a bottom-up design approach, whereas the top-down design approach will be covered in another lesson. In this lesson, you'll learn how to create an assembly, insert components into the assembly, how to move and rotate components within the assembly, and finally, how to constrain the components in the assembly by using something called mates. This lesson uses multiple parts to create an assembly, so download the zip file from the description of this video and then extract the contents to an area that you can find easily. One thing to note is that all the files were created in SolidWorks 2019, so you will need 2019 or newer to be able to open the files and follow along with this exercise. Finally, don't forget to subscribe to the channel, like the video, and let's begin the lesson. There are several different ways you can begin a new assembly in SolidWorks. When you already have a part open on screen, you can create an assembly from the part. You can do this by going up to the drop-down menu, click on File, and make Assembly from Part. When you do that, a pop-up box will come up. The only option here, unless you have additional templates, is Assembly, so just click on that to highlight it and go to OK. This will automatically bring up the Begin Assembly dialog. This is where you can start adding components to our assembly. Before continuing, there is another way you can create an assembly, which I'll quickly show you. So first click on the X to just cancel this assembly we just created. And then also click on the Close Assembly, so we're back to our original wheel file. So you can either go to the File menu at the top and then click on New, or you can just go Control-N on the keyboard, and that is also going to create a new file. From here, you'll have some templates, and you should see the default templates on screen that I have. So you'll have part, assembly, or drawing, and obviously we want to use an assembly template, so you can click on that and then go to OK. Once an assembly file is open, you'll have the option of either browsing for components to add into the assembly or creating a layout sketch. Also note, if you have any part files open in the background, like we do with our wheel file, it will show up in the Open Documents dialog box. The Create Layout sketch is useful for a top-down design approach, where you want to design components in the context of an assembly. However, in this lesson, we are just looking at a bottom-up design approach. So instead, we'll choose a component to insert. In many cases, what you'll do is click on Browse and then adding an assembly this way. Or if you do already have a document open in the background, it should show up here and you can just double click on it. If you have multiple files open in the background and you're not sure what they are, you can click on one and then go to the thumbnail preview and just drop that down. That will give you just a quick preview of what it looks like. And that way, if any of the names of the files haven't been done very well, you can just look at the thumbnail to quickly identify what the files are. In the options, you also have a selection box to enable graphics preview. So if we untick that, you'll see there's nothing showing up. This might just be helpful if you're adding a very complex part and slowing down your computer as it's moving around the screen. You can just untick that. Otherwise, generally, you'll just have this on all the time so you can see what you're placing. So what you should be seeing is as you move your mouse around the graphics area, you should see our component in that graphics area, which is, of course, our wheel file. In the Property Manager, there are also options to show Rotate Context toolbar, which allows you to rotate the components in the graphics area before placing it, which is this little area down here. So if I untick that, we should see the box disappear. If we bring it back, we'll see our little dialog here. This will allow you to rotate the component either X, Y, or Z axes and also by a defined angle. So we could put, say, 30 degrees and then click the X axis and it's going to rotate it 30 degrees along the X axis. You can also right-click in the graphics area and you'll see some options for rotating the part, such as rotating by 90 degrees, either X, Y, or Z. Once you've selected your component to insert and it's showing up in the graphics area like we do have on screen now, you just push the left mouse button to place the component. But before you do that, we just need to consider something to do with design intent. If we go up to this little eye icon and click on the little drop-down arrow and you're looking for View Origins, so click on that to show the origins. And then just left click so the menu disappears and you should still have the component sort of moving freely. Now what you can see here is we have both a origin point in the center of our drawing, which is the origin point of our assembly drawing, the very 000 point within space. And also you can see on our component, we also have an origin point, which is the 000 point of that actual component, the very center of it. So if we did have our component over here and I was to click and it's going to place that component there, obviously the origin point between our component and the origin point of the assembly file are not going to align together. In some situations, you may want this, but 99% of the cases, you'll want the origin point of the component to be in line with the origin point of the assembly file. With the thought process of design intent here is that the original component, the first component, is going to be zeroed in to the origin point of the assembly file. So therefore, any other components that you're adding in or reference planes that you're using to build further layers of the assembly, it's all going to be related down to that 00 origin point of the assembly file, and usually the first component that you're placing in as well. The reference planes of the assembly are therefore aligned with the reference plane of that first component. This can make adding mates or other components easier while also helping you to predict and determine the center of mass and other values. If we hover our mouse just over the origin point of the assembly, you'll notice that it kind of snaps into position. So if we were to do this and then click the mouse button, it would position it exactly aligned with the origin point of the assembly with the origin point of our part file. But before doing this, I also want to show you another way. So whenever you're placing your first component into an assembly file, you don't actually have to click anywhere or snap it to the origin point. All you have to do is just click on the green check mark and that will automatically align it to the middle point or that 00 point. It's also worth noting that the units used in the assembly file can be different to the units used in any of your part files. So this means that maybe your assembly file is in imperial units and using feet and inches, but but your part file is using metric, so that might be millimeters, meters, etc. If that's the case and you have files with different units of measurement, you can always change the units used in the drawing on the fly at any time. You can do this by going up to the top menu where you can see the gear icon and clicking on that and going to Options. And in the options, you want to go to Document Properties and then Units. And you can see the unit system used for this assembly file is currently set to millimeter gram second. So you could change this if you wanted to centimeter gram second or any other one. But for this particular exercise, we will just use the MMGS option. Because we don't want anything to change, just click on cancel. Another way you can change the units quickly within a file is down the bottom here. You won't be able to see it because it's just behind my camera overlay, but you should see a little icon that says MMGS, which is, and if you leave your mouse on it, it will actually come up saying units of measurement or unit system. And if you click on that, you can change the unit of measurement type. So again, just make sure currently that is MMGS, which means millimeter gram seconds. As this is the first component into our assembly, it is automatically locked into place. No matter where you place it, if it was happened to be placed off center away from the origin point, it would be locked into that position. And if you click and drag around, you won't be able to move it. If you need to move it though, what you can do is right click on the component and then go to float. And this way you can now drag it around and it will move freely. If you right click on it again and go to fix, it's going to be fixed in position. Now we don't want to move that away from our origin point. We want it back to where it started. So we can just do Control Z to undo and go back to this position. Now we are going to move on to the next part of the lesson where we start to add more components into our assembly. Next, we're going to add some more components and also learn how to move and rotate those components within the assembly. Currently, we have our first component inserted into our assembly and it is locked to the origin point of the assembly. But when we add additional components, you'll find that they are set to float by default and therefore can move freely within the assembly. There are, of course, a few ways of inserting new components into our assembly. The first way we're going to look at is by opening an existing component, which we can do by doing Control O. And we are going to add our axle and click OK. With our axle file now open, if you go up to the top here, you'll see these little icons up here. And if you just hold the mouse, it says click to tile right. So if you click on that, you'll notice that it's going to open all your currently open drawings in separate sort of tiled windows. So what we're trying to do here is have this open on top of our assembly file, and then we can actually drag that component into our assembly. And then on this sort of top bar, we can just double click on that to maximize our assembly drawing. If you're not sure what file you're on, you can always just look up the top here. It should show you sort of an abbreviation of the file. Also, if you have multiple documents open, a quick way of switching between them is by pushing Control Tab on your keyboard, and that will just cycle between each file you have open within SolidWorks. Also, quickly to note, when you do place this Excel file, just click anywhere, as it doesn't matter where you place it, it will still be free to move even after the fact you've placed it, because it isn't the first component, which is by default locked down into position. But in this case, it is free to move, and we're going to add constraints to that in a moment. I'm going to show you another way we can add more components, but also while I'm here, we can show you how to delete a component. So you can either delete a component in an assembly by right-clicking on it in the feature manager, or in this case, component manager, and you can go down to delete. Or another quicker way is just to click on the component and then push delete on the keyboard. So with that gone from our assembly, if we go up to the feature manager tree or the command manager and go to insert components, just like we saw at the beginning of the lesson, our insert component dialog box is open. And because we still have our Axle file open in the background, it should show up in these open documents. So another way we can insert a component is by just opening the part file and then going to insert components and just having them all listed here. And from there, we can just click on it and then click in here. And again, I'm just going to show you one more way of inserting a component, so we can click on that one and delete. If you have a Windows Explorer window open, and here we have all our files, so you can just drag and drop files from Windows Explorer into your design as well. Doesn't matter which way you go about inserting components, just figure out what works easier and and the quickest method for yourself is. Now, with the axle inserted, you may notice that the orientation of the part is not what you want, and therefore we might need to rotate or move the component within the assembly to reposition it in a better way. You can do this in a few ways. So if you left click on a component and hold it down, you can drag it around. If you right click on a component, you can rotate it. And if you rotate it out of position, you can just Control Z to go back to your original position. And another way of moving components is to use the Move Component tool. So click on the component or components that you want. If you're selecting multiple components, you can hold down Control and then pick the components you want. In this case, we just want the axle. So click on that and then go to Move Component. And here you'll have additional options for moving and rotating a part. The benefit to using the Move Component tool is that you can switch between the types of movements and rotations for components, all within the same command. The Move Component tool provides the same movement types as the mouse shortcuts, but adds additional options which aren't available by clicking and dragging. This allows you to further refine the component's positions. As an example, the Move option has a drop-down box, and we could change this to along assembly XYZ, and this way it will lock the movement in those X and Y positions relating to the assembly XYZ positions. And you also have some additional options here you can play around with, like along entity to XYZ position, etc. So to cancel this, you can either click OK or just escape on the keyboard. Another way of moving a component is by clicking on it, right clicking on it, and going to Move with Triad. So this is a pretty good tool to use because it allows you that finer degree of movement. You can either go in an axis direction, so like a Y or an X, by clicking on the arrows and dragging. You can rotate by clicking on these areas, these radial areas, or you can move it in a sort of 2D area like the XZ by clicking on this area section and dragging it like that, or you can go along the YX axis by dragging it here. Be aware that even though we're moving and rotating components around the assembly, we're not defining its position and location or freedom of degrees. This is done by using something called mates, which will be shown in the next part of this lesson. But first we're going to add the rest of the components to our assembly so we can then add the mates to them. So let's do this by going up to Insert Components and then Browse. You should browse to the location of the extracted zip file for this lesson. And we're going to add these last components that we need. So we need the support and the plate. And if you hold down Control, you can select multiple components and add them into the assembly at the same time. So hold down Control, select the plate and the support, and then click on Open. You can move and drag around the screen before placing them to get a better position if you need to, but really the position's not going to matter because then we're going to define its location later. But just put it off the first one, it's going to ask where to place that, and then you'll notice it goes to the next part and you place that one. And if there were any more components that we selected in that process, it's just going to go through and you just place them one by one. You can probably picture what this assembly is going to be in the end, which may mean that you'll notice you need an additional support. So we can do this by going back to Insert Component and adding the same file again. But a quicker way of doing that is in our manager tree on the side here, find the support file, hold down Control, and then just drag it into the graphics area. And that's just going to make a duplicate of that item. So you can actually see there's two of these supports now. So if you've followed those steps so far, you should see something similar to what I have on my screen. And we're going to move on to the final part of this lesson, which is adding mates to these components so that we can lock them into the correct positions and build our final assembly. So far, we have learned how to insert components and move them around the model space. Now we're going to learn about something in SolidWorks called mates, which defines a component's freedom of movement and degrees of movement. You can think of mates as the glue between parts, and it's what holds the assembly together. So what you're doing is you're taking components or parts and you're using mates to sort of bring the faces together or limit the degrees of movement between them or space them a certain distance apart. And you kind of build on top of each component and create these relations between other components in the assembly to therefore build the entire assembly as a whole. So let's go into detail on how you actually add these mates and start gluing between the different components. To add mates, click on the mate icon in the Assembly tab of the Feature Manager, and you should see the Property Manager appear, which will have a whole bunch of different options you can use to create different mates. Another way is by going to the Insert menu and then going to Mate. And a final way is by clicking on a component and going to Mate, which looks like a little paperclip. The only difference that when you click on a component and then click on Mate, it's going to show up in the selections right away. So in this case, we don't want this particular face for the exercise, as we're going to show you some other ways of doing it from scratch. So any selections that might be in this group box, you can just right click on it and go to Clear Selections. SolidWorks provides many types of mate options, which will help define relationships between component surfaces, points, or faces. Note that the different mate types are similar to the geometric relations available when creating a sketch, and they behave in a similar way as well. You can also create distance and angle mates to constrain components and to always maintain a certain distance or angle between them. You may notice by default the standard mates group is activated, but there are also options for advanced mates and mechanical mates. These allow for more complex motion and relationships between parts. So I invite you to play around with all the mates available, but in this lesson, we'll just focus on the standard mates, which through your SolidWorks use, you'll probably use 99% of the time. Mates are used to set up boundaries and rules between components and restrict their degrees of freedom, but you must be careful not to over-define components by adding too many or conflicting mates. For example, a conflicting mate would be setting a coincident mate between this face and this face, so the two faces just join together, but then creating another mate, maybe a distant mate, telling it to be always apart by a specified distance. Now, obviously, this is going to conflict because you have one mate trying to push it together and another mate trying to pull them apart. And whenever you have a conflicting mate, it's going to tell you that there is some sort of conflict within the assembly, and then you're going to have to solve that issue. So to begin putting this assembly together through the use of mates in SolidWorks, either you should be up to this part if you've been following along with the exercise, or if it's not looking exactly like this and you want to start from fresh, you can just go to Open and open the full assembly file. And it should look something similar to this. It's just a bunch of parts sort of placed in random locations. So to begin, we're going to go to the Mate command, and it's going to ask us to make our selections. So we are going to click on this sort of body of the axle, and then we're going to click on the body, the internal body of the wheel. And whenever you make selections, SolidWorks is going to try and use the best sort of mate for those particular selections. So in this case, it's thinking, hey, I should probably use this concentric because you have basically two circles trying to fit within each other. So it's going to default to this concentric type. But if you wanted to try and force it to a different type, like a tangent or perpendicular, you can just click on these ones and see what would happen. Depending on your selections, it may conflict and say this type of mate won't work with your selections. But in this case, we actually do want the concentric mate. Then you can just click on the Add Finish Mate tick box and then move on to the next mate. The thing to note when you're using the mate command is that you don't have to apply a mate and then start the command and then apply a mate and start the command. It just happens whenever you select the correct selections you want and apply a mate, it's just ready to move on to the next selection. So you can see the selections is already cleared and we don't have to constantly reactivate the same command over and over. So the basic process is you just go through, add the mates that you need, and then once you're done, you just click on the green check mark. And then if you found that you needed to actually add more mates, you'll just go back into the command again, add any extra mates you needed. So obviously in this situation, we do need some more mates. So another one we can do, and you are able to move around to get to better angles that you might need. The next one, we could select this surface, and that's just going to automatically assume we want a coincident, which is going to work. And then we can click OK. Our next selection, we could say pick this face and go OK. Now obviously at the moment that's just planar. So we want this one and this one. Click OK. If you did make a mistake and you wanted to quickly undo, you can either just push Control Z or just click on this little undo button, and then you may need to redo the selections again and apply. And so we'll also do this one on the other side. Okay, so you'll notice in this situation, it's not going to do the mate the way we want it to. Obviously, it is a coincidence. It is the same as this side, but it's basically the wrong way around. And you'll notice in our little toolbar, there is a flip mate alignment button. So if you click on that, it's going to rotate the part around. So that way, if you often get two faces, but they're sort of back to back, and you need them the other way around, that's the little button you'd use to sort of flip the position. Depending if there are other mates preventing it from turning it around, you do need to pay attention to that. So we'll do that one. And again, we need this one here. As you go along and add mates, you might just want to finish the command and just check the movements to make sure there's nothing you're missing. If I was to rotate this, but it actually moved out to the side, then it's telling me that I need some sort of mate to keep it flush against that surface there. But since this is rotating around, and that's all the restriction I want within this part, so that's okay for me. While we're here, you may also notice that mates show up in the feature manager tree as well in this little section for mates. So if you click on the arrow, it'll expand out and you can see all your mates. If you move your mouse over them slowly, you'll see that it's highlighting in the graphics area what surfaces are related to that mate. So you can help identify if you're looking for a particular mate and you might need to delete it. You can sort of find it this way. So we might have needed to delete this. You can actually delete a mate by right-clicking on it and going to delete, or by just highlighting and pushing delete on the keyboard. You can also suppress mates by just clicking on them and going to suppress, and you can then unsuppress them by again clicking on them and going to unsuppress. So basically from here, from this feature manager tree, you can edit, delete, or suppress mates that exist in the assembly already. Another tip is you can click on one and either slow double click or click on one and push F2 on your keyboard and then rename them to something that's more familiar, like axle, insert, mate. So this might just make it easier to identify key mates within the assembly. So our final mate is just this bottom plate. So we'll go and finish this off. So click on the mate tool. We want to click on that surface and this surface. Okay. And we also want this surface to be coincident with that surface. And then we might just click OK and see sort of what else is missing. And it just needs that final mates to sort of lock it in place. Now you could create a coincidence with, say, this face, and then the back face and the back face here. And that's going to sort of lock it in position. But there would be another easier way of doing this. So if we go to mate, we can click on this cutout and this cutout, and it's going to align those two. So you can imagine with all the other mates in place, that should, okay, so it's almost locked into place. I think the last one we need will be this one on the opposite corner, and therefore it's all completely locked in. Now you may notice that if we grab our wheel and we try and spin it, it's not going to turn because being the first component, it is locked in place. So to change that, we can just cancel that, make sure, yep. So we can, here you can see it's not moving. So we can click on the component and go to float. And you may notice the whole assembly is moving around because there is no fixed 0 point in space anymore. So what we can do is just undo that to a state where it's locked in place. So we'll go back a couple more times. Might redo. Okay, so we're back at a state here. We've just undone a few steps and gotten back to this point. So it's no longer floated. This can move. If we float this part, we can turn it, but the whole thing's going to turn. So that means we need some definition to the rest of the components, and then we can free this up to float. So what we can do is we're going to click on this so we can see it highlighted in our feature manager tree. We're going to expand it, and from here you can see the top, front, and right plane. And also you'll notice the top, front, and right plane for our actual assembly file as well. So what we can do is create mates and expand this out from here. We're going to create a mate between the front plane of that base plate and the front plane of the drawing, and click OK. And then one between the top plane and the top plane. And you'll notice it may not like this one. No, it should be fine. If it doesn't work, we'll just clear it, and then we'll do the right plane and the right plane, and we'll click OK. And it's going to say, please select. So we want this to be coincident? Yep. And we'll just check if there's any more movement. Nope. So as you can see there, what I'm trying to do is just lock down the planes of that base plate with the planes of the actual origin of the file of the assembly drawing. So that's going to restrict any movement of this, and through that, the rest of the components as well. And from there, I can right click on the wheel, or click on the wheel, sorry, cancel the command first. Right click on the wheel, go to float. So as you can see, as we move it up and down, the wheel is spinning, but the whole assembly is moving up and down as well. And that's because that last plane wasn't done. So if we go back to our mate and we want the top plane, no, we'll just clear those selections, sorry. So clear those. We want the top plane and the top plane of the drawing. We're just going to select OK to that and then finish our component. Control 7, and then if we rotate, finally we got it to a state where only the wheel spins around. Now, before finishing the lesson, I want to include just a few tips with adding mates and building assemblies with a bottom-up design approach. First, as I described before, mates can be renamed, and this can help make it easier to identify particular mates within an assembly, especially as you can see, just adding these mates to kind of build this assembly has created quite a long list of mates in there, and it can quickly become difficult to identify what is what. You don't want to go about and rename all of them because it's just time consuming and it's not really worth the effort, but there may be particular ones like maybe the axle. That could be a good one to rename to something like axle mate. And then you might pick another one like the base plate and the ground plane, and you could just rename to that to ground plane constraint or something along those lines. So just key ones, that can help a lot. Secondly, like I explained before, another way of identifying mates is just holding over your mouse, and that can quickly find what is particular mate that you need, and then you might delete it or suppress it or edit it. And finally is think about your design intent when creating an assembly. Because that first component that you place in is usually locked directly to the origin point of the assembly, usually I try and build my assemblies from that point. So in this particular lesson, the wheel has been the first component, but as you can see, it's created a lot of difficulty with creating that freedom of movement. We wanted that wheel to spin, but because it was locked into place, we had to create additional mates with the base plate and then having that move around, etc. So it may have been a better idea to insert the base plate first and have that locked, because in theory, that's going to be kind of where your ground plane is, and then building the assembly from there. That way you'll have that freedom of movement in the wheel to spin, and you don't have to worry about creating mates to sort of build to that point and then, going back and forth that way. So always try and build an assembly with the idea in mind of the first component going in, kind of being the center of the universe. And don't forget, you can create assemblies with other assemblies in the same assembly. So this might be an assembly of like a little caster wheel on the bottom of a bin or a trolley or something. And so this can be its own little assembly. And then you can put that assembly into a larger assembly. So you don't have to build an entire assembly with every bit and component that you need and all the parts. It'll just become a massive headache. So sometimes it's better to actually break it up into smaller sections and just work on those. It's going to be easier on your mind. It's going to be easier on your computer in the end as well. So that brings us to the end of this lesson. Assemblies are something you're going to do a lot in SolidWorks, so it's important to kind of get the idea of it. Once you do a few basic assemblies like this, it'll become more and more familiar. You'll get a good idea of what mates to use and how to quickly use them. And when you do come across issues where things are conflicting, you'll be able to identify them pretty quickly and edit or remove them to fix up the issues and then continue on with your sort of building process. This particular method is for that bottom-up approach. So we're putting in components and sort of gluing them all together to create the assembly. The other way of doing it is the top-down, where you actually create an assembly and create parts within that assembly and then save the files out. But that type of design will be covered in a future lesson. So that should just give you an idea of how a bottom-up design approach works. And in most cases, this is how you do most assemblies anyway. You create the files first and then you sort of put it in together. It's usually just where you do a top-up where you have a bit more automation between how things work and they resize as things might change. But again, we'll leave that for another lesson as it's a bit more advanced. So if you enjoyed the lesson, don't forget to subscribe to the channel, like the video, and let's move on to the next lesson. Components added to SolidWorks assemblies can initially move freely within the assembly's environment. It's often useful to move components within the assembly to help with adding mate relationships or to demonstrate movements of parts within the model. There are several tools available to assist you in moving and rotating components. In this lesson, you'll learn about commands and mouse button functions available, and also how to use the triad tool to reposition components in the assembly. You'll also learn about some options available in the Move Component tool that can help you detect collisions within parts of the assembly. This allows you to test moving mechanisms in your assembly and output data such as minimum clearance distances. If you plan on doing the SolidWorks Associate exam, it is worth learning this tool because there will be questions that ask you to use the Move Component tool to check for collision detection and then providing an answer from the data you get of the minimum clearance distance. Not only is it good for the exam, but also in a practical real-world example is when you have assemblies with a lot of moving components, you can check to see if anything is going to collide and cause an issue. If you want to follow along with this video, you can find a link to all the assembly and part files in the description of this video. Please be aware that I'm now using SolidWorks 2020 edition, so you will need 2020 or newer to be able to open and use these files. So let's begin the lesson. There are several techniques to move and rotate an underdefined component within the assembly environment. A component whose position is underdefined will appear with a minus sign in the Feature Manager tree. This indicates the component has some freedom of movement within the assembly model. The most direct way to manipulate a component position is with the mouse buttons. Dragging it with the left mouse button will move it around, while right-clicking on it and holding will rotate the component. Another tool is the triad, which can be accessed by right-clicking on the component and going to Move with Triad. The triad consists of three axes, the XYZ, the planes, and the rotational axes. The XYZ directions will allow the component to move in that one direction. The planes will allow the component to move in a 2D component, so here we have the X and Y plane that we're moving along. And the rings will allow it to just rotate in that particular direction, so either XY, ZY, or ZX. To access additional selection and movement properties of the triad tool, you can right-click on it, but I find there's a bit of a trick. If you just right-click on the triad, you'll find it disappears. So you can click away, right-click on it again, go back to Move with Triad. Now, I find if you click on a direction and then click on it again, and then right-click, you'll have this additional triad menu. So again, right-click on the component, go to Move with Triad, and this time I might select the plane, click once, click again, and then right-click, and you should see this menu. If you don't see it, just try clicking once, so go to Move with Triad and just right-click anywhere on the triad. So in my situation, it doesn't seem to work that way. I have to actually double-click on one of those parts and then right-click. This menu allows you to specify values for the movement. The Translate XYZ box allows you to specify a coordinate location for the component. The Translate Delta XYZ can be used to define exactly how far from the current position you want to move. There is also an option to enter angle values for the rotation. By default, the triad is aligned with the axis of the assembly coordinate, but other geometry can be used to modify its alignment and position. You can drag the origin of the triad to move it to a new position and then make your component adjustments from that position, or pick from options in the right-click menu, like Move to Selection and Align with Selection. Align with Selection will realign the triad axes, whereas Move to Selection will realign the triad to the geometry picked and also move the triad. If you right-click on the origin of the triad, you can also choose to align to the component's origin or the assembly's origin. Clicking on the screen away from the triad will clear it from view, and it will always return back to the default position when accessed again. For even more options on repositioning components, the Move Rotate Component tool can be used. This tool can be accessed in a few ways. One is going up to the Tools menu, and then Component, And here it is actually divided into two tools, but they are the same tool. It'll just access directly to the either rotate or move component. You can also right click on a component and then expand the menu by clicking on the double arrow down the bottom and then going to move component. Or in the command manager, when working in the assembly environment, you'll see the move component tool. The toolbar lists the tool in two different ways, move component, and if you click on it, rotate component, but in reality, they are the same tool. To activate the move rotate command, simply click on it. And if you wanted to switch to the rotate tool, you simply click on the rotate group box here, or you can go back to the move by clicking on the move group box. So you can switch between the two tools by using these two group boxes here. With our Move Component tool activated, you'll notice this drop down here. Dropping this down will give us some additional options, and these options will allow us to define specifically how we want to change the position of the part. Also included in these options is ways of having our components in the assembly interact with each other. Collision detection will identify when components collide and has the option to stop at the collision point. So if I have this option enabled and I drag the part, as soon as they touch, they're going to stop. The option for physical dynamics allows one component to push another. So as I drag this part across and it touches, it's going to actually interact and move it out of the way. The other option for dynamic clearance can also be turned on to identify the clearance between the components while moving. Most of the advanced options relate to the behavior for collision detection and physical dynamics if needed. But another important option to be aware of is this configuration checkbox. If multiple configurations exist within the assembly, moving components will affect all configurations by default, unless you have this option checked. If the option is checked, then it will only affect the configuration you currently have active. Now let's move into part 2 of this lesson and go into a bit more detail on the information you can get from the Move Component tool. When working with an assembly that has moving parts, it is often important to know if parts will interfere with each other while in motion. The Move Component command includes options to detect collision to help identify if, when, and where collisions between components occur. To use these additional tools, let's go back to the Move Component tool and click on it to activate it. Then in the Property Manager, turn on Collision Detection. In the options, you can also select all components for collision detection, or you can select specific components. Selecting specific components limits the scope of the evaluation, but it can help with the computer performance when dealing with large assemblies. To select components, click on these components, and then in the options box, make sure it is activated by clicking on it, and then just click on the components that you wish to use the collision detection on. Once you have finished selecting the components you wish to use, just click on Resume Drag to continue using the Move tool. You can also limit the scope of detection by clicking Dragged Part Only, which will mean that collision will only happen on the part you are actually moving or dragging or rotating. If you enable the Stop at Collision option, SolidWorks will stop the parts moving whenever they collide with each other. If this is not enabled, then it will just rotate freely. And if we re-enable this, which is what we kind of want anyway, as soon as we start moving the component again, it's going to stop at where those parts collide. Under the advanced options, there are more options to assist with easily identifying the area where components collide. The default selections are to highlight the component faces and play a sound when a collision takes place. The option to ignore complex surfaces can be enabled to check only for collisions between planar, cylindrical, conical, spherical, and toroidal surfaces. Once the options have been set to our needs, you can use the left mouse to click and drag the components of the assembly, and this way we can clearly identify where our collisions are taking place. In this assembly, we can see our two couplings are interfering and causing a collision. So let's make some modifications to these parts so that we can have a more freely moving component. First, we're going to click OK to close the Move Component tool. We'll begin by editing the bottom coupling, so clicking on that and going to Edit Part. This way we can edit the part directly in the assembly. And we're going to add a chamfer to these internal edges. So by going to chamfer, either by using a quick menu S on the keyboard to access, or if you can't find it, go to the Features, Fillet, drop that down, go to chamfer. We're going to use a 2mm chamfer and just select this internal edge and this internal edge. You should see a preview appear. Clicking OK. So we now have a chamfer edge on that one. We can exit that part, and then editing the top coupling by again clicking on it, go to Edit Part, go back to our chamfer tool, making sure 2 mil is selected again, and selecting those internal edges and clicking OK. And then exit the edit part, and we should be able to freely move our component now. So to verify these parts no longer interfere, we need to again go back to the Move Component tool and use collision detection. So we can activate our Move Component, turn on collision detection. We're going to go to these components and then pick our 2 coupling components, stop at collision, and then resume drag. So if we rotate this, we should find there is no longer any collision. Now that we have a working model, we may want to know the clearance between these 2 edges. And the dynamic clearance checkbox allows you to do this. So first we click on dynamic clearance. Like we had to select our components before, we again need to select our 2 components for the dynamic clearance. So we can click on this box. We want the 2 couplings again and go to resume drag. With the dynamic clearance option enabled, as we click and drag, you can see in the graphics area our minimum clearance. And also in our options, there is a numerical value. Once our part has done a full rotation, and that way it can detect what the minimum clearance is, we can see this is, in our case, 0.54 millimeters, is the minimum point of clearance. An additional option we can use is to define a clearance value for which we want the components to stop. So we can do this by clicking on Stop at Specified Clearance. We can see our minimum is 0.54 in a full rotation. So let's make this 1 millimeter. And then if we drag it, it's going to stop at that point where it is 1 millimeter. If we were to try that again at say 1.1 millimeters and just pushing tab to sort of move on from that option and then dragging, it's now going to stop at 1.1. If you have an option where you might say 1 millimeter, go to drag it, you may get an error dialog come up. Just click OK to that. It just may mean that where it's positioned currently, it's too hard for it to detect a collision. So you might just need to move it back to a larger area and then change your clearance and then try moving it again. So that completes this lesson. It's an important tool to learn because if you are doing the exam, the SolidWorks Associate exam, you will need to use this tool to detect a clearance of an assembly and then making sure you can find the minimum clearance value and inputting that as your answer. And it's done in a few sections of that exam and possibly the professional exam as well. So that's the end of this lesson. Don't forget to subscribe to the channel, like the video, and we'll move on to the next lesson. When building an assembly in SolidWorks, it's important to constrain components in a particular way so they act like a mechanical system. To do this, we use a tool called mates to create relationships between components, parts, or parts and the assembly. There are many types of mates available to help constrain components, including the standard mates subset. Standard mates are any of the following types of mates in SolidWorks. They are the coincident mate, parallel mate, perpendicular mate, tangent mate, concentric mate, distance mate, angle mate, and a lock mate. In this lesson, we will use an assembly containing a block and a rivet to demonstrate each of these 8 mate types and how they can be used to constrain the components. Keep in mind these files are created in SolidWorks 2020, so you'll need 2020 or newer to follow along and use these files. As always, don't forget to subscribe to the channel, like the video, and let's begin the lesson. Here we have an assembly with a block and a rivet. The block is fixed in place while the rivet is free to move around. We will use these 2 components to demonstrate the standard mate types available. Before beginning to add mates, let me first detail which selections can be made in order to add mates to these components. You can select 2 faces or surfaces, a line or a linear edge. You can select planes, an axis or temporary axis, a point, a vertex, or a coordinate system, and finally an arc or a circular edge. The selection entities determines which type of mates are available for the components, so choosing the correct entities is an important part of properly constraining the components. To begin constraining these 2 parts, we first need to activate the Mate tool. The Mates tool can be found in the Assembly tab of the Command Manager, under the Insert drop-down menu, or by pressing S on the keyboard to bring up your shortcut menu. Now the shortcut menu can be customized, so it should show there by default, If not, you may have to customize it to show. So the Mates tool has an icon of a paperclip. When you click on it, the Property Manager updates and a list of available options becomes available. There are 4 main tabs: the Standard tabs, the Advanced Mates, the Mechanical Mates, and the Analysis. This lesson will just focus on the settings found in the Standard tab and leave all the other options in the other tabs to another video in the future. In the Standard tab, the Mate selection box displays which faces, planes, edges, or points are selected to mate together, along with a button to toggle multiple mate mode, which is used for more advanced mate scenarios, so it will be left as a topic for a future lesson. Below this is a section for the mate types, which are the mate options that we'll focus on in this lesson. Further down is another box called Mates, which displays the current mate that's being created, and an options box with selections that help display and control mates. Leave all these options at the default settings and scroll back to the top to the Standard Mate selection. The first mate is the Coincident Mate. This mate constrains 2 components to have their faces, edges, or other selected entities remain coinciding with each other. This doesn't mean that the components will always remain in contact, but the selections will always coincide. To demonstrate this, click on the Coincident Mate to activate it. Select the top face of the block, and then rotate around so we see the underside of the rivet, and click on the bottom face of the rivet. You should see that the rivet moves into place, so it is now coincident. You'll also notice a context toolbar appear with other available mates based on these selections. In this context menu, there are also buttons to flip the mate alignment and to undo the selections. And finally, there is a green tick to complete the mate. If the parts orientate incorrectly when the entities are selected, use either the Mate Alignment buttons in the Property Manager or the Flip Mate Alignment button in the Context toolbar. When you complete a mate, the Property Manager stays open. This allows you to continue adding mates without having to reactivate the tool every time. If you have finished adding mates to your assembly, you can then click on the green check mark in the Property Manager to complete and finalize the Mates tool. So if we now click and drag on the rivet, you can see that the part can freely move around, but the faces that we selected are always going to be coincident with each other. Also, whenever you add a mate, it will be added to the mates folder, which you can find in the Property Manager on the side. If you click on the small arrow to expand it, you'll see a list of the mates you have created. From here, you can edit or delete or make changes. So let's click on this coincident mate that we created, and in the menu that pops up, go to Edit Feature. So this is how you'd edit an existing mate. So we want to change this to a different type of mate. So in our mate selections, we can right click, go to Clear Selections, and now we're free to start again. So let's now try the Parallel Mate by clicking on it to activate it. The Parallel Mate forces 2 selected entities to always remain parallel, such as faces, axes, or edges. With the Parallel Mate selected, click on the front face of the block and the top face of the rivet. The rivet will move in place and these 2 faces will now be parallel to each other. Click the green check to accept and then click the next green check to close the Mates tool. So let's click and drag on this rivet so it's outside of our view a little bit, and then click on the X in the view triad, and you can see that these faces are always going to be parallel to each other. We right click and try and rotate the component. You can see it's still going to move and rotate slightly, but only in a way that those 2 faces that we selected are still going to remain parallel to each other. Let's go back and edit the parallel feature, clear the selections, and the next one we will look at is the perpendicular mate. The perpendicular mate performs similar to the parallel mate, but with the exception that the selected entities are constrained to remain perpendicular instead of parallel. For our selections, let's choose the same 2 faces, so the front face of the block and the top face of the rivet, and this time it's with the perpendicular mate selected. So the rivet will move into place and it will now be constrained perpendicular. So click OK and OK again. So you can see these 2 faces are now going to be perpendicular to each other. The next standard mate type is the tangent mate. First, let's delete the old mate we just created. So if we go to the mates folder, and I think you can, and right click on it, go to delete for the perpendicular mate that we created. And then we may just need to move this one out a little bit just to create some room, see what we're doing. So the tangent mate constrains two selected entities to remain tangent to each other, such as two faces or a face and an edge. Before creating the tangent mate, first create a coincident mate between the bottom of the rivet and the front face of the block, as this will help demonstrate how the tangent mate works. This time I'll show you another way of creating mates, which is by making the selections first. So without the mate tool actually activated, let's select the cylindrical face of the rivet and holding down Control and then select the top face of the block. And then you can let go of Control. We can then go up to our mate tool and you can see the rivet move because it's going to use a tangent mate. So it knows based on our selections it needs to create a tangent mate, and our selections already input because we made those selections first. So the tangent mate was created just based on our selections because SolidWorks is smart enough to know what is the most useful mate type to use based on those selections that we make. So in this case, it knows because we have a cylindrical face and a flat plane, it's going to assume that a tangent mate needs to be created. And in some instances, that is going to be the only mate you can create. As you can see, these other selections are grayed out. So let's make sure our parts are properly aligned, and we can use this button here. It's not going to matter too much. We're just going to have it sitting on top. If you sort of rotate around, you can see it's on the top here, and then click on the green check mark. So if we now drag this rivet around, we can see that it's going to always be in a tangent relation to the block. So click OK and expand your mates folder. You should see the tangent mate is still there. What we need to now look at is the concentric mate. So we're going to demonstrate this by editing the tangent mate. So we can click on that. So we can click on that and go to Edit Feature. So right click in this box and go to Clear Selections and click on Concentric Mate. So concentric should now be activated. And a concentric mate constrains two circular sections to share a common central axis. To help show this, we can turn on temporary axes for the components by clicking on this visibility icon and dropping it down. And in here, you'll want to show View Temporary Axis. So if you click on that, you'll see that anything with an axis like a cylinder or a circle, semicircle, etc. is going to have a temporary axis. So that's just an axis through that point. And we can use this just to visually see the points a bit easier. So with our concentric mate selected, we want to click on the cylindrical face of the rivet and this cylindrical face of the block. And we can see the rivet has moved into position to now have a concentric relation between those two selections. You'll notice in the contextual menu, there's also an option for this particular mate called Lock Rotation. And you can also see it over here just under the concentric mate, Lock Rotation. So what this is doing, if you enable it, is as we drag this around, the part is not actually going to be able to rotate. So you're kind of eliminating the need of an additional mate to lock that rotation into place. You can kind of combine two mates into one that way. So it's useful in particular when you're doing concentric mates to lock the rotation down as well and minimize further steps. Let's go back to our visibility options and just turn these temporary axes back off. So they should no longer be showing. And the next mates we're going to look at are the distance and angle mate types, which both require numerical inputs to define the mate. And then finally, we'll look at the lock mate type. The distance mate constrains two selected entities to remain a certain distance from each other, such as two faces or edges. Let's go back into our concentric and edit feature, and then right click in the dialog box and clear selections. So we're now ready to continue a new mate. The one we want to select is the distance mate. So you click on that to activate it, and you'll notice a numerical value is required for this as well as our selections. For our selections, pick the rivet shaft, the base of it, and then the top face of the block. You'll see that it should move into place. And currently it is set to 20 millimeters for the distance. So we could change that to 100 millimeters, push enter, you'll notice it moves out. So it's always going to be almost like a parallel coincident mate, parallel mate, but it's going to have a distance between those faces as well of what we specify, in this case 100 millimeters. But you could make that anything, 50 mils, etc. And you can also flip the direction of which way it is going. So in this case, it's going down 50 mils. If we untick that, it's going up 50 mils. You can also adjust the alignment by clicking on this one here, Flip Mate Alignment, which is going to flip it around. So now it's almost as if we click the flip dimension. But the difference is it's actually orientating the part or the component in a different way as well. So if we click OK to that and click OK again to close, so we can see our components are both free to move. Well, the rivet is free to move, but if you look at it in a certain direction, say in this direction, it's always going to be 100, or in this case, sorry, 50 mils away from those two faces that we selected. The last standard mate type that forces alignment between parts is the angle mate type. This mate constrains two selected entities to maintain a specified angle between them, such as two faces or two edges. To demonstrate the angle mate type, first we need to suppress the coincident mate, which we can do by clicking on it in the feature manager tree and then going to suppress. So this way you can suppress mates, so you don't have to delete them if you don't need to. You can just suppress them, and therefore this can now move around without that distance constraint in place. So what we could do is now create a new mate by going back to our mate tool. And we're going to select the top face of the block and the bottom face of the rivet again. But this time we want the angle mate selected. And we're going to put in a value of 60 degrees, push enter. And you can see that the rivet is going to move out of position. So it's now 60 degrees of those two faces to each other. If the two components are intersecting when the angle mate is applied, we can use the mate alignment options in the property manager to properly align the parts, as well as flip the dimension box around as well. So we can flip the dimensions, but we can also adjust the alignments. Notice in the mate selection group box, there's a selection window available to select a reference entity to help control the orientation of the angle mate. This can be a plane, planar face, a linear edge, or a reference axis. This reference entity must be perpendicular to both selected faces. There's also a button you can click to autofill the reference entity. Clicking this button allows SolidWorks to automatically search for and select a reference entity. If we click this button, SolidWorks is going to put a little pop-out notification showing it was unable to detect a reference entity. This is because the positions of the parts don't allow a reference entity to be perpendicular to both selected faces. So to continue, let's click on the green check to complete the angle mate. And then we're going to add a parallel mate between the front face of the block and the flat face of the top edge of the rivet. And this will just complete our assembly construction. So we can click OK and click OK again. So what I did with that parallel mate, and when you highlight a mate, you can also see what entities are selected. So we can see these are the two faces we selected with our parallel. So the parallel is going to help line up the two faces, whereas the angle mate is applying in this direction. So you have this kind of angle happening. And our distance mate was no longer required, so we suppressed that, but we could actually just right click on it and delete as well if you really didn't need it anymore. So the final standard mate type to look at is the lock mate type. This mate restricts any movement between two parts, making them fixed in space relative to each other. To show you this mate, let's both delete these two mates that we created, the angle and parallel. So there's no mates, and it should be able to freely move around. We're going to go back to our mate tool, and we're going to select the lock mate type. And for our mate selections, we don't have to actually pick faces or edges or anything like that. We're just picking components. So we're going to click on the rivet and the block, and these are our two selections. We're going to click OK again. And now if you try and move this around, it's not going to move. It's going to have a little pop-up saying the selected component is fully defined. It cannot be moved. And the same is going to say for the block. This is because you've set a lock mate type. Now with lock mates, you don't use them too often. I personally haven't had a use for them at all. There probably is some cases where you would, because it's kind of a cheating way. It's just going to lock everything in place where it is. So you can see our rivet is really undefined. It's just kind of floating in space, but we cannot move it because of that lock mate. So it's more practical to put in mates that have some sort of relation to each other, like the faces are parallel to each other, or they're a certain distance away from each other, or they're coincident to each other. You want those type of mates, so you kind of build them in place, kind of like a Lego set, place them and you place them and you build this assembly through these constraints. And it's not often where you would just select two components and just lock them in place. I'm sure there is a use for it, but I haven't come across a use for it myself. But obviously it is there for a reason. Just don't depend on it, I suppose is what I'm trying to say. It would be very poor practice to go and open an assembly and everything is just locked in position and that's all there is. That would be a really bad assembly if I ever opened one like that. So this brings us to the end of the lesson for the various types of standard mates. There are more type of mates available, such as mechanical and other more advanced mate types, but this is just the basic standard mate types. When building assemblies in SolidWorks, it is common practice to take components, bring it into the assembly, and then constrain them to each other using relations and mates to kind of build the overall assembly. And you can also bring in assemblies into another assembly and constrain those assemblies together. So when you're modeling in SolidWorks, it's really this kind of layer approach on top of each other and constraining things and then building that relation between them. And because it's such a vital part, I recommend you sort of get familiar, at least with the standard mates, because you'll often just use them the most, but then start to explore the other mate types like the mechanical types and such. I hope you have enjoyed the lesson and have learned something. Don't forget to like the video, subscribe to the channel, and I'll see you in the next lesson. Just like parts, assemblies can also have configurations. They can be created through a design table or created manually. While part configurations tend to focus on dimensions or features, assembly configurations tend to focus on components, mates, or assembly features. They can be used to represent different versions of a model or a powerful way to increase performance, especially on larger assemblies. So in this lesson, we are going to take a look at using configurations within an assembly. We are going to create a second version of this assembly, replacing the one-piece crank arm with a three-piece subassembly. You can download the lesson example files from the link in the description of this video. You will need SolidWorks 2020 or newer to open and use these files. Don't forget to like the video and subscribe to the channel to show your support, and let's begin the lesson. Once you have downloaded and extracted the lesson example files, open the CH03L05 assembly file, which is the main assembly file and should look like this, which you see on screen now. The main thing we're trying to accomplish is to replace this one-piece crank arm with a three-piece sub-assembly crank arm by using configurations within the assembly. To access the configurations, look over on the side panel here. If you need more space, you can just drag it out and you want to click on the configuration manager. In the configuration manager, you should see our only configuration currently is the default configuration. I want to first point out a couple of options and settings within this default configuration. You can access the properties for the configuration by right-clicking on the default configuration and going to Properties. Here you can see some menu items such as changing the configuration name, adding a description, using in bill of materials, etc. But what we're interested in is the advanced options down the bottom. These options here tell SolidWorks how to handle any new features, mates, or new components that are added when you are working with other configurations. This checkbox will suppress new features and mates in this configuration when they are being added to other configurations. Likewise, with the suppress new components options, any components we add while working in other configurations will be suppressed in this configuration. To demonstrate the effect of these options, let's check the suppress new features mates checkbox, but leave the suppress new components checkbox cleared. So we should have a tick in the top one, but these other two or other three are unticked. Exit the property manager by clicking on the green check mark at the top to select OK. Our next step is to add a new configuration, which is going to be adding in the three-piece subassembly and then constraining it in place using mates. We can add a new configuration by right-clicking on the top menu part here and then going to Add Configuration. you'll see the menu pane pop up, and in here you can also see our advanced options, but we're not going to worry about that. What we're interested in is giving it first a name. So we're going to call it version 2 because this is going to be our second configuration. You can add a description if you want some more detail, but in this case we can just leave the rest blank. Click OK to accept. And you should see we now have two configurations, our version 2 and our original default configuration. You can see which configuration is the active one, as it will be kind of highlighted or normal looking, but any other configurations will be grayed out. You can only have one configuration obviously activated at one time, and you can switch between configurations by simply double clicking on one of the other configurations. So if you had multiple configurations, you can double click on them and move between them. In this case, we just have the two, so we can swap between them by just double clicking on them. So to continue on, make sure you double click on version 2 to make that active. You should see it is active. The default will be grayed out. So in our version 2 configuration, we want this single arm crank piece to be suppressed, and then we want to add in the 3-piece. So to suppress this crank arm, we can just click on it. So the menu pops up and go to suppress. Again, to demonstrate the difference in configurations, as this is now suppressed in version 2, if we were to switch to default, you can see that the single piece crank arm is activated in this. So it's not deleting it in any way, it's just suppressing it, so it's hidden from our version 2. So go back to version 2, make sure that is active, and we'll continue on. And we are now going to add our 3-piece subassembly. So go to Insert Components. You should see a menu pop up and browse to the location where you extracted the lesson files. You're looking for the 3-piece assembly and insert that, and just drop it anywhere you like, and the menu should clear once you do that. We will need to lock this in position, as currently this subassembly is free to move around. We can do that by using mates. So we just need to add 3 mates so we can constrain this 3-piece crank arm to the main assembly here. The first mate I'm going to create is the concentric mate. So we're going to select this, and instead of rotating under, you can actually just right click on this and go to select other. By moving around, we can select the internal concentric edge we need. So that's just a quick way, instead of having to rotate and click underneath like that. We need this to move out of the way a bit, so we can move this up. Next mate we want is this face and this face. And the final one is this face and this face. Click OK. So you should have added 3 mates. And you can test this by simply moving it around, and it should all function correctly now. And it should have moved the crank arm out of position. With all the mates required being added, let me show you a way of selecting configurations directly. What I mean is that this subassembly was made using components that also have more than one configuration. Because we have multiple configurations at the component level, we may want to specify which components to use in our version 2 assembly configuration. To do this, we click on the crank knob, let the contextual menu pop up, and you should see a little drop-down menu here, as this component has multiple configurations already applied. So we can drop that menu down and click on the slotted knob. And next to this, you also have another drop-down menu, which allows you to select where this configuration is going to be specified. So you can click this configuration, all configurations, or specify configurations. In this case, we just want to be applying it to the version 2. So we're going to say this configuration and then click on the green check mark. And you can see our slotted knob is now part of our version 2 configuration. So keep in mind that this drop-down menu only appears because this subassembly has configurations inside it. And more specifically, that component has multiple configurations. If you click on it again, you'll see that this has the drop-down menu. But if you click on another part of the assembly, say the crank arm here, it doesn't have that drop-down menu because it's only the handle knob that has the multiple configurations. Another way of selecting configurations of our subassembly within our main assembly is to go back to our feature manager tree, find the 3-piece assembly and click on it, and you can see that the drop-down menu is also here, so we can make our configuration adjustments here. You can also click on the component, and that will also show if you were to click on one of the other components, as they don't have multiple configurations set up, you wouldn't see anything. So that's another way you can control the configurations of subassemblies as well. So let's go back to our configuration manager and switch to our default configuration by double clicking on it. And straight away, you'll notice we have an issue where our 1-piece crank arm is showing as well as the 3-piece crank arm. If you recall, when we looked at the properties for the default configuration, we left the Suppress New Components option cleared. This has resulted in the components we added in the version 2 configuration being unsuppressed in the default configuration. However, we did check the box to suppress new features and mates. If we go back to our feature manager tree and then go down to the bottom and expand the mates subcategory, you can see that our 3 mates that we created to constrain this 3-piece subassembly are suppressed in our default configuration due to those advanced property options that we selected. If we click and hold on our 3-piece subassembly, we can drag it around, and this is because those 3 mates are suppressed in our default configuration. So you can see the settings are important to consider when you create assembly configurations, so you control how new features, mates, and components are handled in each configuration. To finish off this lesson, let's make it so the default configuration only contains this 1-piece handle. We can do that by simply suppressing our 3-piece subassembly. So by clicking on our 3-piece subassembly, or even doing it in the feature manager tree itself, going to suppress, you can now see that is suppressed in our default configuration, and only our single crank arm is showing. If we go back to our configuration manager and switch back to our version 2 configuration, we can see that it contains our 3-piece subassembly, and if we go to our default, it's only going to contain our single arm configuration. The final thing we might want to do is rename the default to version 1 so it keeps it in better order. So we can do that by right-clicking on it and going to rename tree item, and then we'll just give it a name of version 1. Another way you can rename is either by having it highlighted and clicking F2, or just slow double-clicking on it. So as you can see, assembly configurations can be a very powerful way of creating your models. It allows you to create multiple configurations within the one model, and this can potentially save you time or performance, especially in larger models. But when you have a model that is so similar like we have in this design, and you have one part that may be changing through different stages, it may be more beneficial to create configurations showing these changes and just suppressing the parts that you don't need through the different configurations. This way you don't have to have multiple models or assemblies showing each different configuration. And then you'd have your one main assembly with all your different configurations. You can have many different types of configurations set up and simply click between them to make those changes to show to your employer or clients or whatever it is. I also demonstrated that you can control configurations of sub-assemblies within your main assembly. So this way you could have smaller sub-assembly in that main assembly that has those multiple levels of configurations as well, which is then controlled in your main assembly. So that brings us to the end of the lesson. I hope you have learned something new, and don't forget to like the video and subscribe to the channel to show your support. Assembly design tables allow you to create and control configurations of the assembly using a built-in spreadsheet within SolidWorks. They are used to control suppression of components, mates, assembly features, configurations of parts, and numeric values of distance and angle mates. The assembly design tables are then used to create and document the assembly configurations. The options and procedures are very similar to a previous video I did on part design tables. So if you haven't seen that lesson yet, I recommend you go back and just review that one first. In this lesson, we are going to use an assembly design table to quickly create different configurations of it, which represent different versions of it, all within the one assembly file. Check in the description of this video to find a link to the exercise files if you'd like to follow along. These files were created in SolidWorks 2020, so you will need SolidWorks 2020 or newer to be able to open and use these lesson files. Don't forget to like the video, subscribe to the channel, and let's begin the lesson. First, begin by extracting the lesson files onto your computer somewhere that you can find easily, and then opening the main assembly file. The main assembly file should be called A001 Trolley Final. Our goal will be to add several configurations to the assembly using a design table. We will begin by creating the configurations that represent the handle at different heights. If we look closely at the handle, we'll see that there are different holes which will adjust the handle to different heights. In this assembly, there is a distance mate that is used to control the height of the handle. Switch over to the Configuration Manager tab, and you can see we currently only have the default configuration. To create a design table, go to Insert, Table, and then Design Table. In the Properties box, make sure that Auto Create is selected, and all the other options can just be left at their defaults. Click OK, give it a moment, and you should see a pop-up come up asking to select a dimension. The dimension we want to use is this D1 distance 2. So highlight that by clicking on it and then click OK. After another moment of loading, it should all be ready to go now. And to give ourselves a bit more room, we can just drag this out by carefully picking the corner and then dragging it out. And it's also worth noting that we can still zoom in and out in the graphics window and also pan around as well. Just make sure you don't double click outside of the table because that will exit the design table. So what you can see here is an Excel table inside of SolidWorks, and we use this to control our configurations. Because it is actually using Excel, if you are familiar with that program at all, it works the same way as how Excel works. So you can add all your cell data, use equations, copy and paste, anything like that will work in here as well. So for example, we might want to give ourselves a bit more room here. We could just drag these out to expand the cells a little bit. And what we want to do now is this column is going to be our configurations. So we can add some names in here to identify each of the configurations. We will do this by doing, the first one will be setting.50 and then setting.100. And because this is Excel, we can just drag these two cells and drag the bottom corner to auto fill out more cells. We only need one more in this case, so just add an additional setting.150. The table has the distance dimension assigned already, which is our leg height, and this is going to control the height of this handle. Each of these holes are intervals of 50 mils. So what we want to do with these extra configurations is make the handle step up in increments of 50 mils. The first thing we can do is just highlight this cell and again drag it down to auto populate the rest. As you do with Excel, we can use equations, so we can say equals leg height plus 50, and that's going to add 50 mils, and then plus 100, and the final one will be plus 150. So that just means this is the default, and then it's going to plus 50, plus 100, plus 150 for each step. It's actually going to retract the handle each step. Let's take a look at the configurations we have just created. So if we click outside of the design table, it will exit out of the design table. You'll see a pop-up saying that these configurations have been created. You can click OK to that. And we should see that our configurations are here, 100, 150, and 50. For some reason, 50 is gone on the bottom, so we can just click and drag this up to move below the default, and that will get our order back in the right. We can activate each of the configurations by double clicking on them. So we can go setting 50, and you can see the handle moves down. Setting 100, it's moved down again. Setting 150, and it's moved down to the final position. And we will just go back to the default, which will take it back to the beginning. We have so far created a design table that will represent various handle heights due to changing the distance mate by increments of 50 mils. Next, we'll create another configuration of this assembly to show how components can be either suppressed or resolved. To go back to an existing design table, make sure you're in the Configurations tab, and you should see a Tables folder with a little arrow next to it. If you click on the arrow, it will expand it to show any design tables, and we can see our design table there. Right-click on it and go to Edit Table. Give it a moment to load. And if you see any pop-ups like this one come up, you can just click OK or cancel. Doesn't really matter. We don't need to change anything with that. And once it's loaded, we will see our design table is back on the screen. For this upright trolley positioning, we want to suppress these two smaller caster wheel sub-assemblies as they're not really needed when it's in an upright position. To do this, we click on the next empty cell here, and then we double click on the component or sub-assembly, and you can see that it's automatically filled it in for us, and it's set the first one default to resolved. To make things easier, you can also use the abbreviations R for resolved and S for suppressed, but they need to be in capital letters. As all our configurations here are for when the trolley is in an upright position, and the caster wheel sub-assembly is not meant to be visible, so they need to be suppressed. We can then go through and just put a capital S in each of these configurations to make it suppressed. You may also note that there are actually two sub-assemblies of this caster wheel, two instances of it, if you will, and I'll show you how to deal with that in a moment. But first, we are going to suppress this first one. So we have done that. Click outside of the design table. It will take a moment to load, and we can see that the caster wheel is now gone. But if we change between our settings, the handle moves, and the caster wheel is still gone. Like I was saying though, this caster wheel also needs to disappear. So let's see how we can remove that one as well. We can do that go back into our design table, give it a moment to load, and then cancel any pop-ups if they appear. What we could do is do the same process again, go in the next cell, double click on a component and suppress it. But you can actually suppress multiple or resolve multiple instances of a component or subassembly. We can do that. If you have a look in this field here, you can see there is a 1 at the end of it, and the 1 represents the number instance of that component. So what we can do, if you double click on that cell, just put a comma and then a 2. And you could do this for multiple instances if you wanted to, like 3, 4, 5, 6, etc. In this case, we only have the 2, so it's 1, 2, enter. You can see it's updated, and then just click outside of the table again. And you can see that both are now suppressed. If we zoom in a little closer, we can also see there are a couple of nuts that weren't exactly part of that subassembly and were just separate components, and we should probably suppress those as well. So let's again go back into our design table, allow it to load and cancel any pop-ups that come up. So we can just click OK or cancel to this pop-up. Don't need anything there. So in this case, we will have to use the new cell. So we can click on the cell, zoom in a little bit, double click on this one. So that is added it, and we want them suppressed so we can add our capital S for each instance or each configuration, sorry. And then we want a comma 2 at the end of this one as well, as we want to suppress both of these in the one data set. And then double click outside, but we can see that only one of them has suppressed. So what's going on here? Well, it's likely that this nut has been used in other areas, like maybe here or down here at the wheels or wherever, and the instance we defined as number 2 is not actually this one here. So how do we go and find what the instance number is so we can correct this? Well, if we go back to our feature manager design tree, if we need a little bit of room, we can just sort of drag this out a little bit. You can simply click on the component that you're trying to find, and it will highlight in the feature manager tree. So here we can see the name of the part, and then in our brackets we've got an instance number, and we can see it's actually number 3. So we should be putting 1, 3 so both of these ones hide. Again, we go back to our design table now that we know which number we need to fix this to. Let it load, cancel any pop-ups if they appear, and then we can click on this cell and then just go back in, change it to 1, 3 this time, exit out of the design table, let it load, and you can see now they are both suppressed. If we go back out to an isometric view, you can do that quickly by going Control-7, and that will zoom extents into the isometric view for us. And we can just check our different configurations, make sure those caster wheel subassemblies are hiding. I've had an error on this one. I'm just going to say save all in this case, and then just changing between those configurations, we can see that the handle is moving correctly and the caster wheels are not showing on any of them because this is the trolley in its upright position and it doesn't need those subassemblies. To finish off, let's just create one more configuration for this design. This final configuration will rotate the handle by 90 degrees so that it can be used in a flatbed design. Again, we go back to edit our design table, allowing it to load, and then cancelling any pop-ups that appear. The first thing we need to do is put a name in it for our new configuration. We are just going to call it flatbed. And to keep things simple, we can just copy and paste one of our cells, one of our data sets as such. And then click outside our data table, click OK to any pop-ups, and allow it to load. So first we need to activate the configuration flatbed that we just created, so we can double click on that. Currently this configuration is just a copy, but we want the handle to fit in the other holes. So to do this, we need to suppress the mates that are being used for its current positioning. We do this by clicking on the handle. Without moving the mouse, a contextual menu should appear, and then in this menu you want to click on View Mates. And these are the mates that we will need to suppress. So again, if we hold down Shift and then click on the end, or just clicking Control to select all of them without moving the mouse. So again, we see the contextual menu pop up and we want to suppress all of these. And then we can just exit that dialog. We should be able to move the handle around like I am now because those mates have been suppressed. We need to add some new mates for this configuration. So we can go to the Mates tool. We can use a couple of concentric mates, and we're going to need this to flip around. Go OK. We need another concentric mate for this side. Click OK. And to finish, we can use a coincident mate from this surface to this surface, click OK again, Control 7 to zoom extent, and this is our new configuration for our flatbed design. Now that our flatbed configuration is complete, we should be able to toggle through all the configurations that we've created in this lesson. Let's give that a shot. We can double click on default. You can see this is created like this. Our setting 50, double click on that. Setting 100, setting 150, and finally our flatbed. Another thing we need, of course, in our flatbed design is for the caster wheels to be resolved so that they're showing, because this will be laying down in a flatter position and it needs the wheels in this area. I think this might be the final time we go back to our design table. So right click on that, go to edit, allow it to load, cancel any pop-ups. So what we want is our subassembly caster wheels, which is this one. Instead of being suppressed, we need those to be resolved, which just means they will show. And we also need the nuts to be resolved as well. Click outside, allow it to load. And you can see the caster wheel, subassembly, and the nuts are both there. And if we change to or activate one of the other ones, it disappears and it flips the handle around. To take your assembly design tables to the next level, you can also specify configurations of any components or subassemblies that are used in the main assembly, all from within the one design table of your main assembly. As this video is getting a little long, I'll leave that for another time, but you may want to take a look at it yourself. That brings us to the end of this lesson on assembly design tables. Another powerful tool within SolidWorks that allows us to create multiple versions of a design, all within a single assembly file and all controlled simply through an Excel database. Keep this tool in mind as you progress and advance your skills in SolidWorks, because I am sure there are going to be opportunities where you can use these design tables in your own work. If this lesson has been valuable to you, then please like the video and subscribe to the channel, and that way you can be notified when the next lesson is released. Have a quick break and then come back for the next lesson.